So I'd like to ask you to take a seat. And I'd like to start introducing this session. Today in this opening meeting, we're going to tackle a technical topic which is very close to the AGI Federation agenda in terms of future developments and strategy, which is the integration of large data and computing in a computing continuum and data continuum that will support data-intensive science in the coming decade. So with this opening plenary, I hope we will have already a chance with the keynote, the first keynote, to learn about how this imperative problem is going to be tackled in Destination Earth. So we have a very specific initiative that the European Commission is supporting. But after the keynote, we will have an interesting panel with also other representatives. So we will hear the voice of other scientific disciplines that are being confronted or will be confronted with similar issues, having to tackle a data deluge with exabytes of data to be reduced, processed, and analyzed. So with this opening session, we hope you will learn about what is being done by major initiatives, not just at the European level or community level, but also at the national level. So in the panel, we will hear the voice of a few national representatives involved in similar initiatives at the national scope. And I hope that after this session, we will also be able to connect and engage and maybe also establish new technical collaborations, and I'm sure there will be lots of opportunities. To conclude my introduction, I'd like also to mention that through the InterTwin project that some of you may know about, we are also cooperating with Destination Earth and specifically with ECMWF on architecture, sharing designs, but also technical solutions that may be relevant to the Destination Earth implementation and which are relevant also to the AGI Federation. So also in the context of InterTwin, we will have a very nice link and opportunity of having a number of user communities that you will hear talking today, also working thanks to the funding program of the project. So with this fairly long introduction, I'd like to welcome our keynote speaker. So I will immediately have a challenge. You may know that I've been living in the Netherlands, but I'm famous or infamous for having no Dutch. So our speaker is Thomas Hennen.
Yes, perfect.
Close enough. So Thomas is the person that is leading, if I understand correctly, the cooperation with external initiatives around the technical architecture of Destination Earth. So I really look forward to this presentation. So the floor is yours. You have to connect your laptop.
That should be
It's done.
all right. So this should work normally. It is working. All right, thanks Tiziana, and welcome everybody. It's great to have a little bit more time to talk about Destination Earth, to be able to give a keynote to dive a little bit deeper in some of the topics. We'll give a brief introduction about Destination Earth and what we're doing, and ECMWF and its role in Destination Earth, and then we'll dive into indeed the topic that Tiziana already hinted towards, about how to deal with data generation and data consumption and how we do that in Destination Earth. And then if I have little time left, then I can maybe also say something about the Federation challenges that we have. So maybe first a few words about ECMWF. So we're an intergovernmental organization based in the UK. We are founded in 1975 with basically two main missions: to deliver long, medium-term weather forecasts towards some member states that can use that then for their products to do national weather forecast, and also to push the boundary of numerical weather forecast science, basically. Next to that, we are also engaged in Copernicus. We're responsible for 2 of the Copernicus services. And since a year, 1.5 years, we're also involved in Destination Earth. So Destination Earth is an initiative from the Commission. It's directly funded. It's run by 3 entrusted entities, ECWF, ESA, and EUMETSAT, responsible for separate parts of Destination Earth. Obviously, the main target of Destination Earth is to create a digital twin of the Earth, but there's a lot of plumbing around it. So ESA is responsible for the user-facing part of Destination Earth. EUMETSAT is responsible for the data lake and the data handling of Destination Earth. And ECWF is responsible for the digital twins themselves and what we call the digital twin engine, which is basically all the architecture around dealing with the data and making data available and running the models and so on. So one recap slide on digital twins. I don't want to bore you, probably are very familiar with the concept, but obviously for a digital twin it's really important. And on the one hand, you take an asset. On the one hand, you need to be able to observe that very well, so you need a lot of sensor information. Well, obviously the Earth is very well monitored, so that part is nicely covered. On the other side, you need obviously to have a simulated representation of your asset to be able to understand how it's working. And then you can start to play with you're getting sensor information from the state of your asset, and you can simulate and understand what's going on, and then you can start to run scenarios to understand what you can do to improve the situation, right? But typically when you have an airplane, that makes a lot of sense. You have to then take action. For the Earth, it's a little bit more tricky to understand exactly what taking action means, but conceptually it's the same, right? And what's important as well with a digital twin is that it's an interactive tool, right? So you can play with it, you can run scenarios, you can interact with it, you can run different simulations, you can add new data sources, right? So it's a very open environment, and that's really important. That's what we're trying to achieve. So for Destination Earth, we are basically working from 3 pillars. So on the one hand, we would like to improve the models themselves. So going to a higher resolution, going to higher fidelity of these models, both globally and regional. Then the second pillar is basically to bring things together, right? So we have a lot of Earth models, there's a lot of impact sector models, but it's not really a place where all these different components come together and you can do end-to-end simulation, right? All the way from your global Earth system model to like simulating the impact on a farm field, right? That chain is not really available. So that's something we're putting a lot of effort in. And then the third pillar obviously is the whole technical interface around Destination Earth, right? So how to make it possible to interact with the data, but also with the models and also with the workflow, right? So that is really important for a digital twin, that you have this high level of interactivity, right? Right, so then the theme of this particular meeting, the data deluge. So yes, so for this particular keynote, I would like to talk about the data production aspects of Destination Earth. So how much data are we generating and why, and how do we deal with that? I want to talk about the data consumption. So how can you be smart about extracting specific pieces of data and not having to sift through massive amounts of data when you want to extract specific fields. And then also about data value, and specifically in the context of machine learning and AI. So what do we do in that context, and how can we extract value from the data that we are generating, right? So I think these are important topics for any project, but for Destination Earth in particular. So the data production. So first, maybe quickly show why we're generating so much data. Right, so here we have an example of a climate digital twin where we go from very coarse-grained simulation to quite extreme high-resolution global climate simulations. And you can really see from the animation why that makes a lot of sense, right? So on the one hand, obviously the quality is better. You get more details. But it also brings, it narrows the gap between a global climate simulation and regional impact. So typically you are interested on a local scale in few 100-meter kind of resolution, and to downscale from like a 50-kilometer global resolution model to a few 100 meters, that's a huge gap, right? So on the one hand, you want to increase the quality and the resolution of the global model. On the other hand, you want to be much closer to your local model, to your regional models, right? But obviously the effect of that one is that we're going to generate a tremendous amount of data by doing so. Here's another example of why high resolution really pays off. So this is Alpine region. You might recognize North Italy, Alpine, the Alps. And there you can see that if you go from left to right, you increase the resolution. You see that the quality of the forecast becomes much closer to the actual observed, in this case, rainfall participation. So again, we have an example there of why high resolution picks off. And here we have another example of a storm that is developing, and by increasing the resolution we can much better forecast its trajectory, and especially also the intensity of the rain and the wind. And we also understand why that is, right? So if you go to higher resolution, we start to capture certain physics, and we can actually simulate certain physics that we would otherwise parameterize, right? And therefore, we can understand why that works, and especially certain critical resolutions are important, right? So at some point, when you increase the resolution a little bit, all of a sudden you can resolve certain physics, right? So you have sort of step changes in resolution where all of a sudden the quality of your model becomes much higher. And we see that kind of step change is with these kilometer scale global simulations. But again, that comes at a tremendous increase in the amount of data that we are producing, and also an enormous increase in demand for compute power. So what are we doing? We're running Destination Earth on these emerging pre-exascale and exascale systems. So initially we're targeting Lumi, Leonardo, and Mare Nostrum 5, but Jupiter is already being procured, and we just heard yesterday that also the French system, Jules Verne, is now they're starting the negotiation with the EuroHPC, but I think they won the bid for the next site. So we see this emerging landscape of more powerful EuroHPC systems, and that's great. But it's lots of compute, but not a lot of storage. Although it looks like a lot, they have a lot of storage. For us, this is not much, right? So Lumi, for instance, has 4 20 petabyte parallel file systems, okay? And they have an object storage, which is 30 petabyte. But we expect to generate a petabyte a day. So that fills up rather quickly, right? So what we're doing, we already try to split like the really high resolution data that we're outputting on the HPC itself and the kind of data that we want to keep for longer term. And that means that we have basically, we put our own storage, our own data lake physically at these sites to absorb that data and to allow us to deploy our software stack on it. So what are we trying to do here? So we understand that storing all this data is not really an option. So the model is running, it streams out a ton of data from that simulation, and we want to operate on that data immediately and store as little as possible. So what does it mean? So basically, we have to understand what kind of streaming framework we can deploy on an HPC to operate on that data immediately when it is being generated. And we do that together with ETP for HPC, who is helping us to draft a technology agenda for these kind of technology topics. So for this specific topic, we collaborate with ETP for HPC and BDVA to not design, but give a sort of an indication on what kind of frameworks would work on a HPC. And at the same time, we're working with their partners in a mathematical group, so EO Maths in this case, to understand how you can, for instance, train your machine learning models on data in motion. Right? So you don't have to train it on static data, but you can train it while the data is being generated. And then you don't have to store that data, but you can still take advantage of that data stream, right? So what do we currently have in place? So what we have in place is something which is already quite sophisticated, but it's not necessarily formally a streaming model as such, right? If you really dissect it. What we have is basically programmable pipelines that while the simulation is running, takes the data and passes through a series of components, even multiple pipelines, that can operate on that data on the fly, right? So it can extract certain fields, it can do some sort of aggregation, it can map it to different grids, it can output it in different formats, right? So you can be really specific on what data you want to have, how do you want to operate on it, and what you finally want to store, right? And that saves a lot of final storage space that you need for the results, right? So you're not going to store all of these results. It's important to understand that at this point in time, it's not really a streaming model. It's just a library written in C++ that you have to run with your model, and then you can program that as functions, right? But we have in mind to do this conceptually in a streaming model at some point in time. So how would that look like then? So here you see a depiction of the climate digital twin setup. So we have even different types of models that run these climate digital twins. They output their data, and we sort of generalize that. So the second block you see here is a generic state vector, and that is this kind of format that we want to transform the output of the different models into. And then we will have applications sitting in the data stream and operating on the data in real time, right? But we also have other components in the data stream. For instance, we will have our quality assessment and uncertainty qualification sitting in the data stream. So you don't have to do this as a post-processing step. You can already do that while the data is being generated. And obviously, because it's a digital twin, we also want to have a feedback mechanism, right? So you have your application sitting in a data stream, operating on the data, and then whatever comes out of that digital twin, you want to feed back into the model, right? So these feedback loops are really essential for digital twins, especially when you build up your environment, your ecosystem with multiple digital twins that basically interact with each other, right? So that's really important. And I think in the streaming model, that is something that can be accommodated because you have this sort of dynamic characteristics of such a streaming model. Obviously, some data will be stored to file, right? So we have an arrow going to our data bridge and our data lake, where some of the data will be stored, right? We're not going to save nothing, obviously, but we try to minimize the amount of data that we really have to store and be specific about it. And then we are lucky, we are in a good position because we're simulating, right? So if at some point in time we realize, like, oh, we actually need certain data, but we forgot to store it, we can rerun the simulation, right? So we don't, it's not if we don't store it, it's lost, right? It's going to be an effort, it's going to be expensive. It might be really tricky to rerun a simulation that you've done 2 years ago. I think everybody has that understanding that it's not so trivial to rerun something that you've done some time ago, but in theory that's possible. So it also gives us more sort of freedom to not necessarily store everything. Right, so that's on the data generation part and how we want to minimize the amount of data being stored while still being able to operate on the data. Then the data consumption part. So also there, we are trying to be smart about how we access the data, right? So a lot of data will be generated and then we want to extract really specific fields. So how do we do that? So we're building a mechanism that supports really precise and specific extraction of certain data. And we call that a polytope, basically a multidimensional search space where you can extract really specific paths. So how does that work? So user A wants to extract, for instance, some temperature fields over Greece. And he can extract only the data points over the land masses of Greece. He doesn't have to load the whole bounding box and then filter out and throw away the data. He can just specifically extract that data. So it's like memory access, right? So we have the database exposed, and you as a user have an API that allows you to specifically extract only those fields and only those locations that you're interested in and extract those, right? And that's going to save a lot of time and also a lot of stress on the underlying I/O system, right? But we can take a little bit further. Well, here's another example. If you only do that, right, you can already save a ton of I/O time. Depending on the shape of your country, so if you're Turkey, then your country looks a bit like a rectangular box, so you're not going to save a lot of data. But for some countries like Norway, you immediately already here you save like 80% of I/O load on your subsystem and the amount of data that you have to sift through after you loaded it. But we can take it one level further as well. You can also apply this to a time series. So maybe you're interested in a certain field and how it evolves over time, right? And you can extract that for a certain region and follow that over time. That's another feature that we want to do. But you can take it one step further. You can also say, well, I'm interested in a trajectory. So give me, for instance, a shipping route and extract certain fields over that trajectory in time, right? And the API allows you to do that, and you're only going to extract the colorful line that you see here. And that saves 99.9, like almost like close to 100% of your I/O operations, right? And you can take it even one step further. You can say, okay, so maybe I'm interested in a flight path, right? Then you even you're going to reduce that even more, right? But we're already at 100%, so I guess 99.99 or 99.999 really doesn't matter at some point in time anymore. But you get the point, right? You're really trying to reduce the amount of data that you have to read from the underlying file system, right? So on the one hand, we're trying to reduce the amount of data that we're going to write in the first place, and then we're going to reduce a lot the data that you need to read into your application to access the data that you want, that you're interested in. All right, the data value. So I have to clarify that before I go to the next slide. So obviously, there's a lot of value in the data implicitly, right? But for machine learning, we can say a few things more. First, maybe say a few words about machine learning and how that basically accelerated very quickly, right? So half a year ago, people were still quite skeptical about machine learning in the context of weather prediction and climate simulation. Now we know that these models are extremely good, right? So it's just reality that we have to deal with the fact that these machine learning models are quite competitive with our deterministic first principle models, right? So here's an example, for instance, where you see that if we use the same initial conditions that we use for our numerical weather prediction and we run like a machine learning model, the errors are more or less the same, right? And the even interesting thing is that it goes wrong at the same time as well, right? So where we have a spike in our error, we see that the machine learning model has a spike in the model at the same point. So we're like, how is that possible? It's like, do they make the same mistakes? And then we understand, like, no, it's really, these machine learning models start to capture the physics as well, right? So if certain events happen, it will deviate in the same way, right? So that was sort of very interesting understanding from it. Like, okay, so these machine learning models are much more physical than we thought. Here's another example for a storm trajectory, and you can see basically the quality is extremely good, right? And we were trying to find these corner cases, like, okay, where are these machine learning models and trying to become bad, right? So for instance, storm trajectories traditional is really difficult to do, but we find that these machine learning models can actually do it very well. And also cyclones, paths. We can see that there's still some underestimation in the intensity of the rain. We do that better. We also understand why that is, but they're getting extremely good. That's basically the bottom line. And also for extreme events, all right? So one of the arguments was like, yeah, okay, that's all fine, but extreme events are really difficult because extreme events, by definition of being an extreme event, there's not much data available on these extreme events, so these models have not been trained on that, so they're probably going to be very bad at that. Well, they're actually pretty good. So here you see that there's an extreme event over Finland where all of a sudden it became extremely cold. You can see the green dot, that was the actual observed temperature, which is outside the climate prediction, right? So this is such an extreme event that it's outside the range of temperatures that we could even foresee based on historic data. And you can see that our forecast, which is our red dots, and the machine learning model, which is the blue dots, actually a machine learning model is doing slightly better. I mean, they're still quite far away from this extreme temperature, but they're very comparable. Same for extreme hot events. Right here you see the same thing. So the red thing on the right-hand side is basically the range of temperatures that we think are even possible. And then the observed temperatures outside of that, and our models capture that somehow, but also the machine learning models capture that very well. So what is this analysis showing? That the machine learning models are really well. They're quite sometimes even better. So the higher is better here. So the blue line is the machine learning model and the red line is our model. You can see that they're actually beating us. And we also understand that they take a very small amount of time and energy to run them, right? So the machine learning models are extremely cheap. So you get better results, much cheaper, right? So where's the catch here, right? So what's going on, and how can we learn from that? So first of all right, machine learning models have to be trained on something, right? So where's the data coming from that the machine learning models have to train on? Well, we are still going to provide that, right? So we have a very powerful training set for machine learning, which is called ERA5, which is basically going back to 1940, if I'm not mistaken, and reapplies our latest, greatest model on all the observation data that is available, and basically creates a forecast of the weather going back to that time period. And the good thing about that, it's because it's a combination of models and data, it is without gaps, so it's a complete coverage. So that's great for machine learning, that you have a very high quality data set that has complete coverage, right? So, but if machine learning models will take over, then so what's the point of Destination Earth and our high resolution deterministic destination models? Why do we even still run these models? Well, two things. So on the one hand, we see, yes, so the data that we're generating with Destination Earth, especially these high resolution data, is going to be very important data set for machine learning to train on. And on the other hand, we also understand that there's still a lot of value in a hybrid approach, where we combine machine learning models with deterministic models, right? So if you look at Destination Earth, the whole setup from basically data acquisition all the way to the product generation and the advanced applications that are running, we see that machine learning can be incorporated in a lot of these steps, and can be combined with our traditional approaches. And we are working on methods to also allow us to deploy trained models for inference in the physics of the model itself. So if you want to replace certain physics or certain models from deterministic to machine learning, you can do that, and we provide a framework for that. So we strongly believe in this hybrid approach, at least for now. I have a little bit of time, so I will continue a bit on federation. So, having said this, and right, so we understand that for Destination Earth we need a lot of compute power. We have these emerging Euro-HPC systems. We are getting a certain amount of compute power in all of these systems, so that means we have to think about federation between these Euro-HPC systems, and that's not so easy. So if you want to run across distributed Euro-HPC systems, then this is our shopping list of things that we need, right? So at least we need users, but also system accounts, right? So the digital twins typically have a quite rich service infrastructure around the model itself to allow this interaction with it and allow this data access and all these different operations on it. So we need to deploy services on Euro-HPC systems, and hence running them under system accounts. And these also have to be transparent between different systems, right? You want to be able to deploy your services on any of these Euro-HPC systems. And that means that those also have to exist. Group access, everything, that has to be federated. That's like step one. But also our application services has to be deployable on the Euro-HPC systems. Performance portability plays a role, but also just being able to run a model, right? We find that the architecture of these Euro-HPC systems is such that we're even struggling to get a model up and running in the first place, right? Let alone it being performant. The whole data access model, the data ownership, the quotas has to be somehow harmonized across these Euro-HPC systems. We need to be able, because we're running services, to manage our secrets across these different sites, so that services can talk to each other and we can have a trust relationship between these services. Obviously, we need an accounting system that is transparent across these different architectures. And we need logging, monitoring, and alerting on all these systems as well to be able to monitor your end service, right? So that's quite a challenge, and it's quite a long list of things, and I think most of that is not really in place. At least we find that it's not really in place. So also there we are working with ETP for HPC to draft a technology agenda on how to make this work. And we leverage their experience and trying to also influence a little bit or make our wishes known to Euro-HPC and to the Commission. So if they're doing a call on federation, that these things are at least taken into account. So fitting the digital twin landscape with European digital landscape is a bit like trying to fit two molecules together. It's really difficult. And it's not even, so sometimes you succeed, but it's also moving, right? So our landscape is moving, the Euro-HPC landscape is moving. It's really difficult. We find that the same holds for the digital twin ecosystem as well. So if you look at the number of calls that are coming out for digital twins, it's quite impressive. And they all bring their own frameworks and their own way of working. And how to fit that together is already a challenge. So what we're trying to do is, at least on our end, try to come up with standards and integrate the different approaches so that we can, as a single voice, talk towards your HPC and the Commission, trying to explain to them how the digital twins for Earth systems would want to operate and how the environment can be made available to that. And then we have this notion of the integration continuum. Right? So not all models need the same level of integration, right? Some applications just want to feed off data, and that's fine, and then you write an interface, you have a standard on the data access, and everybody happy, right? But some models will have a very tight integration. So imagine that you have a digital twin of a volcano, right? That pumps ash and into the atmosphere. That is coupled to how clouds are being formed and how the atmosphere is evolving, and that then feeds back into this volcano model, how this ash cloud will be transported and so on. So there you need a coupling on a physics level. That you're talking about a completely different type of integration, right? So we have to understand for all these different digital twins, where are the integration points and what level of integration do we need? And that's really important to have. And to be able to do that, so this is summary of that one. So to be able to do that, we have had a look at all the different digital twin architectures. Just a few. They're similar-ish, so that's good, which also makes sense because we're trying to do the same thing, so it would be weird if they're completely different. But they have subtle nuances that are different, and also everybody has his favorite components, right, to do these specific functions. So what we're doing now, and we're starting to doing that in the context of this intertwin project, is to come up with some sort of a baseline architectural design where these things can be mapped on, and then we can have a good discussion on what components we pick and why certain architectural layers are there and what their function is, and what kind of integration interoperability challenges we have, and based on that prioritize those activities. And that will also allow us to write the glossary on Earth system digital twins on what are we talking about? Are we talking about the same thing? So that's going to be quite an effort, but we think it's really important because otherwise the effort of making things interoperable will be close to impossible. And with that, I would like to thank you, and I think I'm more or less on time.
So any question for Thomas? Was a quite inspiring presentation, and we do have people from other disciplines as well that are into this business or are being confronted by the same technical challenges. Any question? Yeah.
Morning. Paul Stokes from GISC. You mentioned quite early on in your presentation the concept of value.
Yes.
The value of your data. The concept of value is something that interests me a great deal, especially in the context of business cases and making the case to spend the money to collect and store and preserve data. You need to have some understanding of the value of the data you're trying to keep.
Right.
So how do you assign a monetary value to all this data in order to make those cases?
So that's an interesting question, of course. I guess by asking the question, I think you already have an understanding. It's a difficult one to answer. So we're more going by the assumption that we're not going to store data because we generate it, we're going to store it. We're only going to store data when there's the specific use case for it. So we're not arguing about the value of a specific use case, but if a use case indicates that it wants to store certain data, we do that. But we're not going to store the bulk of the data just because we generate it, we're going to store it, right? So it's a little bit more first order approach, I would say.
Yes, there is another question here. Can you say your name? And a finish.
Hi there, thank you. Mark Dietrich from EGI. Thanks very much for the presentation, fascinating. I have 1,000 questions, I'll only ask 2. The first is, it seemed one of the conclusions you might draw from the data you're presenting is that we are under forecasting extreme events. You know, you've got several of those green error bars for observed data which are under forecasted by your models. So, you know, do we need to add a fudge factor to sort of deal with the extreme climate concerns that we're all very concerned about? So that's one question. The second question is, I'm wondering how your architecture will support more cross-domain situations. So recently there was a report of the requirement that sulfur content of fuel for shipping should be reduced. And based on that, aerosols were reduced, and we had increased warming in the North Atlantic and North Pacific. So how are we going to consider these unintended consequences of positive effects? So,
interesting question. So the first one, I think an extreme event by definition means it's the south side of this of this range, right? What we see is that machine learning models have a tendency to smooth the fields. They're doing some, well, it's maybe a bit, it's sort of an interpolation exercise, right, that you're doing. And by doing interpolation, you're by definition smooth, right? And they're also being trained on quite coarse resolution data. So AR5 is 35 kilometers or something like that. So we don't expect them to capture these peaks. So that's understood. But we are pretty sure that there will be some research group that will solve that quickly, right? Especially because big tech is putting its weight behind it. And there's a lot of very smart machine learning people who are now focused on weather and climate. So we expect that it will be soon done. And then the other question is very interesting. So we don't want to create a digital twin, like one massive digital twin that's going to capture all the physics, right? So we want to create this ecosystem where indeed you can have a digital twin of shipping, right? And you basically deploy that in destination Earth. It feeds off the data stream that being generated by these models, operates on it, and then feeds back into the model saying, hey, I have now less aerosols, so therefore I have less clouds, and therefore what, right? So this whole feedback loop that I showed in one of the slides, that's exactly how we want to couple these other models very tightly in the whole destination Earth setup. But then you're talking about integration on a very fine level, right? And that is complex. But that's definitely the vision that we have, that you can bring your model and just deploy it in destination Earth, and it will feed back into the whole thing. Right.
You go first.
There's a question.
Thank you. I'm Pascal Derek from the Public Health Institute, Sciences and in Belgium. I've got a question, Thomas, about your last slide. It's the interoperability between the different digital twins. Because at one point, you will need to have the data machine readable and machine actionable.
Right.
What kind of technology standards are you foreseeing to be able, for instance, to do federated learning, to distribute through AI codes in the different, I'm going to call them data silos, but not only on the web, and to have AI agent being able to run its model in different silos and going through the different, I will call them data sources. I like your your slide with the different data collection. Yeah.
So I think on the one hand, so what we showed with this polytope approach will allow machine learning models to really specifically access the data that it needs for its training, right? So it allows access patterns for machine learning that normally would be really difficult to do, right? Then you would have to prepare a data set, put it aside, and train on that one. This polytope interface, at least in theory, allows you to directly extract it from the raw data, right? That's one. And then obviously we want to have, on top of this polytope, APIs that are domain specific, right? So your community is used to consume the data using a certain format. We can just bolt it on top of that, and the underlying technology will be this polytope technology, right? And that's how we foresee that this will grow. And imposing standards at this stage is too early, basically. Right, so Destination Earth is just sort of growing. We don't really know exactly what the community is going to look like. We don't want to enforce certain standards that will paint us in a corner, right? That will make it difficult for us to work a certain community. So we're quite open to what kind of interfaces you as a community would like to have to the data.
I was thinking about in data.
Right.
Just to make the data machine actually.
Right. Yeah. So that's.
We have another question here.
Anabel Oliveira from LANEC. If I want to set up a coastal digital twin service, let's say for coastal inundation,
Yep.
we want to do it on demand, so applicable anywhere in the world, the user configures the site.
Yep.
What type of integration do you foresee into Destination Earth?
Right. So it really depends on the digital twin. So in principle, we have these three components, right? We have the Euro HPC where the big Earth system models are running. If you have a digital twin like that, then you have to think about integration on that level. If you don't, then we have the core service platform, which is going to be operated by ESA. That's going to run in a public cloud, and you can just run your application there, and you will have access to the different data sources, right? So you can feed off of data of Destination Earth, right? So then you only have to worry about the interface on that level, and then you can deploy your application directly on the core service platform. So it depends on the type of digital twin, I would say.
Thank you for a fascinating talk. I'm Gergely Sipos from EGI. I have one kind of question, remark. I don't know if you have been here yesterday. No? Okay. The slide you had on federation needs is kind of very well matches what we presented yesterday.
Right.
So definitely let's follow up in the break to discuss those points. And my question is a bit separate from the science. Is there any collaboration between this initiative and the gaming companies, especially those that create ultra-realistic worlds?
Yes.
Because to me, maybe the kind of the modeling analytics is kind of similar problems.
Right.
You can just feed the data.
Right. No, so I didn't mention that at all, but indeed, we have a contract to look into immersive visualization. We're using Unity as a gaming engine for that, and there's a company who's implementing these sort of gaming engine style interfaces towards Destination Earth information system. So we're definitely working on that, and ESA is going to have a contract as well. And I think there's a call, Horizon call, opening up somewhere in December, which is about AR and VR for Destination Earth, exactly tackling that topic. So there's lots of work in that one. Yeah.
So I have a question. I think this is the last one. You've presented very briefly the complexity of the data management part and the data lake as well. Could you expand a bit on the concept, how the data lake will look like, what is the distributed nature, and give a few highlights about that?
Right, so indeed. So the data lake for Destination Earth consists of two parts. We have basically a central data lake, which is like a federation of data sources. So it will give you access to data holdings, but not necessarily copy the data into the central location, right? So it provides you access to this data through the central data lake interfaces and APIs. And then we have the what we call a data lake that is sitting at the Euro HPC site. So we have this data bridge that is sort of an extension of the data lake next to the Euro HPC system. We have one deployed at Lumi of like 30 petabyte in size, and there the Destination Earth digital twin data will be moved onto that local data lake, and you'll be able to consume the data from there. And obviously we have to think about scenarios to move the data around as well. Because you can imagine that, for instance, you will have an extreme event, there's a storm coming, all of a sudden you have 200 cities in Germany who want to run their own local digital twin, feeding off the same data, and maybe the Euro HPC system cannot accommodate that. Then you have to run them on other Euro HPC systems, and that data has to be made available on in these other locations as well, right? So we're looking into data movers between these data bridges as well to make that data available. And their federation aspects obviously are important as well. So we have indeed this sort of these two parts of the data lake, a central part which is basically a federation, and then this local data lakes for high performance access to the data close to where the simulation is being run.
Okay, I hope that perhaps during the panel or later there is also possibility to have some chats. The data lake concept has also been studied and prototyped in the energy physics community, astroparticle physics, and I think there is probably a lot of experience to share and yeah, maybe potential collaborations to explore. I don't see more questions from the audience, so I think we can please take a seat here. So we have a panel now. If you could please put up the slides with our panelists, and I'd like to introduce them one by one. Thomas, please take a chair from this side of the table. So as I said in my introduction to the session, we hope in the panel to bring up also the experience of other communities that are tackling the problem of the data deluge. Next slide, please. Yes, so I'd like to introduce the panelists one by one in alphabetic order. So the first panelist I'd like to bring to the stage is Ignacio Blanquet. Ignacio, please take a chair, yeah, on the right side. Ignacio is professor at the University Politécnica de Valencia, UPV, and here is also representing the IOSC Association, being one of the directors of the board. But also interesting, Ignacio is highly involved in the implementation of the cancer imaging data space, where EGI is also participating in the federation part. So I hope Ignacio, besides bringing the, let's say, the point of view, the IOSC opportunities, can also present a bit the challenges of data federation in this different scientific domain. Next, I'd like to welcome Andrei Filipczyk, professor at the Josef Stefan Institute. Andrea, I think you have multiple hats, but Andrea comes from the high energy physics community and is also highly involved in the integration of one of the LHC experiments with the RHPC capacity that is being hosted in Slovenia. So I hope Andrea can bring the physics community experience, but also the hands-on experience in having been already working on RHPC capacity integration at a national level. Next, Luciano Gaido from INFN, Director of Technology. Luciano is involved in a number of national projects in Italy, aiming at building up federated hybrid infrastructure in Italy for science. So I hope Luciano will bring us the perspective of how Italy and the Italian scientific community is being organized and funded and structured. And last, the panelist, Hannes Thiermann from DKRZ, Germany. Hannes is data management leading person at the World Data Center for Climate, and Hannes also brings the experience of the ISNES community, which is our federated infrastructure for climate modeling. So welcome to all of you. And I'd like to go to the next slide with a few questions. I believe we will also have time for questions from the audience, so if you have any additional topic you'd like to tackle, we will have time for that. So I'd like to start with a question which is a bit for those of you who have scientific roots in different domains. So Hannes, Andrei, and Ignacio, my question is, what are the most pressing data and compute integration challenges that research in your scientific domain will face in the coming decade? We have heard from Destination Earth. What are the issues, what are the directions and the areas being explored, and we would be interested in knowing how your communities at different stage of maturity, of course, are similarly tackling these issues. You have mics on the table, and you can switch on the mic. There's an on-off button. We'll take a few seconds to start. Yeah. Who wants to start? Well, I will pick one. Andrei, okay. You are the one in the middle.
Okay, so I worked for a long time still working in high energy physics, and mostly in Atlas experiment, let's say, and involved in computing for 20 years already, right? So several different projects, and later I'm also involved a lot in EuroHPC, where we especially built a Vega machine in Slovenia for national and for, of course, European purposes.
Can you hear
Can you hear me? Right.
You can hear
could
him?
have
Yeah.
put it closer. So basically, the challenges of particle physics are quite high, and one could say that the future might be at stake, but it's not entirely true, because even 20 years ago we didn't quite know what we're doing, and we were relying on evolution of technology to be able to drive the physics program through. So after, let's say, 20 years, our computing infrastructure and procedures is relatively stable. Production doesn't work for everything, but for most of the cases. But still, the world of technology is changing rapidly, and we have to somehow adapt. So physicists, at least fundamental physicists, are all about precision and reality, right? So we want to measure things to extreme precisions. Maybe we can put it in a different way. We have a digital twin of our experiments, which is basically Monte Carlo simulation of the detector and reconstruction. And we are interested into differences between the reality, the real detector, and what we can simulate to the order which is lower than 10 to the minus 9 or even less. So 1 billionth or even 1 trillionth in all cases. And so we need extreme amount of data to be able to perform our physics program. So this physics program was already challenging till now. Let's say at this point during the run 3, so this is the third operational period of the LHC, is we have more than 1 exabyte of data, all the experiments together, let's say. We use more than 1 million cores all the time, non-stop, and we create about 100, even more than 100 gigabytes per second traffic worldwide to be able to process the data. So this is quite under the limits, and now with run 4, which will start in, let's say, 6 years from now, we will need a 10-fold increase of all this, because the trigger rate will increase by a factor of 10. So just by scaling, you would expect that you would need 10 times more resources than that, but of course this is with present funding scheme not quite feasible. So invest a lot of effort into all kinds of optimizations, let's say reducing the events, improving the analysis, speeding up the Monte Carlo simulation. This was achieved already several times. Here, of course, our great challenge is how to use the accelerators. One of the large problems is that Monte Carlo simulation itself is by nature, it's quite different to usual parallelizing techniques, let's say image processing or stuff like that, where you can do several steps at once. We have tried a lot of times to accelerate it, but the gains are there really small. So if you count on the end, so if you speed up Monte Carlo simulation by a factor of 2 by using GPUs, the investment in the GPU is much higher. One of the greatest challenges these days is actually also the manpower or person power that is needed to maintain the computing infrastructure. For example, we need about 100 FTEs to maintain the sites. So let's say 150 dedicated administrators to CERN, let's say, to WCG, plus 50 on Atlas only to operate central services and deal with exceptions, errors, and so on. So this is a bit too high these days. It could be automated, though this is also one of the difficult things. So I'll stop here for now.
Perhaps I'd like to ask a question. Having seen the approach of Destination Earth, what are the similar challenges that you see between the two?
I think the similarities are quite similar, and we have a lot of common. So maybe I could also mention at this point that actually we have started the initiative with, let's say, between ECFA, which is the European Commission Collaboration and Consortium for Future Accelerators, then astroparticle physics community and the nuclear physics community. So we just had a workshop a week ago in Bologna to discuss the common strategy, common deals, because, you know, one great example is Russia, the data management system that was developed by a particle physicist, and nowadays it's used in many experiments. I think even Destination Earth has this included. And I think that there are much more commonalities that we initially think, and we have to really consider that in the future to first to optimize our investment into development of computing software, and second, to have a better strategy towards the, let's say, European Commission funding agencies, so to have a better strategy for the future and a common approach.
Thank you, Andrei. So, Hannes, what is the experience, the challenges of easiness and climate modeling?
So our field is pretty close to Thomas' area. So I will make a bit of a counterpart, Thomas, if you allow, no? To make it a bit more lively here, no? So, and you were quite honest in your presentation, pointing out several challenges ahead of Destination Earth, and I agree. No, I believe one of the most pressing challenges is that so far, perhaps not all scientists have really understood the change of the concept we have now here ahead of us with this Destination Earth, with digital twins. Let's say from our experience in easiness, and you touched on that a bit, so far we had these climate models, they were running with all the problems, but they were producing the data, and we kept basically everything. And when a PhD or whoever comes around a couple of years later, he can give it a start immediately to do his research. And now, you said it kind of, only if there is a, let's say, case for keeping the data, you will keep it. And it's just probably a tiny bit. Perhaps after a year, it was even smaller. And so the point is that research and their infrastructures need to be organized much better to make their case, to really make it visible to those who perform these big simulations. So the point is, for researchers, they have to make the case, they have to tell you, okay, this is needed, otherwise the data will not be stored, and you mentioned it, okay, probably the simulation can be redone, but we know that it's challenging. For climate models, we can really eat up all of those HPC resources easily, and to have a share on these resources for, let's say, doing something again, which just perhaps a PhD needs, is not very likely. So the change of the concept is really something which people need to be aware of, no? That we need to talk to each other, we have to listen, to really have a good case to make this Destination Earth, which I believe is a brilliant thing, to make it a success. I have other points, but perhaps we can move over to other, no?
Thanks, Hannes. So, question is for Ignacio. So it would be quite nice for this audience if you can first introduce the EUCAIM data space. I believe many of you are not aware it's quite a new initiative and project. And to start off, I would be interested also in the data management federation aspects that we have been discussing with your contributions, and how EUCAIM is going to challenge and tackle that, and any other point, of course, that you want to raise.
Thank you, Tiziana, for introducing this point. Yes, EUCAIM actually is not a data space by itself, but it's a project that is creating a research infrastructure federating cancer imaging repositories all over the world. It's quite aligned with the health data spaces and the testing and experimental facilities for health. So this research infrastructure, which is being built, has a lot of challenges. We have plenty of challenges. Medical data has many challenges, and especially in the case of imaging, we have the challenges of the criticity of the data that we are managing and the challenges of managing this big amount of data and big amount of processing needs. However, I would not say that the problem are on the resources. I see two main problems. We have one problem on the data harmonization. So you can put standards for coding the data. You can put terminologies on the health data. This is quite advanced. But images are so sensitive that if you have one image obtained by one specific scanner in one place, another trademark, another place, with a different protocol, with a different operator, minimal differences can make that the artificial intelligence methods can diverge a lot. So you have to apply harmonization at the very beginning, and this is really an open issue. And it's very important to gather this big amount of data in order to train properly the system. So I would say the first big challenge is on the harmonization of the imaging data that is being collected all over the world and is available in the real world data. And the second problem is the inherent problem of managing health data. So we have a GDPR, but in this case, despite that data is anonymized, nobody can really say that images are fully anonymized. There are always individual particularities that for special cases people can identify. So it is treated with a lot of care. But if you go to hospitals or providers, there are hospitals that allow to download anonymized data, others that say okay, but with full traceability, and others say no way. It depends on regional laws, hospital laws, so the legal landscape is amazing. So what's the approach of the research infrastructure UK is to deal with a fully, set of stages from a fully federated model. You cannot even see the data. You can only run processing distributedly, which is a challenge. You go to researchers, and this puts a lot of effort on researchers to prepare properly the tools. Second level, I provide you a virtual environment in which you can inspect the data. You cannot download anything. You can only inspect. This is an issue for resources again. But yeah, I'll say that we don't need the problem is not that there are no resources to provide them, but they should be provided in a way that makes the things difficult. Or even models that are more flexible. So I would say that trying to link with Destination Earth, we have, this model of integrating digital twins is really interesting because we have many different schemas that needs to be supported due to the legal environment in which we are working.
Thank you. So in UK, besides all the technical challenges, the legal aspects and regulatory aspects are major. Thanks for this highlights. I'd like to go to the second discussion point and look a bit at the national perspective. So my second question is particularly targeted to Luciano and again Andrei to learn about how the Italian research community is gearing up from an infrastructure point of view, and the same for Slovenia. But of course, Ignacio or Hannes, if you have also ideas or contributions from Germany and Spain, we would be interested. So let's start with Luciano. Can you tell us a bit about your experience in Italy?
Yeah, we have a very important initiative in Italy funded through the National Plan for Recovery and Resilience, which will build a national center for supercomputing for HPC, big data, and artificial intelligence, and several other projects funded to complement this activity. So in total, there will be 200 million euros to build this new infrastructure, which will leverage what has been done in the past in terms of existing infrastructures. INFN is contributing to this activity with its own cloud distributed infrastructure, which is called data cloud, and other entities, 25 universities, 12 research institutions, and also 14 private companies are involved in this project, will contribute to this new infrastructure, shared infrastructure and distributed infrastructure, where the computing and data continuum will be in the DNA. So we will have contribution from supercomputers, from Cineca, for example, Galileo 100 and Leonardo on one side. On the other side, we will have an infrastructure based on the cloud paradigm, and also thanks to a complementary project called Terabit, which is implemented by 3 entities which are INFN, OGS, and GAR, with the contribution of Cineca, of course. We will implement this new paradigm with a new concept called HPC bubbles. So there will be, in the complementing the existing cloud infrastructure, these bubbles, which are different from the HPC supercomputers. They are made of FPGAs or GPUs, or, of course, complementing the CPU part. And they will be made available through this federated cloud infrastructure. Well, the challenge here is to make all these diverse resources accessible through a common mechanism, which is, of course, challenging. But we will be dealing with this by leveraging what has been done in several projects so far. Escape is one of the important projects. Russia has already been mentioned. It is one of the main components of the data lake solution we will implement in this infrastructure. FTS, of course, is another important component. But we will tackle the need to define an harmonized way of assessing resources. This will be done through the platform as a service component in the cloud infrastructure, which will provide direct connection to the cloud resources in the infrastructure, and through a sort of concept of edge computing near to the HPC resources, the supercomputers, where the implementation of specific services will allow to offload the computing needs, the workloads, into the supercomputers through the platform as a service tool. So it is challenging, but this common infrastructure we will implement will be made available through several scientific communities, through what we call the spokes, thematic spokes. There are 10 thematic spokes in addition to the national center with the infrastructural part of the plan. They are thematic and they are very diverse. They range from health research to environmental studies, through physics, astrophysics, space studies, and so on and so forth. Every community will have the possibility to rely on this common infrastructure with their needs, but through a hopefully common framework to assess both computing and the storage resources.
So
there are twin projects. INFN is contributing to and with several other partners. And the model and the architecture is defined already, but the implementation will be gradual, of course. And so by the end of this national plan, which is foreseen for 2026, everything will be in place, but we will be step by step.
I have to say, from a EGI Federation point of view, experience like the one reported by Luciano and INFN is quite important, as the problem of the computing continuum and distributed data management is very, very common across the whole sectors of science that we are supporting. One of the major issues where essentially progress was not really satisfactory was different funding schemes, different organizations running different types of infrastructure at the national level. And I believe that this separation of funding also created the silos and the way we operate nationally, and this has also slowed down the ability to tackle this integration aspect at European level. So from my perspective, we look forward to these initiatives because this will bring a tremendous simplification in the way resources are being procured, operated at the national level, and then made available in EGI and international level. So,
just one more
please,
information. Yeah. There will be a specific presentation on this plan, on this activity during the next session after the coffee break. If you are interested to know more at the technical level about this, you can attend this session.
Which session is this, Luciano? A bit of promotion?
The international contribution, national, I don't remember the name of that, the next
Okay,
one.
if you're
the
interested, ask Luciano. So I will go to Andrej and then Hannes.
Okay, so Slovenia, we have similar approach. Like Italy, but don't know that ambitious because the country is much smaller. But anyway, we started already, well, we are participating in grid computing for a long time, and we entered the EuroHPC 5 years ago, activities, which then resulted in Vega. And one of the main ambitions when setting up the Vega is not to set up yet another classical HPC, but experiment with the possibility to make it available through everybody, meaning that it could provide a point to execute whatever you actually want. In data-intensive workloads, HPC workloads, provide kind of cloud infrastructure services or whatever, so without any particular limitations. And also the SLINK, which is a consortium of let's say supercomputing entities in Slovenia, which has about 25 members, supported this idea, and we actually did a coherent planning and plans for the future. So of course we also plan for the upgrades of Vega and some other infrastructure, and we have some funding for, let's say, fair data storage within the national recovery plans, which has to be built by 26. So we also collaborate quite a lot with Chineka because it's fruitful. Also through InterTwin project, we basically invested a bit in kind in Leonardo, and also we have invested in the future quantum computer because we want to broaden up our activities. One of our main wishes or activities for the future is also to enter the federated EuroHPC business, which I think it's quite critical at this point. It's already official that EuroHPC wants to have a federated plan, federated HPCs. Strategic document was already prepared, but not yet completely blessed. So the goals are kind of clear, but the approach of the initial steps have yet to be defined and discovered, and also the way how it will be done is not completely clear yet. But it's clear that EuroHPC business will need similar approach than it's done here in EOSC or EGI or wherever else. They are just not completely aware of that yet. Let's say most of the EuroHPC community or people that work over there, they were educated in HPC centers and so on, with strong focus on what was done before, even with praise. But I know even on Vega there now appear a lot of true HPC users which really have quite different demands than in the past. So it's not simulation anymore. So machine learning, artificial intelligence, and let's say large, not large as LHC experiments, but devices like cryo microscopy that you can purchase and you have in the lab produce enormous amount of data. And this is not handled at all, let's say, in what was foreseen before. So some sort of synchronization in this level should be done. There maybe also one thing that I should mention here is EuroHPC got quite a large funding for HPC infrastructure, and data infrastructure was not in the scope of this. Though there is some data space, but it was never meant for long-term preservation, right? While as far as I know, in ESCO and EGI, there are no plans for infrastructure, so it more or less relies on what it can be provided through cohesion funds and so on. So the data strategy within the European Commission remains a bit undefined, I would say. And we will need a bit more coherence, or strategy that would include all types of, let's say, computing resources, whatever it is.
Can I ask just to go a bit more specific on one point that was also addressed by Thomas in the keynote, which is federation. Obviously, being able to be compatible in terms of trust and identity management, but also security coordination, accounting, monitoring, and Thomas, you had a full slide on initial set of federation capabilities that will be required by Destination Earth. Having a good approach from the onset to this federation will be essentially fundamental to ensure that our EGI federation approach tools that can integrate and interoperate with what RHPC is going to implement. So what are the chances from your point of view of collaboration between the two communities?
I think they're pretty good, but I think there should be some high-level discussion started. I think they already had some discussion in the recent past. I'm not sure what is the follow-up or aims. Well, in any case, the first aim inside the EuroHPC, within the EuroHPC, is to make the HPCs themselves federated and easily manageable and so on. But I don't think that this is a serious obstacle in widening the scope, because I think it's more or less compatible. And similar concept, Phoenix is basically quite similar in concept to the AGI Federation and other stuff. There are some technical difficulties, but it shouldn't be a technical obstacle or burden.
Okay. Thanks for the good positive message. Hannes, you wanted to comment?
Yeah, I could only underline and support your statement on the data strategy, for long-term planning in Europe. I'd like to make another different point, and this goes a bit on what Luciano, for example, said. So representing easiness. So we are facilitating the exchange between different stakeholders, and one part of that is to, so we need to be aware that these EuroHPC is basically GPUs. No? If you want to take advantage of these infrastructure, you need to bring your code to GPUs, and that's not easy. This is a tremendous and really costly effort, and for example, for the climate science, we know that from these big zoo of models we have there, only a few are already ported to GPUs and will take advantage of this architecture. And if other models will follow, we don't know. It depends on funding as well. So we will have a certain, let's say, consolidation with the models, which take advantage, and other models, perhaps which I have been on HPC so far, perhaps have to move to somewhere else. And I think this is a quite interesting approach, Luciano, which you pointed out. I believe this is something which you call these HTC bubbles. So these things that the other models which will not go to GPUs have to live somewhere else. And they will go wherever. So we have to take care about, and this brings perhaps new players in this game for these kind of models, which very specific demands with very specific support, so that these models can run somewhere else, and the data will be produced somewhere else. So we will have kind of a new distribution, not only driven by this big players like Lumia and the like, but also others. So, and this changes perhaps the infrastructure where data is produced, where data is kept, how data will be moved. And this is something we have to take care of when looking into the future.
I forgot to say that in this project of data lake implementation in the Italian infrastructure, we will tackle also the need to provide some storage cache near to the HPC centers wherever there is no permanent storage guaranteed, so that every community can in principle use HPC center even if they have not guaranteed the storage. This is optional, of course, but it is an important element to be implemented so that every research community in principle can benefit of the whole set of the whole continuum of computing and data infrastructure.
Thomas?
So yeah, I think it's really important. It's also the reason why we deployed these data bridges to have a cloud stack close to the HPC. But for us, the federation topics around services
are really tricky. We find that Euro HPC systems have quite different policies on what you're allowed to do and not allowed to do. We know that there's Euro HPC systems that will not allow to run services on HPC at all. There are Euro HPC systems that don't allow system accounts. Every user has to be traceable, you even want to understand the nationality of the user. So we see huge roadblocks on the Euro HPC systems to deploy something like Destination Earth. So we are a bit scared on how this will evolve. And it looks like it's getting worse. So these new exascale systems that are being announced, when we talk to the people who are hosting those systems, looks like their policies will be even more strict than what we have to deal with right now. I think in terms of portability, the point you made is really interesting. I'm not sure if we will have non-accelerated architectures for a long time even available at all. So I guess you will have to port your application. There's no way around it. You cannot keep legacy systems for legacy codes around forever. I don't believe in it. And then maybe one thing that was interesting about, you mentioned being able to reconstruct data. We are looking at machine learning and what it can do and how cheap these inference models are. We are even thinking about, would it not be possible to only keep your initial conditions? And you can reproduce your data so quickly with these inference models that maybe it's even cheaper and maybe even faster to just rerun those inference models instead of storing your data and operating on the data. And then you also don't have to deal with the fact that your physics, your model from 5 years ago still need to run on an architecture that it was never designed for. But you can run your latest and greatest machine learning model, the inference model, on the initial conditions and regenerate the data very quickly. So but then again, that's because we have the luxury that we're having a simulation, right? We don't have an instrument that spits out data and after that's gone, so yeah.
Yes, that's quite specific. So perhaps a concluding remark about this question. EasyNS, High Energy Physics, but also Destination Earth through ECMWF are all partners of Intertwin. And the data continuum, the computer continuum are aspects that we are tackling, also leveraging the experience of Slovenia and other countries that are advanced in the implementation of their HPC nodes. In the GI Federation, we have similar national initiatives. I'd like just to mention those to give a more complete picture. For example, in the Czech Republic, there is also a national strategy for an integrated approach to cloud data and HPC that is significantly supported by the ministry. Also in Turkey, we have a similar convergence and integration of infrastructure provisioning, and also other countries like Poland. We heard yesterday from the ministry what the plans are at the national level. So I would say there are good signs that at the national level funding and integration will be supported, and we hope that also through the Intertwin project, the communities represented here can in a way already use the project to push the technical agenda, the federation aspects. They are absolutely relevant to the Intertwin project, and I hope by having already today a running project, we can use the project to tackle a number of the issues that have been brought up today. And with this, I'd like to go to the last question that is perhaps very specific to IASC and Ignacio. EGI has been running the IUSC computer platform through the EGI ACE project, which is concluding at the end of this month. And of course, we had a federated approach for cloud provisioning and data integration there. And I've been hearing at the EuroHPC summit, but also very recently in the IUSC General Assembly, that there is a need of integration and dialogue between IUSC and EuroHPC in terms of how these important initiatives will come together to serve concrete use cases from science. And at the same time, I'm hearing that both in the IUSC arena and in the EuroHPC arena, there is a bit of pushback, thinking this is too early. And actually what I see in the Intertwin project, but also the use cases and how advanced at national level ideas and architectures and funding is progressing, I had the impression that countries and communities are actually ahead, and time is ready to start tackling with use cases and concrete actions. Ignacio, what is your perspective, your personal point of view? What are the opportunities for EGI, for IUSC, in cooperation, federating, and having common approaches with our HPC?
Yes, let me answer in two directions, right? So one, with respect to the opportunities of the communities, I mean, I think it's clear that there are communities very well advanced on linking thematic services with exploitation of data and all the whole stack of the infrastructure, and this is really good best practices that we have to leverage. I mean, we shouldn't aim to a solution that doesn't onboard those assets from the very beginning. I think this is a common understanding from the whole association, I have to say. But I think that what is also clear is that we have research infrastructure that are dealing with the big share of the research communities with resources, with data, and we have to onboard them in a proper way. Let me answer with another hat. I mean, in my multiple personalities, I also am a member of the ERG, right? So as you know, there is a willingness from the infrastructure to join together, to coordinate, to have a better positioning with respect to the research infrastructures, and this idea of creating an e-infrastructure assembly or whatever is called, that will be a boarding which is recognized by the S3 stakeholders, in which infrastructure can also share best practices and go and facilitate the adoption and the positioning within all those communities that are creating the data and having the contact to the researchers. I think that also could be a very good instrument to leverage the position and the good work that the infrastructure are doing.
Yes, so I'd like to give a bit of extra background, because in fact there is a ERG session in a few minutes from now. But I'd like to give this message to our community here. It's quite positive to see that the infrastructures, so EGI, EUDAT, PRACE, and OpenAir, for example, we are thinking about having group, a form of coordination that will give the infrastructures a single point of contact, and also will hopefully facilitate cooperation. This is something which is quite recent and was actively supported by EIRG as the main policy body that has been in fact regulating the way infrastructures have been funded and delivered in the past 20 years. ERG is celebrating 20 years like the EGI Federation, so I'm personally very, very happy to see finally this convergence happening. At the very early times of EGI, we had this cooperation platform that gradually faded away, and I think the use cases, the communities, and the initiatives that we've been hearing about today will, in a way, push the infrastructures closer. EuroHPC is a bit of the elephant in the room, so it's not yet actively engaged in this platform or conversations with the IRG, But I hope with time, RHPC will be also part of this initiative, even though we know, of course, the governance is in a way different. But from a technical point of view, the challenges and the opportunities, and I'm happy also to hear from Thomas the fact that not all problems have been solved. So it's nice to see Andrei's point of view and Thomas. So definitely a lot of work to be done. We are on time to close the panel. So yes, one remark from Luciano.
Just one more information. The presentation I was mentioning before is in the National Infrastructure for Open Science in EGI and Beyond at 11 in this room.
Okay, thanks for the pitch. So I'd like to invite all of you to take a coffee and have an opportunity to speak with our panelists and ask more questions. Yes, thanks. Let's thank our panelists with an applause. And I think coffee is waiting for us in the nearby room. Thanks again for all of you for being here.
Can you hear me? Okay. Okay. Great. Thank you so much. Good morning. Hear me? Okay, perfect. Thanks. Just to mention that the stream camera is out of focus. This is true also. Yeah. Oh, that's perfect. Okay.
People will start moving back. Maybe if somebody can do a shouting outside, that's appreciated. In the meantime, let me introduce the session itself. This session brings together some of the national members from the EGI Federation and from the broader EGI partnership. We will have 7 talks, rather short talks, so quite focused, to give us insight into the landscape of a national infrastructure for open science and for EGI, for advanced computing, how this landscape is expected to change, evolve in the coming years. And I ask each of the presenters to try to stick to the 10 minutes of the presentation, and there is a couple of minutes after each talk for questions. Okay, so you can present for 10 minutes. I will sit here and just indicate if you have like 2 minutes left. Okay. The first speaker is Robert Lovas from Hungary, from Staki, which is an institutional member of the EGI Council, and an institute that was mentioned several times yesterday as one of the integrated clouds that achieved full integration during EGIAs. Okay.
So thank you, Geger, for the short introduction. And in the next about 10 minutes, I would like to talk about one of the most important Hungarian national initiative about the ALKH cloud, and also the milestones what we achieved already concerning EGI, EOSC, and other S3 projects. Okay. Very briefly, the history. So we started at the same time when the EOSC initiative was born in year 2015, and also after that, our research network has been reorganized. So that's why we are now quite similar to the Lukasiewicz research network, what you have here in Poland. And there we received a significant amount of funding from the Hungarian ministries in order to upgrade the system, and now we are in the third stage. And here today and these days we are working on to somehow go further and support research data infrastructures and initiatives better. So that's why we have a data repository project, and actually this is in the alpha testing phase. And at the end of this year, we assume that it will be released for the national community. The major objectives of our cloud system is quite straightforward. So we would like to support the research network affiliated groups and at the same time university research groups as well. We have very strong focus on AI research, and actually this is absolutely in line with Hungary's artificial intelligence strategy for 2020 until 2030. And that's why we create different representative architectures for this AI community. And at the end, I can mention that the European infrastructure developments also would like to be engaged as much as possible. So the inauguration event of our cloud system was last year, and also you can see that we are really embedded in European infrastructures. So actually, you can see that Tiziana at the inauguration event talking about EGI, and also the leader of Slices project from S3 was also invited there. You could see already these numbers yesterday from a presentation. So our cloud is, let's say, a medium-sized infrastructure to support the communities. But we are very proud of that, the increasing number of projects we support. So actually we have more than 250 projects what we were able to support in the recent years. Concerning the KPIs, obviously one of the most important outcomes of these infrastructures, the scientific publications. Also, we have a very strong focus on online training events. And here in the right-hand side, also you can see something which is not usual, supported national labs. Because in Hungary, there's a new instrument called national labs around different focus areas, for example, AI and autonomous systems. And also we support these new instruments in Hungary with our cloud system. I already mentioned reference architecture, so we try to improve these and also make it available for broader communities. And these different architectures are quite similar to the infrastructures what you can see, for example, from AWS or from Microsoft Azure. So these can provide an end-to-end solution for different scientific or industrial domains as well. So we support different clustering methods, big data, machine learning, and so on, as you can see on this slide. And I just want to mention one of these, which is, let's say, one of the latest achievements. This is about distributed deep learning, and here we created a reference architecture based on the open source Horobot framework. And also we made some measurements and some experiments in the framework of the Artificial Intelligence National Laboratory. And in order to make it available for a broader community in the Horizon 20 NEANIAS project, we provided and we developed different underwater space and atmosphere research related reference architectures as well. And here we decided to make this robot reference architecture available for the EOS community. So if you visit the marketplace, you can see here how you can access this distributed deep learning framework. Okay, and also I would like to mention another very important national initiative. This is the National Laboratory for Autonomous Systems. And there are different testing facilities. For example, Zola Zone, you can see also one photo from there on the screen. And we created a reference architecture also to support the pipeline and also the visualization and the other facilities and other functionalities there. My colleague Attila Farkas will have a demonstration about this reference architecture tomorrow afternoon. So I would like to welcome, this event and this demonstration. And the latest achievements are around quantum computing, because we are really the witnesses of increasing number of experimental, academic, and commercial service providers that can cover a large part of quantum computing principles. But on the other hand, this is a real jungle, so there are different technologies and also different interfaces that may differ significantly. So that's why we have, again, a new reference architecture that can be used in order to do in order to perform some quantum computing related simulations locally on our science cloud. And also this can be, from this reference architecture, you can access resources from Jülich Supercomputing Center and the D-Wave quantum computer. Okay, just talk about our relation with EGI. Yesterday, you could also learn that this cloud has been already integrated fully with the EGI cloud, so that's why we are very proud of it. Proud of this. But on the other hand, also have to mention that we had a lot of challenges during this period, so that's why it's a bit slower. A slower process, but at the end we were able to achieve this. So we had obviously a problem with the energy crisis and so on. We also support the AI for Public Policy Horizon 2020 project with our cloud system. So this is again something that demonstrates that we are open to support international initiatives as well. And in the last 1 or 2 minutes, just want to mention that we have very strong connection and we are heavily engaged in an S3 project called Slices. And this was really the first in digital sciences that could enter the S3 roadmap 2 years ago. And the main focus of this Slices project is to support the development and research related to next generation of the digital infrastructures. So if you take a look at, we can see a lot of similarities to EGI, because this is, again, a distributed research infrastructure that can aggregate networking, computing, and storage resource facilities. On the other hand, the main scientific domain of what it tries to support is about around the networking protocols, radio technologies, data collection, distributed computing, and so on. So this is really purely about digital sciences. Okay, so we are there, and there are open calls in this Sciences S3 program. Actually, we are in the starting community phase. And there are also, you can do some experiments with these facilities around Europe. So one slide about that, how we can see our contribution in Slices to EOSC, and these are really related to that data and applications that are generated by these sciences research infrastructure, and we would like to make it available following the principle of open science. And also I have to mention that we can be considered one of the most important hubs in Hungary, since we also established the Research Data Alliance Hub 4 years ago, and last year we established the GaiaX hub in Hungary with support of the ministries. And we have lots of ongoing research activities here, so just to mention that we have research on orchestration tools and reference architectures as well, to make it really reliable. And this is, I think, one of the key issues, how to make these systems and these achievements and put in production and make it really successful by the user communities. So as a summary, our cloud research infrastructure are hand in hand in national labs. Also we support different universities, very well embedded in EOS-related activities and S3 activities as well, and we are welcome new users, and we are ready to collaborate with other national initiatives in order to approach even more new users. So thank you for your attention.
Questions? I have one question, which is about the cloud and the repository project. How do the two work together? Is there a data staging service from the cloud to the repo, or vice versa?
Yes, actually, here the cloud provides the storage facilities to the data repository, but in the future we would like to make it more interoperable and so on. But actually, the very first step is that to provide storage facilities to this data repository project. And also, since we can see some overlapping concerning the targeted communities, probably we can have joint activities here, joint trainings and so on.
Just a small question. You have mentioned about access to quantum computing. Could you please tell more about this? To which resources, what type of computers, and how it is organized from the point of view, let's say, availability for researchers?
Okay, this is a kind of, okay, I would like to find, okay, this is, so actually this is the very first step to access resources, for example, from URI. Using the standard interface they have, the Ocean SDK and so on. And also what we are doing here is to support not only this DBA resources, but also from IBM, Microsoft, and Amazon as well, to have at least a common interface to access these resources. The next steps will be about brokering, scheduling, and a lot of other things. So the very first step was about the demonstration that we can have access. They can be utilized from a single environment. And after that, there are a lot of open questions, how to make it really useful for the users. But here, this can lower the entry barrier to the users, as far as we can see. And we also maintain this reference architecture, so when a new technology arrives, or if there are new interfaces, we fine-tune this reference architecture according to these updates. Okay.
Thank you.
Okay.
Thank you, Robert.
Okay, thank you very much.
Let's move to Giacinto, who is online and who will talk about the Italian initiatives. I'm just pulling out your slides. Give me a second.
Okay.
Or actually, you share your screen, right? So I don't have to do anything.
If possible, I can do it by myself. Okay, let's try if it works. Hopefully you see my screen in presentation mode. Is it true?
Yes, we
Okay,
see it.
perfect.
And can you just transition the slide? Okay, it works,
Perfect.
and we hear you. So
Okay,
you have 10 minutes.
Thank you. Thank you so much to everyone and for inviting me to this to give this talk. I will try to provide a very brief overview on the services and the activities that are going on in this period of time, thanks to several project and initiative already started. So just going directly to the real important things. We started thanks to National Plan for Recovery and Resilient with quite a few important projects. In particular, I will show you details about two of those that are strictly correlated to our national computing and storage infrastructure. So the first of those two are what we call national centers for high performance computing, big data, and quantum computing. This is a typical hub and spoke approach where there are several thematic spokes plus one spoke that is related to the computing and cloud infrastructure. So spoke 0 is about indeed cloud and supercomputing, and the other 10 spoke is more on thematic topic, as you can see in the slide now. The idea is that this project is a very large project in terms of participation, both public and private institutions, both on the research institute and the university sites. Those are some examples of the partners involved. And here you see also the private company too. Just to give a very brief overview on the sides, the project is really a huge one with a lot of people and partners, and with a very large variety of interventions. So we go from open call that still has to be approved, and innovation grant that has some specific focus on providing innovative services, and together with the private sector too. So to be more on the INFN side, the role for INFN here is obviously to support thematic services in the context of high energy physics, but more deeply in order to support the computing and storage infrastructures at a national level together with SINECA and the GAR. Obviously, the splitting it's quite easy to guess. GAR it's working on the network infrastructure, SINECA on the real HPC center, while INFN is more strictly involved in the distributed computing facility. Together with this project, we have also Terabit, that is a research infrastructure project, so different call. Only three partners here, INFN, SINECA, and GAR, that are mostly complementing what is already funded by national centers with a specific set of services and activities. In particular, for what regard the SINECA, obviously the overall objective is to empower the HPC facility. You already, I guess, know a lot about what's going on at the SINECA in this period of time, so I'm not going into much details here. From the point of view of the network, we are in a phase where we are upgrading all the national infrastructure up to 100 or 400 gigabits per second, depending on the kind of nodes we are connecting. And thanks to these two projects and activity already going on, like RT upgrade infrastructure, we are going to have a very huge bandwidth at national level in the next few years. What is happening at the NFN side is that thanks to the complementarity of investment made on those two projects, we are improving and enhancing the distributed tier 1 and tier 2 infrastructure at national level in order to have more space for more resources together with more resources itself. And we are starting with a new kind of facility. I will describe more in details afterwards, that we call HPC bubble, that are distributed around Italy, and they are providing a complementary offer to what Seneca is already offering. And we are also investing a lot in terms of supporting disaster recovery solutions and space economy data center, specifically oriented data center. With the two specific intervention from National Center project. What is the overall approach of all those development? Basically, the approach is based on having a layered platform where you see at the bottom, obviously, the data center and the real hardware resources, while on those data center, generic services could be instantiating depending on the capabilities of each of the hardware. And thanks to those general services, you can build a specific user community service that are somehow customizing the general services, or just linking together as building block those general services. And then those very user-specific community services could be seen from the end users, like a data entry point, the data lake entry point for their specific application and data distribution. What was already in place, and we are going to further develop and empower, is the INFN cloud implementation. As you may already know from other presentation in the past, we are already we have already in production and federated infrastructure in Italy based on two sites that are tightly coupled federation cloud infrastructure that we call backbone. And on top of those, there are the possibility to federate others, data centers, cloud providers, or with other technologies that are somehow joining the infrastructure, accepting the same rules of participation and similar configuration. I will give you a bit more details in next slides. How this is built, we rely on the pass orchestration service that is already provided in several projects, and also obviously in the EOSC portal. Thanks to this, we are able to deploy services on very heterogeneous cloud infrastructure, even HPC data center, and provide a very high-level functionalities to the end users, like choosing the best hardware available, data location, or the good SLA for your use cases, etc. Obviously, we should share the AI approach. So we all the cloud facilities federated are sharing the OAuth and OpenID Connect approach via Indigo EM at the moment. And the basic idea underneath that is that we are going from providing a simple infrastructure as a service approach towards the more specific approach, where the platform and the software as a service is the way we propose services to our end users. Just obviously using the typical approach based on Tosca template that our pass orchestrator is able to implement. The idea is that the end user could land in a dashboard like the one you see here, where you have set of services. You see compute, analytics, machine learning, data services, and so on. And for each of those areas, you have a specific set of services customized for a given application or use cases. And so you can see from the very simple virtual machine to a sync and share as a service to a Spark plus Jupyter cluster or whatever. So that's a very large plethora of services already available, increasing time by time. and with the approach of indeed increasing the level of the services in the spectrum that I was showing before. Here you see how the end user could choose a service, a specific service, and customize those services, defining how much resources, which kind of flavor, and so on. And then it deployed the service with no knowledge about Tosca and even no knowledge about the infrastructure underneath. So just to know what are the resources supporting its specific use cases and its specific account, maybe. And then the services is deployed by the PaaS automatically. Not only services and computing, obviously, but also working on the data lake model. The idea is trying to reach the possibility to include any kind of computing facility from the public to the private sector, and optimize the storage in order to access very fastly the data in a very distributed manner. Thanks to the big network infrastructure we all build underneath, we can rely on a very performant network, but we can deploy automatic caching where needed, etc. So if you put all those things together, you see that obviously we can build a fully functional picture where you have the data managed like a data lake from one side, and you can deploy services thanks to the orchestrator from the other side. Obviously, when you go to the data realm, it depends on the data, and sometimes you really need to have very strict configuration, and so we have ISO certified cloud infrastructure. We are going towards an increasing of those resources and sites. We are going towards the certification of 3 different sites in Italy. Now we have 1. And this will give us the possibility also to provide the disaster recovery, high availability capabilities together with the ISO certified security environment. What we are going to start as a service in the near future is providing what we call HPC bubbles. Those are a small cluster, I would say, in some sense, sized in about half or 1 million euros of budget per each site. And we will have several of those sites around Italy. The idea is that we have 3 flavors on the computing side. We will have resources that are only CPU, so a lot of cores in the same motherboard, a lot of memory, and all those machines are InfiniBand connected. This means that even with no knowledge of HPC programming, you can leverage up to more than 200 real core on a given server. And this is quite useful for a lot of communities where small knowledge of programming are available. There are also flavors with the CPU and GPU. Here we plan to have a H100 from NVIDIA card, again with the same CPU and memory configuration and with InfiniBand connected too. We will also deploy FPGA service, at least a couple of vendors, sorry for the typo here, in order to provide different capabilities or different possibility to the people willing to test this specific capabilities. All those computing services will rely on 2 separate storage infrastructure based on a mixed approach SSD plus HDD. And this means that we will provide very fast storage access to those HPC facility, even in with remote network connection. The idea is that all those capabilities will be perfectly integrated into the INFN cloud services that I've already shown you before. And there will be obviously the possibility to virtually connect more than 1 HPC bubbles along the sites. And obviously the final idea would be that there will be a connection between those bubbles and the standard HPC traditional data centers. What we are going towards is that we will have in the very near future what we call continuum that will give us the possibility to leverage resources where there are and with the flavor there are. And so you can deploy services on top of standard cloud services or edge computing remotely based maybe on simple Kubernetes clusters or similar. We can federate both computing and the storage very transparent and from the end users. We are already putting into this game standard HPC centers because we have a lot of experience in already leveraging resources from Cineca to KNAF, for example. And the idea is that in this way, the end users could just log in into the system, deploy the services, leveraging the resources he really needs in terms of hardware capabilities or dimension, etc., without a deep knowledge on the full plethora of services available underneath. And that's the way we are proposing this evolution, thanks to obviously the project based on national resilience and recovery funds, but also on the initiative already going on through different European and national projects that we already know. Together with the hardware and services, we have already refactored also the organization in terms of working activities. We have now a big working group that we call Data Cloud that is split a lot in quite a good number of work packages.
Giacinto, sorry, the time is up. How many more slides do you have?
No, I've finished already. So okay. Those are the list of activities we are carrying on, split across the different work packages, and that's done for me.
Thank you. Thank you. Time for a question. Okay. Vladislav, if okay. Just a second, the mic is coming.
My question is regarding to the financing sustainability. User should pay for this infrastructure from Italy as a pay-per-use model.
Okay, that's obviously an interesting question and quite hard to give a general answer to that. This really depends on the way the user come from. There are users that are somehow pledged for the resources because they are core users from some of the partners joining the effort. The National Center for HPC, so the project is starting up with a specific body that is a private body, and they will try to gather also support for long running of those infrastructure from the people willing to leverage those services. And some other institutions, for example, are joining the effort with their resources, for example. So they are providing resources for their own use cases, but joining the approach and the software layer, I would say. So there is a very large mixed of solution depending on the context. So each of community are trying to support, obviously, this effort for the long-term period. Just also because the project are asking us to keep this running for a long time itself. So that's in the plan.
Very much, and I would like to move to the next presenter, Jérôme. Can you put this screen back? Okay, cool.
Hi, good morning, everyone. I'm pleased to show you the French strategy for the development of open science in France. in particular in relation with EGI on EOSC. Main information are taken from a talk that Volker Beckmann gave last week during the tripartite event. So I give him many credits for the slide. And there is only a few slides. There is less than 10 slides, but there is many information on them. If you have any question, do not hesitate after the talk to ask me, or later on during the break if you have a question. So, as all of you, we are facing many challenges. First, we are facing fast increasing needs for services to manage a large amount of scientific data and also a large diversity of scientific data. And all this data has to be fair by design. To answer these needs, we are providing resources since several years from now, ago. But what we are now facing is a really decreasing human resources in many laboratory. That's come because people want to private sector, or we have also difficulty to hire new engineer to join the laboratory. So that's for us very difficult to stay with always the same amount of people working on the project. So to mitigate this issue, we are trying to share best practices, knowledge, and to utilize many kinds of infrastructure on services. I will show you this later by creating bridges between research infrastructure, different kind of thematic domains, infrastructure, and services. So that's like what EOSC does at the European level, and therefore for us is EOSC a very important part of the solution, either in France but also with colleagues of Europe. For us it's very important, and it's for us a new kind of humanism for both broadcasting scientific knowledge and data. So a few words about EOSC in France. For us, it's very important to include all the services EOSC can provide to the researcher in France. And there is, for this, we have created a college, the EOSC France College, in 2022, which is composed of many representatives from French organizations. And each for this, French organization have to be member or observers from the EOSC ISBL, and there is also a representative from the ministry, of course. And this college try to give advice and propose action concerning the building of the next landscape of computing, data, on digital infrastructure in France. This is done in relation with the committee pilotage, the steering committee for services on digital infrastructure. There is many working groups around this. I will not show you all the committees that have been created. There are too many, and I can send you the diapo if you want, but the slide if you want, but there's no interest for this, I think. And we try to have a strong link between user communities, deciders, on what will be done, because we have we could see that there is a very weak link between the researchers and the EOSC, and we are to enhance this link so that researchers know about EOSC. For example, one activity currently is to deploy a national EOSC portal with a French translation, and this is fully compatible with the EOSC portal, so that we can help to enroll on the EOSC portal, each services that could join the EOSC. We try also to be very involved in the building of EOSC. We have many French partners, and that either university, research institute, laboratories, by providing services, by providing time to EOSC working group, for example, semantic interoperability, technical interoperability, sustainability, and so on. And we are trying to provide services to EOSC, but that's we have always to convince people that EOSC is really important and what will provide EOSC for them. So that's we have to. That's a day-to-day work, an important day-to-day work to convince them that they have to go to EOSC. The EOSC France College is the national EOSC initiative and is officially appointed for this by the ministry. And this college is trying to link all the initiatives in France. Also France Gris is one of them, but there is another project, mostly financed by new Equipex projects that are called Maisonette. That's more HPC, small regional HPC centers. And what is difficult with, so for example, these HPC centers, they are regional based. They don't have a strong link with EOSC because most of their customers or researchers are from the university they are hosted. So we have to link them all together and make them connected to EOSC. There is other kind of Equipex like the Gaia Data or the Moody's for LS. Gaia Data is the one from the Data Terra research infrastructure for its observation, and Moody's for LS is from the bioinformatics French Institute, who is connected, who act as a Elixir node, and we are trying to merge, for example, all the hardware part, all the hardware hosted in data center, so that all is mutualized and managed by the same team, and provide the same level of service for each kind of projects. So this is all going to work, and I don't know exactly how the landscape will look like in 5 years from now, because there is lots of discussion on a lot of place for each partners to evolve. We are trying to provide storage, processing, networks, solution for each user in France. And France should have the role of linking all this infrastructure as we do since 13 years now. The discussion is currently ongoing at the ministry level to know how it will evolve in the coming year. Probably that France Gris will disappear as itself, and we move to another kind of either organization with other kind of rules. For example, currently France Gris cannot be part directly to Hash 2020 project because it's only what we are calling GIS, so in a scientific interest group, and has no legal presence. That's always a representative either from CNRS or from INSERM that act as representative, but it's not a real legal entity, and we have to modify the status of France Gris. So either we want not to only change the status, but also change the name and the scope of France Gris to be more inclusive and be able to make the link between all the French partners. We are acknowledged as a key actor for infrastructure in France, and in particular distributed infrastructure, either grid, cloud, storage. We are working a lot on interoperability because we are connected with AFP, with Tatatera on Maisonnet. And what we are doing that most of the other in France are not doing is supporting for the long tail of science. And that's very important because there are many researchers that are not covered by the large cluster, scientific cluster, and we should always have a solution for them. We are one of the French infrastructure who has the most relationship with European partner, in particular, and thanks to EGI. And that's a very important role that should be taken over by the next infrastructure. And we are also trying to offer technical coordination between the regional computing centers who are involved in the other project. As I told you, transition is underway, and I don't know exactly how it will look like in a few years, but I hope that, like I could see before in the presentation, we'll have something more integrated and more simple to show to the researchers. So we are still doing lots of coordination and organization of IRSC-related events in France, for example, the 2022 5B meeting in Strasbourg, or the French IRSC technical workshop in January these years. All of these events have a lot of people, always around 70 or 100 people who are coming to the event. So I think that's very important to continue the animation of IRSC event in France with France Gris, and in particular on the technical side of IRSC, and we'll continue to do so. There is a small link also to the research data gov project that aims to provide a data repository for the long tail of science, but it's a very organizational project, and the data will be stored directly by the partners. So, for example, for Strasbourg, the data will be stored provided by the university through the S3 endpoint. And we have probably also a role to play for linking this data gov project on the IRSC organization at the European level. So lots of things to do, but always less people for doing this. And I think you can see that today because we are not so many French people at the conference. It's a miss, but I hope that the next year will be much more people, French people here at the EGI conference. Okay, and for finishing this talk, a short thanks to Geneviève, that is now retired. I think most of you know them. And so if you have any question, feel free. Thanks.
So where are located mainly these resources in CNRS, or how are you also interconnected with universities in France?
Now all the resources are coming both from CNRS and universities. For example, in Strasbourg, some resources are provided by a laboratory who is called UMR. That's a mixed research unit that is both funded by the university and CNRS. The University of Lille is also providing resources. The cloud, there is a cloud who is connected to EGI Federated Cloud, who is hosted by the University of Lille and is 100% funded by the University of Lille.
I see in Europe, so there is some more or less independence of the university. Typical situation is also UK. So this national, how to say, this activities not such looks like the national. It is more or less in France. It is the CNRS. For example, in Slovakia, it is also that this university want to be a little bit independent and build also own this infrastructure. So therefore, this nationality of this environment is not such working very well. And also, it is not provocative question, but sometimes I'm receiving this question: how you can imagine is if you will be not in the partnership with EGI, if you can do everything at the national level, so without EGI, or you need this EGI? You know, so it was a question, I raised this question at home, so what is your opinion about this? So.
I think a simple thing what we could not do without EGI, for example, is security. We are working on distributed infrastructure, and security are mostly not high enough in our priority, so not mine, but from the ministry. And we don't have enough people working on security. And joining the security network from EGI is very important because we can share all the expertise, and we will not have the same added value only if we will work in France. And I think that's the same case with other kind of services. For example, with the OpenStack, we are sharing lots of information or best practices with colleagues from Europa, and all this network is managed by EGI, and that's, I think, very, very important things for us.
Thank you, Jérôme. One point on this changes in the legal structure. I mentioned you this privately yesterday, but probably Matthias will talk about the event we had to organize in Austria to kind of re-energize the community. Mm-hmm. And that's something that we are happy to do similarly in France or in any other EGI member country, or even in other countries that are not yet EGI members, to bring together the knowledge from EGI, show what we do, what we can do for that country, what's the value of joining EGI, and also bring the national entities on the stage so they can also better know each other. So that's an offering, basically. Thank you.
And that nicely links to the next presenter from Austria, a recent, relatively recent member of the EGI Council.
Thanks a lot. So yeah, hi. I do want to talk about what we are doing currently in Austria to increase a little bit the EGI and also the EOSC network. Scientific collaboration in Austria is most of the time going via ACONET. And ACONET, in fact, is an acronym for two different things. Once it is referring to the Austrian NWAN that you are seeing here. The ACONET Association is monitoring and managing this NWAN, and I have already shown a kind of a slide like this last year, but currently ACONET tries to enhance this NWAN in a way that we want to have, hopefully until the end of the year, in all over Austria, 100 gigabit connections to all the members, all the universities and other scientific partners of ACONET. Additionally to that, from the loop in Vienna, there are a lot of connections to international networks, and since this year we also have a connection more in the, in the west of Austria towards Germany, which mainly is meant as a fail-safe system in case that the Viennese loop is going down. So we don't want to have everything only on the capital. The other part of ACONET, now written in a different way, completely in capitals, is the ACONET Association, and they are existing for providing services, same idea like in the EGI, several services for the Austrian community. I will not go through all of these ones here. Mainly I want to mention here now the Identity Federation and the cloud services, because I will talk about that also in the follow-up slides. If you want to have other more information on that, you can just ask me later, and we can talk about all these services that ACONET is providing to the Austrian users. So among others, they were negotiating kind of framework agreements with several international cloud platforms. Some of them here are also part of the EGI, but we are talking also about Google, about Amazon, IBM, and so on. And the idea here is this is a framework agreement, or these are framework agreements in case that users do also want to have negotiations with these entities or work on these entities. They just can refer on these framework agreements and kind of easily have then access also to these international platforms. The Acconet Association, as it is, also has some additional activities in a way of being mandated organizations to international federations. We are talking now here often about EOSC, of course EGI since 2022, but also Acconet is a mandated organization for Austria in the PRACE network, and they are also being the legal structure above the AQNet, which is a quantum computing network in Austria and connected to Europe. I was talking about that, in fact, last year. And today I want to talk a little bit more about the idea that Acconet is presenting Austria in the EOSC and in the EGI. EOSC, in fact, has a kind of a top-down approach in Austria. So the Austrian government decided they want to be member of EOSC and is paying for that. And they asked now the Acconet Association to be the legal representative to EOSC. And with that, they were building up the EOSC Austria initiative, the EOSC Support Office Austria. And there, in fact, since the government was, the very first step was the government decided we will be partner, and after that was mainly everybody was jumping on top of that, and they were building up quite fast a really big, relatively big association for Austrian cases to fill up this idea of that Austria is part of EOSC. They have a lot of working groups where they want to, well, mainly have the objective to build a combined Austrian contribution towards the EOSC idea. But directly after this building, all these working groups, it mainly stopped. All the targets that they want to realize and that they are realizing, they are mainly doing with the help of scientific projects, where then some minor tasks are also going towards EOSC. And this is in Austria at least a kind of a problem for the EOSC member society. That there are a lot of ideas, but not really the realization of that, because they all the time have to wait for the next scientific project that they can do their stuff. The EGI initiative is in fact quite the opposite approach that came since, I don't know, maybe 2016, it was before my time, that there were several scientific projects in Austria where the cooperation, the partners, decided it would make sense together to also join the EGI to see if that brings them an additional value, to connect not only between themselves and within Acconet maybe to Austrian users, but also directly to the international community. And you just see here the logos of the partners. Many of them are here in the east, in Vienna. But we also have the University of Innsbruck in Tyrol, and in Styria, the University of Graz. And they together were connected with several scientific projects via the Acconet network, and now via the Acconet are also going to the EGI. The issue there is, it is directly now a bottom-up approach in contrast to the EOSC approach. This is mainly done by a specific scientific community, which is Earth observation. And we are now in the second year of the Austrian membership of the EGI, and our main goal now is mainly to enhance exactly this national organization, this national consortium. So we do want to have more user communities. We also want to have, on the other hand, more entities who would like to participate. And when I say we, since it is a bottom-up approach, it is mainly me. So I am the one who is in the moment in Austria responsible for the EGI membership. And I was trying now to enhance exactly this national consortium in a way of what Gergely already was saying now. We have several user workshops. The last one was in end of April of this year, where the EGI was coming to Austria, showing us what they can do. We were together with EGI and Acconet trying to show the users how they can reach the world from their own computer, via the Acconet association, via EGI, to whomever they want to talk with. And we do have some careful success of some first partners who would be interested also to join the Austrian network. We are currently in negotiations with them. I hope that in the next weeks or months we can have then the next steps on that. Here is again to say we also try to have some kind of joint events together with EOSC, but since they really still have the problem, they have a lot of working groups, but not really ideas or people who can fill that. At the moment, in Austria at least, EOSC has the problem that they have a lot of ideas and no way to realize that. So they could not do workshops together with us to show something. Another strategy that I have now since maybe 2 weeks, I did receive a first version of an impact report from EGI in Austria. And there I have seen that we have several entities in Austria who are at the moment still talking with EGI around Acconet. So I will see if they also can join the national grid infrastructure, so the NGI in Austria, to participate also officially in the Acconet association. And in fact, this is what we are doing currently. I still do have sometimes an issue with, from the EGI perspective in Austria, with the EOSC strategy, since EOSC were the first ones in Austria really doing such a network. Their idea was that they just are responsible for everything. And when I'm now talking with people or with entities, why not also join the EGI network? Then they're asking, but this is already done by EOSC. So this is at the moment currently an issue that I have, but luckily I think 2 or 3 weeks ago I have seen a really nice presentation from EOSC itself, what exactly they are doing, or mainly what they are not doing. And exactly this is for me now the help to show the people what EOSC is not helping and where EGI can jump in. How that will work, I hope the next weeks or months will tell. I hope that maybe next time when we have the next EGI conference, I can give a little bit an update on exactly that success. Yes, and with that, I do want to end already. It was just 10 minutes. So do you have some questions? We also can talk afterwards outside if it's a little bit longer.
I'm curious, what does EOS not do that we do?
What does EOS not do? I was expecting such a question, and exactly that's why I have a follow-up slide, what EOS is not doing. This is exactly the slide that, can I open that here? Yeah, this is a slide that EOS was showing me 2 or 3 weeks ago. It is quite new, it's still not finished, but this is exactly what they are deciding that EOS is not doing. So they are not a cloud infrastructure. They are just bringing together different cloud infrastructures. I think we had yesterday or the day before yesterday such a talk that EOSC is another cloud infrastructure or whatever. In fact, they themselves declare themselves they are not. And mainly what I see of the talks that they are having now, they are data providers. So they are making sure that somewhere data can be stored, but they do not really want to go in the idea of data processing or something like that. So they are more in this fair idea, fair of data. And with this information, I newly try to go around that big bunch of information in Austria and tell the people that EGI is doing also other stuff, which is not done by EOSC, as you see here. Yes?
Vladislav.
I'm wondering for money, from where coming this money? From the Austrian budget or governmental budget or somewhere else? Or how is this more or less to...
The EOSC membership, the funding comes directly from the government. The EGI membership comes from, at the moment, from these 7 partners that you have seen here. So
no, for the membership, but to keep this and maintain this infrastructure. So when to more or less to buy some this new this cluster or something, new hardware and.
Well, when we are buying in Austria clusters and hardware, this is mainly done by project funding. So these 7 partners here plus 2 more, wherever they are, we did win now another Austrian, a project where we are building up joint infrastructure in Austria among these partners connected by the Argonet network, and we are also planning to connect this infrastructure to the EGI network. So, but long story short, that all the time comes from research funding.
In Slovakia, so this money should come from the structural funds, from this recovery plan, from the Europe and so on. So this is not such money at you. So, for example, now Slovakia want to buy for the 70 million euros one supercomputer from these structural funds. No.
Well, we do have in Austria, we have the Vienna Scientific Cluster, which is also a supercomputer run at TU Wien, and they are receiving money via a lot of governmental funding and so on, outside of the idea of EGI. But since they are part of TU Wien, which is a member here of the National Grid Initiative, that's why we also can connect the Vienna Scientific Cluster towards the EGI. The question, of course, is whether they do want to be connected. And this is a completely different topic.
Okay.
Yes.
Thank you, Matthias. I suggest we move to the next speaker. So Jerry from Ireland, and not yet EGI member formally, but we have a strong working relationship in a recently started project. Coming. Yeah.
Thanks, Gargle. Yeah, so we are nowhere near as advanced or developed as some of the previous presenters, but I'll go through some of what we've discussed. Just one point, we've had a lot of rebranding, renaming, mergers and stuff like this, so no one's probably heard of Walton Institute. You may have heard of the TSSG, which is Telecommunications Systems and Software Group. We were that for 25 years. I was in Waterford Institute of Technology, but we merged with Institute of Technology Carlos, so we're now the Southeast Technological University, so I just want to get all of that out of the way. In Walton Institute, we're about 80 researchers. We're a mixed bag of people. You can see what we are. And we have different research topics around mixed reality, cybersecurity, molecular communications, electronic textiles, quantum communications, and research infrastructures. We've been working with virtualization since around 2006 across a different variety of them. And we've mainly built research infrastructures for our own use, for our own researchers, but we've expanded into European infrastructures over the years. There's been a bit of a gap, but we've kind of come back. From a national scene, the Irish government is actually pretty poor at funding national research infrastructures. They're pretty good at funding researchers and groups of researchers for infrastructure, who tend to hold on to it and keep it for themselves, but as a national strategy and a national infrastructure, it doesn't really happen. For example, we have one HPC system. It's 5 years old. It's not currently being replaced. So that would kind of give you an indication, and the value of it is a lot less than that number I just heard a minute ago. We're also very slow to sign up to European initiatives. If you look at the S3 roadmap, you'll see that we're signed up to very few of them, if nearly if any. And the Irish government wants to see a critical mass of end user support, of end user need and end user requirements. And sometimes this is really almost industry need rather than researcher need. So they want to see research outcomes that are primarily going to lead to jobs, job creation. I think that's where their real interest is in science. So for us, you kind of have to build that need, so we have to work from the bottom up. And with that in mind, in 2021, we contacted EGI. We had a couple of chats with Tiziana and with Gergely, and we decided that the iMagine project might be a vehicle to federate one of our clouds in Walton with EGI. So we established an NGIIE. It's not formally established, but it's established from a systems point of view. And we built a standalone Walton Cloud to federate in, primarily because it's going to be a learning experience of joining EGI. We've had a few challenges that were interesting, but we've gotten there anyway. We now have 2 VOs deployed, and even better than that, we're starting to build this case for the national infrastructure in Ireland. So we have these 2 VOs. We've been approached by other researchers in Ireland who've actually approached EGI and have been referred back to us about using our resources. So we're starting to see now that people don't know who to contact in Ireland, don't know how to get the services that they require, but actually have that need and have that demand. So this is very advantageous for us because it now starts to bring us all together and we can build this use case. Software vulnerability groups advisories are very useful because again we have multiple other clouds there and those vulnerabilities tend to apply to that as well. And it's just the catalogue that's available through the EGI marketplace. Those services that are there around data management, around all the different automations, provisioning, replay, stuff like this. This is a scale that we certainly can't do, and even in the national context in Ireland, I don't think we'd be able to do. So this is another kind of critical selling point. Another project that we have in Ireland, it's a pilot project. So this is one of the few top-down initiatives from the Irish government, and it's really around open data and access to data. So this is the one that they've kind of grasped, not so much around anything else. So we have a project called IRL-DAT, which is a derivative or a take on the EU DAT platform. And we are looking at creating a shared data storage service pilot, but this is purely for active research. Now, the goal of this project for us, it's up there, but reality is it's capability building within the Walton Institute, and it's also around lessons learned. How do we turn this into a form proposal to the government? How do we bring this forward? The other aspect that we have with this particular pilot project is it's about the active research data, but there's no mention or indication of how you process that active research data, what happens with it. So it's purely as it's live, so there's nothing about archiving, there's nothing about processing or using it. So as a standalone, it's actually, in my opinion, not much good on its own. We're currently in phase 2 of this project, and phase 3 then is defining how we're going to integrate into the broader EOC landscape, but we're also got a particular interest around sensitive data. So that kind of leads me to some of our future plans. So we're now about to deploy our new cloud environment. We're out to tender for compute, storage and networking equipment on this, but we've also got to focus on the security services. And so we already have the quantum random number generators there for a lot of entropy, and we've got these hardware security modules. So these pre-exist, and we're looking to integrate those into the cloud. So with OpenStack, we've got Barbican, and Barbican will allow us to do an API directly into the hardware security modules. So we're looking at volume encryption, so we're looking at securing this data at rest. We're looking at the ephemeral disk encryption, again, so kind of protecting the disk from the administrators of the hypervisor, and we're also looking at the image signature and verification. So you've uploaded your image, it's there, you're using it, just to make sure that, again, it hasn't been manipulated with. The Thales system, to give us nice, secure, multi-key approach into the system. All the cryptographic operations happen within the HSM, so this is a kind of a very much validated, authenticated system. We can run this in FIPS 14-3 compliance mode if that's what we need. We've also put in functionality modules because, again, we've an interest in post-quantum cryptography algorithms. So we can actually deploy those onto the HSM, run them in the secure memory space within the HSM, and use that again as a service. So this is all kind of leading towards a USP around our cloud, because it's going to be quite small, but this is part of our selling point to the Irish government, and I'll get to a bit more of this. The other thing that we're doing is we're going for CPU enclaves. So we're looking at the AMD EPYC processors, and the particular reason for this is it effectively encrypts the memory on the server. It encrypts the bus, The only time the data now on the server will be decrypted is when it's actually on the CPU. So even on the bus to the CPU, it's encrypted. So this gives us a very high, but not a complete level of secure computing. And again, the reasons around this is we're looking at, can we process someone's IP? Can we process medical data, pharmaceutical data? Can we process something that is very sensitive and very valuable? And can we bring those users into the cloud and into the overall federation? From an Irish perspective, operate and things like that, we're about to upgrade our network connections to 100 gigs, so we're looking at a 100 gig capable transfer node. But again, we also have that IRL.EU project that we do hope will expand. So again, we're looking at a node from that. And obviously you've got an EGI data transfer service as well. So I see that there's some of the technologies that the EGI data transfer node and the JN data transfer node, they share the same, so grid FTP, XRootDs, things like this. So I'm wondering again if there's a mechanism to integrate these together. And then lastly, we have a couple of open problems. One is securing the funding to expand, particularly national funding. So we have to build this case, we have to build it from the bottom up. We have to see what we're going to do there. And then the other one is how you securely transfer the data. We have a few ideas around that. I'm going to leave it there. Thank you.
Question? My question is about which other institute do you think could partner with you to formulate an NGI, just like in Austria we heard it.
Yeah, there's quite a bunch of them. So there's two of them. So we've got the Irish Centre for High-End Computing. So it's their they have the supercomputing. So they're a definite first candidate. The other thing that we have in Ireland is Science Foundation Ireland, one of the national funding bodies. They have this concept of research centres that they developed over the last 10 years or so. And within that, we have one called Connect that brings 10 universities together. So again, I think if we take something like Connect with all their expertise, so Connect is around future networks and communications, you take the likes of iCheck and you take some of the other research centres, that is a large-scale cluster. We'll nearly cover off every university in Ireland. We'll cover off all the researchers who would have a level of interest in this. And again, I'm sure there's other research centres that would be more end users and application users on this that we'd have to reach out to. So the clustering is starting to happen. It's just it's a case of reaching out and bringing these people together. So your suggestion earlier that you might be able to come and do a workshop, that sounds very appealing, and I think that could be a way forward for us.
Thank you very much.
Yes, thanks.
So now we move to another continent and start with a talk from Taiwan by Eric Yan, who is a long colleague of EGI. We worked together in many projects, so I'm looking forward to your talk.
Hello, everyone. Thanks, Gergely, for the providing opportunity to update the collaboration in Asia, focusing on disaster mitigation. As Gergely mentioned, that actually the collaboration in Asia has been initiated from 2008 by the UH funded, European funded project. And also later, this collaboration is supported by the EGI Engage from 2015 until now. So the vision of the collaboration is for the about the sustainability, which is the common goal of all the partners. And the long-term goal here is about the capacity development of the hazard risk analysis based on the numerical simulations. And here we highlight the deeper understanding approach. Means that for each case study, we have the group of scientists identify the root cause behind the event and to improve the numerical simulation models and also the applications focusing on this event. And then once the case study has been accomplished and the simulation services could be applied to other cases in different countries for all the partners. And based on the open science idea, all the data, tools, services, and knowledge, everything from the case study will be shared. Once the case study is concluded, based on the open science mechanism suggested from the EGIS. So this kind of collaboration model involves different parties, especially from all the partners, including the scientists, the end users, the service and the infrastructure support, etc. So in the past few years, we've been keep on supporting new case study and facilitating the regional collaboration from all the partners. And recently, we are also integrating the Earth observation data and also the remote sensing technologies to support the disaster risk analysis. So the scope of the collaboration actually involves the from the infrastructure, the application level, the collaboration platform, the open data to the open science, which is going on. Usually we have the routine activities in Asia. For example, we have the International Symposium Grid and Cloud hosted in Taiwan every year. So together with the Supercomputing Center in Munich, we host the joint workshop on environmental computing and also disaster mitigation. Recently, this workshop has been extended to energy saving issues. And we also work together, meet up together in the APEM meeting twice a year, hosted in different Asia countries. So all the partners will update their progress and bring up their new requirements for new case studies, and also, of course, bring up the users. And we also joined the EGI conference for the updates of the collaborations. Yeah. And here is a summary of the case study we've been carried out in the past few years. Before 2022, 18 case study has been concluded of 5 hazard types. And in recent meeting, the lightning was also mentioned, but it's issued by the Bangladesh. But unfortunately, we are still waiting for the observation data. And the medical-related hazards is also mentioned by Pakistan and other Asia countries. Now this type of hazard is in charge by the Japanese scientists in Tohoku University. I think in next APEM meeting there could be some updates from this new case study. Other than that, in the EGIS, we also include the agriculture applications to this collaboration together with Thailand. That's the extension of the, for example, the risk analysis from the extreme weather situations to the impact to the agriculture areas in the northern Thailand part. Additionally, there are also several new case studies, for example, the air quality monitoring, the Honga Tonga volcano eruption caused the tsunami, the environmental impact of the large scale and wind turbine, and also solar panels, and also earthquake monitoring. For the open data and open science, I've been mentioned that. So based on the requirements from the open and sharing all the things from the case study, there should be a supported infrastructure and also the platform for this part. And of course, the simulation portals of different types of simulation tools are ongoing. Integration of the Earth observation data and also analysis are also happening. I will have some later slides showing this part, and also to integrate some machine learning enabled analysis to the case study. So this is the typical workflow of the a deeper understanding approach here. The key point here is that the observation data required for the case study has to be in place before the case study could be carried out. And also we hope that all the there could be scientists and also user community from the partner country could also join here. And open and sharing data is important. So the Super Typhoon Haiyan case, which caused more than 4,000 life losses in Philippines, is a typical case study of this collaboration. The key point here is that scientists integrate the atmospheric model together with the oceanic models in this case. Otherwise, we cannot accomplish the whole life cycles from the bone of the typhoon until the impacts of the storm surge. And the later, we also extended this case study by incorporating the Earth observation data to monitor and tracking the recovery of the impact areas in Philippines. So that's a typical case of the case study. And in collaboration with the Sentinel Asia, which is focusing on providing the satellite images in time once there's any hazard event happening. So we can take care of almost all the stages in terms of the disaster management workflow. So from the risk estimation before the hazard, and also to the recovery, making use of the Earth observation data. And some new case studies will be very briefly introduced here. This is about the real-time monitoring of the air quality forecast, and also in the future days. That's developed by the team in Academia Sinica in Taiwan. So in order to build up such air quality systems, the team also developed the high resolution forecast and also dangerous systems in Taiwan, which could be extended to other areas in Asia. Those work including the, there are some thumbnails in the website with the URL on this slide, and covering the improvement of the WRF-CAM models, including the integration of the land use urban canopy model and also the boundary area models to identify the gaps between observation data and also the model predictions, and improvement of the simulation and forecast models from regional to any specific areas in Asia. For the Honga Tonga volcano eruption case, usually for the tsunami simulation, we need to have quite exact the parameters of the hypocenter. But for this case, the tsunami induced by the volcano eruption, we cannot have any hypocenter data beforehand. So the scientists decided to do the simulation, making use of the symmetric, the point source, a significant point source as the source of the earthquake. So the simulation could be done within minutes. And the suggestion that there will be no impact of the tsunami caused by this event will be issued. So now we are working together with Thailand between the National Space Center in Taiwan and also Thailand, working on the paddy field monitoring and also the analysis of the rice field growth studies as the one of the new case studies extending the agricultural applications in this part. And this is a simplified infrastructure for these collaborations, including the software as service in terms of the research environment. And of course, we hope that the AAI and also some of the services could be interoperable with the EGI infrastructure. As a summary, more case studies happening, and we are moving forward to share everything from the case study and also to develop the new simulation services from the collaborations. So in this year, we have 2 APEC meetings in August and also in January next year, so that partners will meet up there. And otherwise, you are also welcome to IGC next year for the to have more detailed discussion about the collaborations. So that's the briefly update of the disaster mitigation collaborations in Asia. Thank you.
Sorry for the terrible timekeeping. We have still one more presentation, which I don't want to skip. Shang Kwan from Korea, who is a new lead and can bring in a new perspective, I think, to this community, will present the data commons approach in Korea.
Thank you for the short introduction, Gregory. This time I'm going to talk about Korea Research Data Commons. I'm focusing on research data and software. I'm from KISTI, Korea. This is an outline of my talk. I start by introduction of my organization, KISTI, and then I'll get into the data on Korea Research Data platform. And then I'll introduce the extended data on, and then I'll close by introducing roadmap for open science activity in KISTI. Actually, KISTI is the only research institute designated by the Science and Technology Framework Act in Korea for establishing national science and technology infrastructure. It consists of 3 major divisions, National Science and Technology Division, and Supercomputing Division, and Data Analysis Division. I'm from the first one, National Science and Technology Data Division. There are 3 major open science-related services in KISTI: Access On, Data On, and Science On. As the name says, Access On is related to the open access article aggregation service, and Data On is National Research Data Management Platform, and Science On is an open science portal. It's integrated with on top of Access On and Data On and another KISTI provided services. At this time, I'm focusing on Data On, National Research Data Management Platform. Actually, the Data On is an aggregation service in Korea. So we are focusing on 2 kinds of research data platform or repositories in Korea. Usually we are focusing on government-funded research institutes. So the domain-specific research data platform or institutional data repositories. So we have 2 kinds of platforms or repositories. We gather metadata of research data from those kind of platform or services. That's our goal of the platform. So until now, we have more than 17 repositories or platforms are connected. This is conceptual diagram of Data On platform. It has several services here. Integrated search, Jupyter, and VM support, and so on. And it connected with the domain research data platform or institutional repository using CAFE, Korean Access Federation, which is developed by KISTI. And then we also trying to connect international organizations like OpenAir, ARDC, NII, and so on. So the Dataons provide several kinds of services here, including registration, preservation, discovering services, and also provide the repository registration interconnection with other platforms. and also provide repository hosting services for those who have their own repositories. And additionally, we also provide virtual research environments, so-called data on canvas. I will explain in the next slide. And we have more than 1.2 million metadata, including 37,000 Korean research data, and also provide 5.6 million of figures and tables from the research data R&D reports in Korea. This is data on virtual research environment. It provides a Jupyter Lab and GUI-based workflow engines and workflow environment so that the users can drag and drop style of making workflow or pipelines. The Canvas provides more than 100 applications on top of this Canvas. But this Canvas is comparably easy to understand, easy to use, but this Canvas is tightly coupled with Dayton so that it can be extended to another system, like it can be integrated with another repositories or platform in Korean institutions. So we apply the KRD's concept. I'm revisiting this slide. Dayton is focusing on the data, research data, but this time we are focusing on the software itself, sometimes software source or software applications, software services, and so on. So most of the platform or services are developing their own platform for analyzing software or distributing software sources. So we are focusing on this research software. So we introduced two kinds of component or concepts, KRD's Hub and KRD's Framework. KRD's Hub is a kind of aggregation service for research, metadata of research software, and KRD's Framework is an running environment of research software using Kubernetes, Docker, and so on. So the concept of KRDC is like that. KRDC is a concept for jointly utilizing research data and computing research software. And it consists of, as I told you, two main components, KRD Hub and Framework. But currently we are developing different independently with data on, but later on we will integrate both components into one. So we call it extended data on. This is the interconnected diagram of KRD's Hub and KRD's Framework here. As I told you that KRD, sorry. Oops. Okay. I told you that KRD Hub is a software cataloging service. And we can see here KRD's Framework clusters. This will be distributed to the several institutes like government-funded research institutes for biology or materials and so on. So KRD's Framework is a cluster for software development, management, execution framework. So someday the openly available softwares can be aggregate to the KRD's Hub like this. That's our goal, and so we are developing these two components. This is the minimum viable KRD's version will be developed at the end of this year, but I'll skip this diagram. Actually, KRD's Framework is the core part of KRDC concept, so the goal is to interconnect research data commons of government-funded research institute in Korea, and at the same time share computing resources as well as research data. So it will be integrated with data on, and the first version will be developed at the end of this year. Last year we developed the prototype version of KRDC. The KRDC framework is developed using open source. So a lot of open source components are consist of KRD's hub and KRD's framework. Okay. This is the roadmap for open science activities in KISTI. In terms of policy, we are preparing a new role related to open research data. So we hopefully in next year it will be established. And in terms of data management, we are continuously extending the data on. And then we are currently preparing the KRD's framework and hub. And then at the end of maybe 2024, we will integrate data on and KRDC at the same time. This is summary. I'll short it. Actually, most important thing is that KRDC is a framework, and we want to distribute this KRDC framework to the institutions who want to build their own software development environment. So for free. So it will be shared with other institutions for effective sharing and utilizing computing resources in addition to research data. Okay, that's all. Thank you for your attention.
Thank you. Sorry, because we are running late. Okay. I encourage everybody to engage with the presenter after that, and I'll let you to continue. Sorry for the delay. This is my laptop, so I don't know how you want. Okay.
So we are now moving to the agriculture session related with the data spaces and AI. And there are a few presentations, and the first presentations will be done by Raul Palma, that is working at Poznań Supercomputing Networking Center. This presentation will be about the agri-data space and the efforts towards the design of it. So, Raul, please come here to the... Coming? Okay. That's great. Yeah, okay, so hello everyone, my name is Raul Palma. I am going to be presenting a bit of the introduction to data spaces in agriculture, in particular related to our project, which is called Agri-Data Space. So just to start with this, basically the agriculture data space is one of the initial common European data spaces that has been identified by the European Commission. Of course, it's also part of the European Strategy of Data. And as such, as any other data space, it has, this kind of characteristics. First of all, about data sharing. So there is a lot of importance in the way of collaboration and the use of data for a shared goal. There is also this, of course, the data space is part of an ecosystem, right? So there is many components that generate, store, and manage the data. But also there are, of course, existing digital platforms that are, comprising all this infrastructure of the data space. So one of the key aspects that we will be discussing today here is about the need for ensuring sovereignty and especially interoperability. So what is Agri-Data Space? So Agri-Data Space is a CSA project that has been funded by the European Commission through the Digital Europe program. So this is a 18 months project. So probably you have heard also already some of our sister projects like GREAT from yesterday. And so this is the set of partners that are involved in the project. So what are we doing, or how we are going to provide the outcomes of this project? So basically we have like three main steps here in our methodology. Starting to understanding the existing landscape, so mapping what is currently available, mapping to the different countries, what are the existing needs, and so on. Based on that, we will be creating or defining what are the building blocks for a data space. And on top of that, of course, at the end of the project, we will be delivering a kind of a roadmap toward the implementation of the agricultural data space. So one of the key pieces of the project is basically about the consultation process. So we are involving many different stakeholders from many different actors in the agri-food chain to give us some feedback, recommendations, and overall to test, verify, and see all the findings that the project is going to be delivering. So basically, this is the engagement of the stakeholders. So you can see here, of course, some of the main actors in the agricultural chain, but basically these stakeholders will be engaged or are already being engaged in many of the stages on the activities of evaluation, validation, reach a consensus for how would be like the roadmap for the implementation of the data space. So in a summary, the project has 7 goals. Of course, I don't have to go into details in each of them, but basically it's about mapping the landscape, the current landscape, analyze and assess the governance models, analyze and assess the current business models, of course, exploring the existing legislative frameworks and how this affects to the data spaces, what is the impact in this in the data space definitions. We will start to design and provide some kind of reference architecture for a common agricultural data space with the stakeholders involved. And finally, we will develop the roadmap that I was telling you about. So as part of this initial set of activities, we started, of course, identifying the existing data sharing initiatives throughout the whole Europe. So we identify over 100 of these initiatives. I mean, basically, this is called for us an initiative, any kind of initiative that provides access to data that is based on some kind of restrictions or requirements, like maybe technical, maybe legislatively, financial, and so on. So any kind of those kind of initiatives are being mapped into the whole Europe. We have been talking with several of them, and they are, giving us their feedback, their requirements, their experiences. And based on that, we are, of course, delivering our first set of building blocks. So based on, of course, all of this analysis that we have started doing, this confirm, of course, what we call the current, what we can see in the current situation in terms of the data system available in agriculture. So what is happening is basically that you have at the current time, and in the typical ecosystem, a broad category of different systems working together. So you have, for example, data coming from operational machinery, but also data coming from the fields, sensors, and that kind of things. There are also a lot of systems about farm management administration. Of course, you need to connect to rural payment systems and grant systems. So there is many different data systems interacting in the agricultural ecosystem. But the situation is that it's highly fragmented, so there is little or no interoperability here, and that's one of the key challenges that we are trying to address. So if we go actually more in detail into this interoperability challenge, we see that based on the latest advances in technologies like IoT, artificial intelligence, big data, and many others, there is like an explosion of data available. The problem, of course, is that this data, as I was saying, is not interoperable in many cases. So that means that you have like silos of data that you cannot really use in an integrated way. And there are many reasons of that, of course, because data is available normally in different formats, represented according to different semantic models, so the semantic is completely different in many cases. And there are insufficient interoperability mechanisms that allow us to have like kind of this integrated view. So as part of the agri-data space, of course, these building blocks that have been started to be defined are addressing this kind of interoperability aspects. Of course, we see this in different levels, and this is aligned also with the IDSA reference architecture, as you see on the top. But basically, we go more in detail into kind of these interoperability blocks. Basically, we talk about basic interoperability, that means foundation interoperability, communication protocols, but then we have also interface interoperability, so to being able to use some kind of JSON, for example, for the exchange of the data, that we have shares metadata. We have then, of course, some syntactic interoperability aspects about how to exchange the data via some kind of a structured APIs, and then the full semantic interoperability that is based on how to really exchange data without losing the meaning or without having some conflict in the meaning of the data that we are exchanging. So basically here, we are focusing a little bit on this aspect of semantic interoperability because it has been identified as one of the most challenging aspects, and this is actually something that we have been working for several years especially in the agri-food sector. So basically, the semantic interoperability ensures that there is no kind of misinterpretation or incomprehension between the data that you are exchanging, right? So that means that everybody understands the meaning of the data. That's the main idea here. And of course, this allows us also to spot some kind of duplicates, for example, in the data. And in general, this will improve the quality of the data that we are having in the data space. So normally, this involves having in place some kind of common information models, and also, of course, having the interoperability mechanisms to produce and consume this kind of data in a standard form. There are many different existing vocabularies, ontologies, and semantic models that have been also specifically for the agri-food sector developed over several years. I mean, even if you go, for example, to AgroPortal, you can see there are over 150 of them registered. This is one of the most popular portals for semantic resources in agriculture. So there are many of them that they have been used in the past for many different purposes, like semantic enrichment of information retrieval and so on. But more and more, of course, these are the key building block for enabling this kind of semantic interoperability aspects. So instead of creating new models, the recent approaches, what we are trying to do is really to align what is already available. So we are not going to be producing yet another model. The idea is how to map and enable the kind of alignment mappings between what is already available, at least reusing or basing on the main standards and mostly used models. So that's why we created the agriculture information model. So AIM aims to establish this kind of the common language for the data space, so that enables this kind of interoperability between different systems. AIM itself is constructed in a modular way in different layers. So we have like a meta model layer, we have like a cross-domain layer, domain layer. We can also extend it to pilot specific applications. We have, of course, some transversal metadata layer. And, of course, the most important is about how it's being constructed by reusing, leveraging what is really available. So obviously the model itself is released as an ontology, but it has been also released with accompanied to many different semantic artifacts. That means JSON LD context. So that means that developers will be continue to transfer JSON. So the usage of this kind of model will be something that will not cost to the developers to introduce. But we also have this kind of shackle shapes that allows the validation of the data against the semantics, so that you will be able to make sure that whatever data that you are producing or consuming are actually aligned with the model. So the model itself, like I said, is reusing and making the alignments of these existing models. So AIM is actually now a candidate standard of the OGC. We started like a standard working group that has been already kicked off 2 weeks ago, actually. So we are really new on this, but it's already been approved by the technical committee, and we are going to be producing the specification in the coming months. So we have the model. Now, how we can produce this kind of data that is, in this kind of format that is compliant. So that's what we call the linked data pipelines. That is, we have several tools that implement these procedures to collect the data, transform the data, link the data, and publish the data in a way that is compliant with the model. And then on top of that, APIs. How we can, of course, expose the data also with some standard APIs. And here we are relying again on the OGC standard APIs. So finally, just to say some use cases about this that we have identified in AgriData space, we have, for example, digital twins, which is one of the key aspects that you have already also heard in other talks here, which is a digital representation of entities and processes, for example, like a digital twin of a field, right? So in here, as you can see, all of these systems feed from a wealth amounts of data from many different sources. So you see here all of this need about the integration of the data that needs to be done. And this is like supporting all of these requirements in terms of interoperability that I was just mentioning before. So with that, thank you very much, and happy to have some questions.
There will be questions answered at the end, and now we'll move to Maciej Zacharczuk from Wielkopolska Agriculture Advisory Center. Maciej leads their IT department, and he will present the idea of building data space in Poland and also the admin project. So Maciej, the floor is yours.
Thank you, Marcin. Yeah. Okay. My name is Maciej Zacharczuk. I'm working in Wielkopolska Advisory Center. It's a public organization, public advisory for farmers in Poland. We are a regional organization here in Wielkopolska region. So we are also working on digitalization of advisory and farming in Poland generally, in cooperation with many institutions. I think the main issue in Poland is data silos. So it's in Poland there are many organizations. It's a lack of coordination, of cooperation between them and between sharing the data. We have also problems with legal registration that don't allow the data sharing, even public data, and so on. We have also many institutions in agri-data sector in Poland, like government institutions, Minister of Agriculture, as well regional authorities and regional governments connected with agriculture, agencies, many research institutes, public advisory centers, 17 organizations, private organizations for advisory, and so on and so on. So we have lots of institutions and databases. They have their own databases, their own standards, dictionaries, and we need to, in our country, to aggregate the dictionary data. That's it's a beginning, and we need to centralize data sources. I mean, not to build one big data source, data center. We see that we can connect many silos that we have, to open them in the meaning of, for example, databases of plants, crop varieties, pest diseases, production products, meteorological data for agriculture, and spatial data, and so on. Current state that we have, now we change slowly, step by step. We start from, as I said, data silos owned by government agencies, institutes, and access to them is separated for farmers, for advisors. And the main problem now it's that the user must copy manually the data between the applications and systems. So we see that we working on centralized and open the data through the central access point for agriculture data in Poland, and common bus data system to give the access for farmers, for advisors, simply, and for enabling the reuse the data. So we worked on building the national advisory system in Poland. It is called Edwin. We have started from plant protection, for public e-services. The basic is the virtual farm is the service for farmers that includes the data, local data from farms, for application for farmers, and the next, tracing for origin of products, risk reporting and sharing the data. This risk reporting and sharing meteorological data, that's the way that we see that we can open the data in agriculture sector in Poland. So Edwin project was a national project, started in June 2019. Coordination by my organization, Wielkopolska Agriculture Advisory Server, in cooperation with Poznań Supercomputing and Networking Center and other regional advisory centers in Poland, and Institute of Plant Protection. We have finished this project. Official start of the platform Edwin was in June last year by Ministry of Agriculture. What is the architecture of this platform? It is built from microservice services, many users applications like web application, mobile applications, and we have many APIs, internal and external services to link the components and sharing data. We are using the open source components like OpenAPI, OpenID, Kafka distributor, and InfluxDB, and so on. So we are open to extend this platform to another functionalities, and extend with another project. So we are also trying to use and connect with agriculture information model, as Raul said, that we are working on Demeter project also to connect some technologies include in Edwin platform, and we are also extending this platform through Datamite project. Datamite project is a project about monetization, interoperability, trading, and exchange data. 26 organization. It's a project Horizon Europe funded, started this year, 3 years project led by ITI from Spain. We are also the partner of the project. Also the partner is Poznań Supercomputing and Working Center, so we are working on extending the Edwin platform through as one of the pilot. It's one of the pilot of Datamite project. So we plan to implement new mechanism to our platform, connected with data sharing, monetization, quality of the data, and so on. So we are planning to extend the Edwin platform with data marketplace, agriculture data marketplace, and to build a data space in agriculture in Poland. So we see that we can extend the functionalities for creation of value chains and green transitions, digitalization, data sources, and improve the qualities. And we are also trying to pilot the private-public partnerships in this project, not only sharing public data, but also implement mechanism to share the private data, for example, data of the private data of the farmers between different systems, different applications. We have also long-term plans to integrate many project results in one platform. For example, we have some results in Smart Agri Hubs project, like fertilization services, drone services. We are also working together with in the Demeter project. We are working on benchmarking and pollination services, like other projects like AgroBank, biodiversity, selection of seeds, disease recognition, AI for EOS projects, Scalagi data project, machinery communication, ICOs, and implementation of other mechanism, as I said, AIM, for example, standard, and of course, as I said, Datamite. It's component for data marketplace here. Some example existing already. Tracing the origin of agriculture products. It's a simple API to check for consumers the origin of the product and their production. And sharing the data service, also API public for access to risk of pests, meteorological data, data from national network of agrometeorological data. So that's the current situation. Thank you.
We now move to Łukasz Łowiński, that is representing the Poznań Institute of Technology, Łukasiewicz Center, and he will say a few words about Agri-Food TEF initiative.
Thank you, Marcin, for introduction. I will a little bit wait for my presentation, but I say a few words already. I will prepare for you an information about the new initiatives in Europe. It's called TEF, Testing Experimental Facilities. It's based as a co-funding procedure from the EU and the member states which are involved in the project. Also, I hope you will see that soon. I'm a representative of one of the leader of the Polish satellites, which are combining the partners from the Wielkopolska Advisory Centers and also the Poland Supercomputing and Working Center. Okay. And if you don't know what the TEF is, this is the environment and possibility or space where the you look at it because it's something. What happened? This is the space and the environment where the companies, also SMEs, also large companies, also startups could provide testing and experimental actions dealing with the development of their products, working mostly on from the TRL 6 or above, to provide their systems, to provide their algorithms, to provide their hardware and software to market readiness, and could be provided due to the testing in the real environments on the large scale. Due to the whole of the Europe, could provide effects and see what the impact on the users and on the ecosystem of work their products could have. I'm representing the Agri-Food TEF project, which was one of the winning through the several of testing and experimental facilities under the European Digital Europe program, which was also choose from the European Commission in the agri-food sector, in the health sector, in the manufacturing sector, and smart cities sectors. This projects are started through this year, through the beginning of this year, but on this moment we are dealing with some of the co-financing issues in the member states, so we are still in the, let's say, preparatory actions, and I suppose soon all of the actions through all of the TEFs, not only our own, will be started, and the companies could be benefit dealing with the services which will be provided. Of course, we are working in the wider context. We are also dealing with the maybe not overpopulating, but emerging of the growing population. We are dealing also with some of the aspects of changing of the environment, dealing with the drought, dealing with some of the external weather conditions. We are also dealing with the more and more expensive and dealing to the sustainability production, and working with the more and more efficient production of crops. So this is why our mostly project objectives, mostly defined project objectives, that we are dealing with the quite huge project, 60 million euro funding, which will be splitted due to the EU funding and also from the member states, which are very much involved in the also in the preparation and in the evaluation of the aspects of preparation of the services which will be developed and also provided due to all of the Europe countries. We are very strict oriented in the validate of the AI systems, AI and robotic solutions in the agri-food production. This is why we are only dealing with these aspects of sectoral and also technological aspects. The project is 5-year. So this is something what we know, but on the end of the project we are very clear defined goal to be sustainable and to provide the services after the project. So we are very much business oriented, and the services which will be provided for the companies which will be providing the effect for them as strict business-oriented solutions. We are only working as a service provider, so the business case for us is to provide the services for free for the companies, but it will be stated, or it will be focused on the advanced and scale up the solutions from the tier 6 till tier 8 or 9 to be market ready. About main features of our project, we are dealing with the solutions which will be providing the effect and information for the primary production for the livestock farming. It will be focused on the using the technology, but not only AI is the core of the project, but not only one. We are also dealing with the robotics. We are also dealing with the digitalization. We are dealing with the data management, connectivity issues, big scale data usage. So this is the main aspects of, but not only dealing with the project. We are also the combination and cooperation of the several nodes and satellites, which all of them are focusing on some of the aspects what is developing our main focus on their aspects of solution, what will be solution of services which will be provided. As you may see, we are a combination of institutions which have quite huge history and knowledge and also skills through the dealing with the digital projects in not only in agro sector but technological and agro oriented sectors. We are mostly combined through the nodes as FBK, which are the leader of the projects, DFK from Germany and Elini from France as a node, and we are also satellite leaders. All of these nodes and leaders dealing and providing services. Some of them are very specialized for their top of production, but not only, and we are working as a consortium, so some of the services will be provided through the several countries at once. So this is something what I may show off for you. If anyone want to check their solution through, I don't know, 1,000 farms, this is something what through this project will be available. Our services are combined from the several of the aspects which are dealing with. This is the physical testing of the solutions on the real demo farms, on the real environments. We are also dealing with the digital testing, so digital twins. This is the set of services which will be as synthetic environments for testing the algorithms. We are also dealing with the legislation and providing the sandboxes for the checking of the new aspect of creating the law on the regional level and also from the European level. We are providing the services due to the certification aspects, also in the AI, and we are also common with the AI law, which is still in the development. We are also dealing with the ELSA, environmental, legal, societal aspects, and also LCA for the preparations. As a Polish node, we have also infrastructure located in Poznań, so this is where we are here. Through our project partners, advisory center from Poland and also PCNC, also located in Poznań. Through our infrastructure, which is available in the project, we have AMC chambers, we have test sites from the autonomous vehicles and robots. We have quite huge digital infrastructure open for providing the services. We have also field test sites in Silinko near Poznań and also Kolkołowo near Poznań, and have access to more than 100 real demo farms. In our catalog now we have almost more than 60 services related to the testing and experimentation. As in the data spaces, we are providing and preparing the lots of data streams. We are collecting the data from the fields due to our services, due to our actions on the fields. We are providing the training and comparison data sets. We are providing real and raw data, and also providing the synthetic data or hybrid if it will be needed in our services. We also still need the data in our ecosystem because we are dealing through the projects in the several, as it was mentioned, in the several of data streams. And for us, it's very important to also provide some comparison between the data which is available or could be provided during the project. As I also mentioned, it was mentioned before that we need to expose and share the data in the form of the data space. For us, it's other projects which is developing the data spaces is very important for this aspect. And also we will be dealing with the solution standards which will be developed through the other projects as AgriData Space, recommendations, MI, IDS connector, or Eclipse connector. So for me, the important is that the information about these projects go through the internet, through our networks, and we will be the place where the companies, where the SMEs may look up their support for their scale up their solutions and looking for the place where their solutions could be tested. Thank you.
So thank you very much, Łukasz. So okay, now we move to next presentation. Okay, so this presentation will be given by me. I'm Marcin Płóciennik from Poznań Supercomputing Networking Center. And, okay, it's still, okay. So I will focus on two use cases, AI-based use cases in two projects, so namely ICOS and AI4EOS projects. So in those projects, we also collaborate with our colleagues with Wielkopolska Agricultural Advisory Center and with the Poznań Institute of Technology Łukasiewicz Center. So first I will say a few words about the AI4EOS project. So basically this is one of the projects in the EOSC 0104 from 04 call. So the project itself is focusing on advanced features for distributed federated composite learning, on metadata provenance, for the and then on event-driven data processing, also in general on provision of AI machine learning, deep learning services in EOSC. The goal of the project is to deliver an AI exchange in the context of the EOSC, and enhancing, increasing the application of what is currently available. Also, we deliver different methods to compose AI tools, and we enhance existing the cloud services to support AI on distributed data sets by the federated learning. So the project evolved from the previous initiative that is called Deep Hybrid Data Cloud. The exploitation of this platform is being done also in Imagine project. So if we look like, if we have a look on how does it look like, so we have AI for the architecture dashboard, we have AI as a service, we have Exchange API and Training API for training AI. That underlying we have the federated learning framework, and on then we have on the lower layer the PaaS provision orchestration. We have in the project 3 use cases, where one of those is related with integrated plant protection, and the other is agrometeorology and automated thermography. I will just focus very shortly on this one, that is for the integration of Edwin that was mentioned just before, with the AI platform. And basically, currently in Edwin, we have several mathematical prediction models for integrated plant protection, and we would like to enhance that with the AI-based models. And so we identify that the initial focus will be on wheat and the sugar beets, and the fungal diseases that we identify as the largest assets that, I mean, that are the most important plants in our region. So we have the 3 scenarios. So there is one with mobile app to collect, to identify given diseases, by usage of satellite data and drone-based data to recognize the diseases on early stages. And also, also the usage of phenological stations that we built next to the experimental fields where we have a lot of the plants available. So collected data from those experiments will also contribute to the agriculture data space that was also mentioned in context data mine that we will build in Poland. So another project I want to mention is something around cloud continuum operating systems, so from edge to cloud, and the project ICOS that is coordinated by the Atos, and this is the project with several companies that you might know, like Red Hat, and basically there are 4 validation use cases in this project, and basically where one of them is related with agriculture operation robotic platform. So in the project itself, we are saying about integrating from really extreme edge, far edge, to the cloud, and to create a meta operating system that will span over all these different categories and would create whole continuum and will allow to orchestrate. So there are several challenges that are around this continuum, and basically we are now at the design phase for this meta operating system, and well, there are really several challenges related with trust, security, privacy, with networking. And so we have this kind of initial architecture with the distributed meta-kernel layer, with the runtime manager, continuum manager. Then we have the whole security layer where we, first of all, focus on the anomaly detection, also on the trust. And one of the most important addition is whole intelligence layer to coordinate the continuum. And what is the added value is also the a kind of AI analytics that could be used also by the application that you're using will be using this meta operation system. And there will be also available AI model marketplace. So, so as an access, there are several kinds of possibilities. So there is like command line. There are also like ICOS shell, where you would be able to start the infrastructure, get the topology, start up the agents, and run the whole continuum. So the proposed technologies in this ecosystem are related with, for the data management is Data Clay and Zenoh, and for the management of this continuum is Nubla, and underlying we use Kubernetes, Grafana, and few other technologies. So our use case there is that what you could see, this is the robot that can be used for different kind of operations and different kind of plant treatment. You have there installed a lot of the cameras and sensors, and there are a number of the modules like precision sewing, precision care, and there is maintenance data. There's also a platform that transforms it to the fields, and we will use this as an also a node, edge node, but also as kind of networking node that could connect with the farm or with the internet, because not always the robot will be a good connection in the field. So then this whole system integrates with irrigation system, weather systems, and also decision support system, and in the end the client will have kind of the app in the form of the dashboard. So there are a few scenarios there, like the predictive maintenance of this machinery, because as you can imagine, this is quite an expensive machinery, and there might be many robots going through the fields. So we estimate more or less 100 gigabytes per day of the data that are coming from the sensors to be partially this will be processed on edge. Some of this has to be stored for improving the models. Basically, there is a use case related with crop management analytics using AI, so creating weed map and improving this whole algorithm, but also for validation and improvements of models for operations and steering. And that was my last slide, so thank you very much. So we'll move now to the last presentation done by Tomasz from Poznań University of Life Sciences. So Tomek, the floor is yours.
Okay, good afternoon. My name is Tomasz Wojciechowski, Poznań University of Life Science, Department of Agriculture Engineering. I'm representing here my university and the company which we cooperate with this project, Set Software. Some words about the university, Poznań University of Life Science. stated here in Poznań. We are, I think, one of the 2 leading agriculture universities in Poland. And I think we are one of the 4 universities which are mainly focused on precision agriculture and digital agriculture. And SET software is a developer of software for farm producers, the biggest one, the smallest one, as you see from portfolio, from all 20 years of experience in delivering this software for the companies, ERP, farm management information systems. And in that project, we cooperate with to produce a platform which will be focused on yield prediction. We are focused on 3 crops, potato, blueberry, and apples. What is on mainly the customers of software. So this was the willing to deliver the products. So I will say something about the data space and this AI services because as a consumer of this data space and how we use it. So of course at the end we will have a platform which will have some modules, meaning the knowledge, meaning the data which we collect. Then all data which will be used should be somehow filtered with some fraud detection. Then some yield prediction models, cost prediction models, and of course the user interface with visualization. From my perspective, the main point is the data which we use for learning the models and transferring to the user. Also, so typically, it's a challenge when you wanted to produce, to provide this kind of product as a yield prediction model, for example, because at the beginning you need some data from real farms. And the farms do not collect all of data which, as a researcher, which we wanted to have. So we have to focus on some. These are which we're focusing. So meteorological data, agrotechnical, then some soil data, satellite data. Some of them are on public data, some private, some are open, some not. Some are so different kind. And if we think about meteorological data, which we used, it was typical weather station which was placed on farms. Well, it's not what is the conclusion after the project that not every farm has that kind. Well, we think that meteorological data was easy to get, but we need data from real farm. But in Poland, the situation is that nowadays farmers buying those meteorological data, but still we don't have real good data which can use it. So some farms which we cooperate have it, but some data we had to get from some public data spaces. Well, the challenge was with agrotechnical data because it is only can be taken from the farms. So one conclusion is that it doesn't matter if the big companies or the small companies. Every company in Poland have problem with collecting and recording the data from the past. Some data are analog on the paper, some data on digital. So still doesn't matter if the well, in some cases, the smallest one has better valued data from the point of view of the models than the biggest one. So the challenge for the developers was to standardize the data, aggregate, etc. Because those data were taken for different part of Poland. Of course, some challenge was the economical part. Well, because main data which we wanted to get is yield from small part of the field. And another part of data which we used was satellite data, so Earth observation data. I heard plenty presentation today about Earth observation data, so of course we used that was the first one, which you see is on public as a open data from the Copernicus system, and we wanted to use medium high resolution data. And one conclusion using that, for example, when we think about the medium image observation data, which are ready for the agriculture market. So yes, there are some good business plans which you can, or business models, which are ready for developers, like, for example, here the planet. But when we think about the high resolution, which I think now will be on the which are interesting for the agriculture purposes, we are still don't have good quality data when we think about the past data, and when we think about the business models which we can use it. So if we think about the medium, we are ready, we can use it. Every developer, doesn't matter if it is public or private, but still some things to do. And we use some type of data which connected with soil. One was typical, one was from some proximal soil sensors, like here. Typically in agriculture, we use those data for management zones preparing. It's for in the production cycle, we use those data as a management zones, but in that we use these maps as for producing some indexes of variability of the field, which can be used in yield prediction. One of data which we wanted to use was the information from the imaging cameras placed on the field. We want to use some commercial product which are already on the market, but during the project we found that the product is not ready for the market a little, because we wanted to take some information about the yield, for example, flowers, etc. In kind of apples, it will be fruits, but there are still some technical problems and software problems with these products. So what we found that we only use it for as information what phenological stage, but the observation is only manual, so not automatic. Of course, the project have some milestones. We are focusing on prediction models in crops, in these 3 crops. So in the first level, we wanted to produce the models which will predict yield on the species level. So, and then in this next level, we produce models on some varieties. So not only potato, but special varieties for chips or for other purposes. So as you see, because these numbers of errors of map show us, because everything which is below 10, we recognize the agriculture is workable, is working. So I think we, for now, have good results. And we was thinking about, because sometimes, as we recognize, the farmers don't have all of data. So we try to find, is it possible to get some information to have good quality prediction models, taking account only the meteorological data, so the ground level data, then the only satellite data, and mix it, so hybrids. And we do it for example, for potato. So as you see, fusion of those data do not get we didn't get any better results, so still about 10. But in some crops like blueberry, this connecting those data to types give us better results. So from 40 to 11. And at the end, of course, it should be some platform. So it will be visualize the meteorological data, the farm data, and some crop data, of course, from satellite. And what is interesting here, we produce, so the developers produce some service which will, what you see on the right down the corner, real-life visualization of the crop which is on the field. And that point, and what I said before, that we recognize that we as a university recognize that we need some new product for imaging phonology, digital imaging phonology. The same conclusion comes from company. So at the end we found as a university, as a research community, we submit a proposal for call from our future project, our initiative, and now we are ongoing co-development with the software, with EDGI, platform for phonological imaging, when we can, because these phonological networks are on the market, or we can use it like a phenocams, but they don't have the AI services which we can use it. So our goal is to put it on the EOS market. I think it will be on the late autumn this year, and it will be open. So if there will be some information needed about some project, about this initiative AI for Pheno, please contact with me. I'm on the event application. So thank you for your attention.
So I would like to thank you to all the speakers, and now if there are any questions from the room to any of the speaker. Okay, so if there are no questions, so I think we ran exactly what we had to run, like 1 hour, but we were late because previous session was late. So I'd like to thank everybody for attending this session. We are here around. If you have any questions, we can discuss. And if you look for any kind of use case in any kind of food production, you can contact any of us. As Maciej said, they have like 100 network of 100 demonstration farms, where and also we all are collaborating, so we can easily come out with some use cases. So thank you again very much, and yeah, have a nice rest of the day.
the afternoon sessions. I understood that there are 6 parallel sessions, and one of those is the green computing session. Thank you very much for your participation and attendance. I'm Cătălin Condurache from EGI Foundation, and within EGI ACE, I coordinated the task 7.2, which was about the service planning in EGI ACE and also green computing in EGI ACE. And during the activities, we started with members of the task, like a trigger point, and then we evolved and we created a task force, and within that task force we tried to assess the status of green within EGI, EGI Federation, and maybe beyond. So we had a session last year in Prague, and EGI ACE is terminating this month, so we consider it will be appropriate to give another presentation, a farewell presentation on green computing with the participation of task members, but also task force members, so which were not directly involved in the task, but from other work packages. So a good mixture, I would say. So we'll start with the first one is from Paul Stokes from JISC. He is a project manager in digital preservation, involved in many activities, many projects, and he will give the status of green computing progress and improvement in EGI ACE, like a complement to the poster we have outside, which will encourage every one of you to vote for the poster. I give the microphone to Paul. Thank you.
Thank you. Now I've got to log in there because my computer logged me out automatically. I need my notes here.
Just one thing. Questions after each talk. Let's not wait at the end for questions. If you have questions, please interrupt. Yes.
Questions? No, no questions. We're not going to have questions. Okay. As was said just now, I'm Paul Stokes. I'm from JISC. I have many bees in my bonnet, one of which is about green, and this is a very rapid romp through what we did in Task Force 7.2 and the publication we produced, and of course the poster, vote for the poster, it's out there at the back, number 12. This might be slightly incoherent, but never mind, do ask questions as we go along. So, a little bit of background. As you all know, 30-month project, January to June, so we're nearly at the end, HTC, HPC is the themes. The potential is there for all of these services to reduce their carbon impact if they thought about it a bit. And our remit, well, basically our remit was this, to make EGI greener than it currently is. So, how could we make EGI greener? Well, we had a bit of a think, and we thought that we should talk about and think about good practice, have an approach based on finding out who is already green, and then sharing that information, the knowledge dissemination, and measuring, of course, seeing if we've made any sort of impact as we went along. So, expanding those one bit, the good practice, we were going to be seeking out good practice, finding, categorizing good practice, both among partners and possibly beyond. On the knowledge dissemination side of things, awareness raising, both amongst the project partners and beyond, and sharing good practice, again, project partners and beyond. And other metrics, baselining, finding out what people, or where people are at when we started, and then measuring progress against that baseline over the lifetime of the project. So these are the things we set out to do. I'd mentioned baselining, a bit more of that in a bit. Awareness raising. You may notice us banging on about green quite a lot at this and other events. And we're all about making sure that everyone at least notices the fact that green is an important issue. Green means different things to different people. So one of the things we wanted to do is make sure that we were banging on about green in the context of EGI. So we were seeking out good practice amongst some members, finding out who is already aware, finding out who's already aware and doing something, even more important, and also finding out who's aware, who's doing something, and who's willing to share what they're doing. And measuring progress, well, we're optimists, so we thought we would definitely have some progress. So, baselining. This was basically to find out a few things. First of all, how many partners are undertaking green activities and processes already? Not as many as we would like. What those processes and activities were, and could they be shared? But the most important thing of all is having a point at which to measure, has progress being made? It's important to know where we're coming from, to know if we've got to where we want to be. So the key deliverables we identified at the beginning of our task, an EGI ACE task force, green task force has already been mentioned, some signposting resources and other shared resources. And we ordered these available for EGI partners and others, so these things need to be on a public platform of some sort. And impact, we needed to understand, have we made a difference? And so these were the measures we chose to indicate if we had made any sort of a difference at all. So increasing the greening, I hope that's the right word, I'm not sure if it's a real word, but never mind, the greening of EGI, an increased awareness within EGI, and an increase in the activities. And so how we were going to do all this awareness raising and finding out information and stuff, well, we had some basic methodology which we were following. Interviews, we had one-on-one interviews, particularly with platform providers from Work Package 4. We asked them about energy-based brokering strategies. We came across a few interesting concepts, but one of the problems that was immediately apparent when we talked about energy-based brokering strategies was it favors the wealthier and the more mature centres who can afford to be green. We did some desk-based research, investigations into greenification, another word I've totally made up, greenification strategies of similar institutions, etc., and also around the information provided in the EGIA's VA sheets. My colleagues know more about that than me. And the survey, well, a bit more about the survey shortly, and a task force, we mentioned that already, and a bit more about that shortly, and many awareness-raising activities, including webinars, conferences, and other things. So, signposting. We put the stuff on the EGI website. The URL's there. I hope you can read that. If not, see me after school. It's a work in progress. We're putting resources there, links to resources. So if you have anything you think should be there, please do let me know, and we'll add it. And the task force, established in 2021, that sounds so good, doesn't it? Established in 2021, about 20 members, give or take, from all across the project. There's an open invitation to join the task force, by the way, so if anyone here is interested in green strategies, policies, etc., do come and see us after school. And the task force was the driving force behind many of the awareness-raising activities we actually undertook. What the task force was intended to do was, well, map the landscape of green computing activities within the EGI Federation, with a specific focus on participants in the EOSC compute platform, because they're the ones who use all that power and energy and are very not green. Identify best practice amongst partners, including measures for reducing energy consumption, as well as achieving optimal metrics. Create a knowledge catalogue, that's a fancy way of saying a signposting site, including best practices and training materials oriented to serve as basic guidelines to improve energy usage and efficiency of data centers. And to measure the progress, as I said before, we need to know we're actually having an impact. Measure progress towards key goals, making EGI ACE greener, and goals including improvements achieved by EGI ACE partners in pursuit of that goal. And finally, to liaise between complementary green computing activities in other projects. So, one of the key tools we had in order to achieve all this were a number of surveys. And so some basic stats about the surveys. There were 3 surveys. They covered green computing practice, There were 2 surveys there. One was an initial baselining survey, a second one to see if we made any progress, about 40 questions. And there was a third survey about software efficiency, again, about 30 questions there. 21 different institutions responded, yay, all down to Catalan. 9 institutions responded to both, which enabled us to have a meaningful indication of progress and improvement. And it was across about 15 countries. So, some green computing survey highlights. One of our members started to track green computing metrics as a result of all the information and awareness raising we've been doing. Green computing roles have been created in 2 partners. Green computing policies have been defined at 3 places, and 2 of those are available to share. 3 institutions were planning to introduce green computing-related awareness activities or training programs, particularly if they were provided to them. Hot off the press, not quite sure if they've done that yet. 1 is planning work systems to optimize progress so that green computing initiatives have a minimal impact on their throughput. Sorry, processes, not progress. 1 has started to use a green energy supplier. That's a supplier that issues certificates detailing how and where their energy comes from and how it's green. 1 has started to use green power initiatives, in this case, leasing a windmill, which I thought was quite innovative. 1 has started to proactively try and source green-labeled hardware, and green-labeled in terms of the certifications and advertised efficiencies. 2 have started to use green decommissioning services, or all about not just the green in the power, but also the lifetime carbon impact. 1 has started to include green clauses in their standard contracts and procurement processes, and some of those, I believe, are shareable. And 1 has begun to make purchasing decisions based on lifetime power and carbon costs of equipment, and they're prepared to share those and the typical procurement requirement clauses. So, progress. We have had an impact. Yay. So, the software efficiency highlights, I would hesitate to say this has been quite so successful. It appears that there is little consideration given to the programming language's energy efficiency when procuring a programming language. C, C++, Python are chosen as the main programming languages, mainly because they are fast and they're available. In most cases, no energy efficiency criteria was considered. However, software that uses the EAR, Energy Management Framework, is being considered by some, and the way software interacts with the systems is measured to identify the most cost-efficient use, and so on. Energy efficiency is not considered as a criterion when procuring software. On the GPU framework side of things, again, performance is everything. Energy efficiency is hardly considered at all. And on the energy consumed by the clusters, in some cases, energy measurements is taking place, but mainly for cost management purposes as opposed to carbon management purposes. So if that could be tweaked slightly into be a carbon calculation, that would be good. So, our main conclusions. There's relatively low engagement in EGI about green and green issues, which is not good. However, some people are engaged and some people are aware. Unfortunately, they are not necessarily the decision makers, the ones who can actually decide on the purchasing decisions and the energy consumption decisions. So we need to attract or attack those people. There are pockets of excellence, which is good, and change is happening. Our survey proved it, but it's happening slowly. So things we need to do in the short to medium term. We need to build upon the current knowledge and knowledge-sharing activities. We need to facilitate the adoption of green initiatives and practices. We need to incentivize the adoption of green initiatives and practices. And possibly more to the point, we need to de-incentivize non-green practices. And the other side of things, short to medium term, things we can do, more awareness and training, If we can have some training courses specifically relating to green that can be distributed amongst the entire project, that would be good. We need an EGI green officer. Now, this one is particularly important, I think, because in my experience, if you want to create a strategy, if you want to progress something, if you want a policy, unless there's someone who is overall in charge or responsible for making it happen, it's not going to happen. So, and I mentioned there, strategy and policy. We need an overall EGI green policy strategy and certification across the entire set of projects. Green energy procurement, we need to make that easier. We need to make it easier for people to buy green energy. We also need to make sure that there are green energy sources they can buy. Green procurement, I mentioned before, the total lifetime carbon costs. We need to make sure that there are green procurement methodologies in place, and people are encouraged to do that. And related to that, green standards, things that are not only understandable, but they are, how can I put this, that they're accepted by everyone as actually being green rather than greenwashed. One of the things that was also suggested was an automated computer brokerage, whereby jobs are sent to the greenest places. But as I mentioned before, that unjustifiably perhaps, or unfortunately, favors those who can afford to be green, which is not necessarily a good idea. So we need to think about that a bit more. So, longer term, and this is hot off the press, it wasn't in our survey or our report, it is a result of conversations here at this conference. One thing we might be able to do to cope with that immature green side of things is to top slice funding, whereby those who get the jobs, a part of the funding goes towards those who can't afford to be green. It's a vague idea, there's only sort of just coming to fruition, but we'd also like to hear from you here in the audience what your ideas are. What would you like to see done to make EGI greener? How can we facilitate that, and how can we do it quicker than is actually happening at the moment? So that was me, and Catalin and Sean also helped with all this stuff as well, so their names are up there as well. If you want to contact me, my contact details are there, and I believe we're on to the next slide deck now, which is Jerome.
I have comments about your...
Oh, do please.
What about using the FITSM training certification to promote green computing?
That would be excellent.
Huh?
If you know of some certified courses,
because
we'll put them on the resources.
Many people from FITSM certification training currently. Maybe we can have a quick chat with them.
Good. So, one result immediately. Any more? Sean. Awkward questions, yes.
So, not so much a question as a comment, because I don't think I really addressed this in my slides. One thing that certainly EGI could do is monitor CO2 emission and ask for sites to report not necessarily on how much their CO2 is, but have some ranking on the level of improvement.
Mm-hmm.
So if you have a ranking based on level of improvement, it will clearly favor the non-Northern European nations, the one who primarily rely on sort of carbon-rich fuels still.
Mm-hmm.
So having a ranking based on improvement might be better than just saying we go to the greenest place, we go to the most that's improved most.
Yeah, but
you need the baseline first.
That
You
does
need the
assume that those who have the more improvement to do can afford to do that.
That is true.
Which isn't necessarily the case, hence the top slicing concept. Any more questions? Thoughts? I mean, if you have something you think about afterwards, then please do email me, Catalan, Sean, any one of us. We're happy to hear. I believe that's Jerome's turn.
Thank you very much. So next is Jérôme Pansanel. Paul was a member of the task 7.2, Jérôme the same. And yeah, Jérôme is from a Signe facility at Hubert Courien Pluridisciplinary Institute in France, in Strasbourg, head of that cluster. You may say a few words more about you, and he will describe probably the heavy work done at your data centers to make it more greener or something like that. Yeah? Thank you.
So, thank you, Katalin, for the introduction. I already presented a lot of what we did on our data center during the last EGI conference. My plan was, or more is, to present what we can achieve to compensate the environmental impact on data from a data center. As you may know, green computing does not exist. That's clearly something that cannot be achieved because building computers, servers needs a lot of stuff, hardware, metal, energy, water, and so on, and it will be never green. But we can do it greener. That's as before. That was the command before. We have to look at the progress on such very good metrics. We have lots of metrics that can be used to achieve this. In particular, oh wait, is there a way to open the screen here or not? Because I no. Wait, yeah. Okay.
Do you not access to the slides?
No, I could not. There is no signal. Oh. Okay. I have to change my glasses or my eyes. It will be much easier. Okay. Oh. Okay. Ooh. Thanks very much. Okay, perfect. So, as I told you before, many elements are coming from mining, chemistry, logistics, use of many of large amount of pure water, for example, for providing this silicium wafer, and therefore that's a very, very polluting industry. And I haven't mentioned recycling, as recycling is for us a real shame because there is only a small amount of IT that is recycled. And so we have to work on a lot of each part of the IT life cycle. We as IT specialists, as a software engineer, IT architect, and so on, we cannot solve all the problem, but we can try to contribute to make to reduce our environmental footprint. In my talk during the GI conference in Prague last year, I presented the different kind of action we can do in each part of the life cycle, either during the purchase process, because when we are purchasing hardware, we can act on the quality of the hardware we are purchasing on the label we have on the hardware, as well as recycling, because you can choose for label partners that will recycle correctly the hardware. Of course, where we will have the most impact is during the use phase, either because we are providing a data center environment, purchasing the hardware, installing it, or because we are providing all the software stuff for doing either storage or computing, and we can have a big impact by working on these items. As Paul told us before, it is very important to measure because before to start any kind of improvement, because you have to know your baseline and you have to select the parameters you will take into account to assess your progress. It can be, of course, the overall power usage of your data center. It can be the efficiency of your software. It can be for some kind of data center water consumption, for the cooling, the waste quantity, what you have, for example, when you are commissioning your servers, workload efficiency, and so on. So there is a lot of metrics. You have to select the parameters and try to then to have made progress on the on all the parameters, ideally. But you are not alone, because it can take a lot of time. You can ask, there's some companies that are specific on this and can help you to make environmental audit. So do not hesitate to ask for them for help. And the second step, once you have all the metrics before to try to compensate, for example, your carbon emission, is to, of course, reduce it. There is a lot of good practice to use. On one of them, many of them are already described in the European Code of Conduct handbook that you will find through this URL. There is a lot of very nice rates and ideas inside the document. Use it, that's very important. You can, of course, increase your cooling temperature, reuse heat for heating the building, or making hot water for the people. You can separate as much as possible the airflow, so cold and hot airflow in your data center room. Use, when it's possible, free cooling. Raise user awareness about environmental cost of IT. For example, each year when you are telling the user how many CPU hours they are using, you can also send them how many carbon kilograms they have produced. If it's possible, you can try to use renewable energy. That's when if you can select the energy providers, this may be possible, but that's not always the case. So there is many options to studies to try to reduce all the parameters. So, once it is done or in progress, then you can look at how to compensate your environmental footprint. So before to compensate, you have to compute your carbon footprint. This is not very complicated, and we have all the compute elements that can perform a simple multiplication. So it will be quite easy to do. I will speak mostly about carbon footprint because that's the most simple item to compensate. And one way to do this is to be involved in the development of a carbon sink, and there is several ways to be involved in such development. So first, compute your carbon footprint. This multiplication between the global energy consumption of your data center with the CO2, so the carbon equivalent per kilowatt of your energy providers. This can be given either by your energy provider or by your energy agency at the national level. And I give you the link, for example, the second link at the bottom of the slide give you the table to many value of carbon equivalent per kilowatt in Europe. And I have used this value to give the value of France in 2021. So the same platform is using around 640,000 kilowatt per year, and we are producing for the production of 1 kilowatt in France. We have an emission of 58 gram of CO2. So this means that we are producing for the usage of our data center around 40 tons per year. But it's not to take it into account all what we are purchasing. For example, if we purchase 10 servers, it will be additional 10 tons of CO2. Once you have compute your carbon footprint, you can then look for partners that will help you to compensate your carbon emission. The biggest players like Google are directly connected to carbon markets, and they can buy or sell carbon credits using these markets. For smaller data center, in particular edge data center, it may not be adapted because we have smaller amount of CO2. But there is also a way to mitigate our emission. And one of them is to directly finance projects that are involved in the sequestration of carbon. For example, it can be forestry or blue carbon. Blue carbon is all kind of carbon sequestration that is in link with water. It can be seagrass, meadow, the development of bog or sweetland. You can also have projects that increase the amount of renewable energy in your country, or increase energy efficiency, or increase the waste disposal or the method the waste are treated after being retired. So lots of possibility, and this is very depending of your country. Normally, for each country, you have a link to this project. If you look to the cost, you have to. It takes between 10 to 40 euros per ton per year. So one of the less expensive is the agroforestry, because that's very simple to do. If you want to develop seagrass meadow, it's a bit more expensive, but it can be easily done. It represents normally around 1% of your cost per year to compensate your carbon. What's very important to note is that there is two labels that are available for compensation: the voluntary gold standards and the verified carbon standards. You can choose one or the other. And if you are going to the web page, you can find a project that can help you to compensate your carbon. All projects are not listed on these pages, but you can find, for example, locally a project that has this label. So that's much more easier for you if you want to look for a local project. And for finishing the talk, there is also the recycling, where you can act to try to improve your footprint and to have a better compensation. That's lots of links. There is many initiatives all around Europa to be able to compensate your waste. for example, not directly to go to the trash, but maybe be reused by an association. There is many directives, and most countries have applied the directives from Europa. So I give, for example, the example of Poland. So of Poland, that's the first one because we have been invited here in Poznan. But it's also the case in UK, in Turkey, or in France, and so on. So there's many initiatives all over Europe where we can have a solution to recycle correctly all the e-waste. So that's all. Just to summarize, the process is measurement, reduce, and then compensate your footprint. Okay, that's all. Thank you very much for your attention. If you have any question.
So thanks, Jerome. So one of the things that I don't think any of us have covered in this talk, but you brought up, you didn't really go into it in a lot of detail, is things like the water, how you deal with water pollution through IT, either IT production or through using cooling water in HPC systems. How much of that represents effectively a carbon source or a pollution source? And the other thing that I'm going to bring up, and again, I don't think I've mentioned this, I mentioned it when we did this first time, is the ethics around IT. So a lot of the rare earths that go into it are considered, what's the word I'm looking for? Conflict zones. They come from conflict zones, so they're conflict minerals. How can we get away from having to rely on places like, actually I won't name places because that would be unfair, but from conflict areas?
I will start with water. Water is normally when we are using water for water cooling directly on the CPU, that's the water is going in a closed circuit. So normally there is no pollution because if you want to remove them, you put this in a can, or it will be then recycled. So there is more, but you are more using water for the cooling part. There is not directly a link with carbon footprint when you are using such water, but it's more about the pollution or the withdrawal of usable or clean water from the population. That's the issue maybe here. One possibility is, as mentioned here, in the projects that are listed, there are some projects that are involved in developing the access to water to some kind of population, and then you can try to assess the amount of water you are using each year for your data center, and then to compensate by telling, okay, I will try to support such project to give access to clean water for more population.
You just made me think there was an interesting story in the UK maybe about 2 months ago. So somebody has put a small data center, like 2 or 3 GPUs, at the bottom of a swimming pool, a public swimming pool, and they just use the water to heat the swimming pool. So the swimming pool charges a rent to the provider of the GPU. They pay for all the power. The swimming pool gets heating for free. Some initiatives like that would actually be quite nice.
That brings me to my question. Do we have a collection of those use cases? Right? I'm thinking more about dual use of the heat that is produced, or dual use maybe if we retire hardware. I mean, there are many projects that do recycle the heat, right? They put it in a, how's it called, in a district heating system, or they heat a nearby house. There are very interesting cases how you can actually recycle hardware, right? And do we have, or do you know about any website which are collecting those use cases? Right? Because I think just distributing these ideas might be spin up new ideas or might motivate people to actually do the same in their compute center or in their region. And I think just collecting them would be already a nice idea.
It's a nice idea, actually, and that's something that EGI could do, is gather use cases like that, not only from the EGI data centers, but also from outside, just news articles that you find in different countries, and putting those together as possible ideas for the future. So I'll give you an action, Catalin.
I think that the website on the code of conduct has a link to such initiative, but it's not. It will not cover all the case, but many people that have data centers that are very engaged in grid computing are members of the data center code of conduct project and are sharing their experience. But we have to check if all the information are publicly available first, and if it's the case, maybe to know how to share it.
And about the conflict zones, maybe on another time. Okay.
That was a very fair question.
Thank you very much. So, Hakan. Yes. So next is Hakan Bayindir from TÜBİTAK Kulakbim in Ankara. He's a senior researcher dealing with several clusters there. Cloud, and I believe something else in general.
Yeah, clusters, HPC systems, and hardware management, and etc.
And he will share with us the experiences and challenges in setting up HPC data center.
Hello, I'm Hakan Bayindir. I'm a senior researcher in TÜBİTAK Kulakbim, and I will try to share what's building a new data center in 2023 entails, especially if you're not building it from startup of ground up into a new building. So this is what we end up with. This is the result. This is the bird's eye view of what we are building now. In the middle, there's something labeled Truba DLC. This is a direct liquid cooled system. It has no crack or minimum crack load in the room. Everything will be cooled by water as much as possible. By as much as possible, I mean 90 to 98% or minimum 80%. There's a small academic network. There will be routers for the Turkish academic network, and it will be air-cooled. There's a cloud group. It is also mostly air-cooled. I mean, we may use liquid door cooling for conventional servers. Also, there's a Truba air-cooled room for storage and smaller loads. Again, we will try to use as much as door cooling, but it is not set in the stone yet. This is the first outside view of the data center. We have a power and UPS group. The generators are on top right, outside of this view. We have 2 generators. Also, the direct liquid coolings, buffer tanks and chillers and hydronic rooms and pumps are near the power center. Also, we have a couple of dry coolers for the air-cooled systems on the top of the building. So why we are building this thing? First of all, infrastructure gets old, and our old data center is not very usable for newer, denser systems. Systems are getting smaller, they are getting denser, but they require much more power and they demand much better cooling, thanks to NVIDIA and GPUs. They are literally jet engines blowing scorching heat. An anecdote, when I get cold in the data center, I move behind the GPU nodes to get warm. Your normal infrastructure ages. Even if you have a cutting-edge system with efficient cooling, everything gets old. Pipes get corroded, you lose capacity in the dry coolers, fans lose their capacity. Also, the new hardware, since it is denser, starts to stress your heating capacity and heating patterns in the room. So newer systems pump much more air, and your previously designed airflow gets interrupted, gets disrupted. You cannot continue to use the same system for newer loads. Also, we need more capacity, and our room cannot handle it power-wise. Also, since you get the same amount of servers, you get same amount, much more amount of computing. But as I said, it needs power. Also, the new cooling systems are much more efficient. So when you change your infrastructure, you get efficiency as a side bonus. So what we are trying to do, we're trying to get twice the cooling capacity and compute capacity. The room is not much bigger than what we currently have, but we are trying to put much more inside it. A DLC system and other liquid cooling systems in other rooms. As I said, some of the spaces are air-cooled primarily, but we try to remove as much as heat by cabinet door liquid heat removal systems. You change your back doors with heat exchangers, basically. We want to have busbar electricity because normal cables get cooked over time. Also, we want to be able to host larger, taller cabinets. The other older rooms, ceiling space is a bit limited. As I said, they were unattainable in our current room. So this is the side view of the building we are currently living in. Data center is on the ground floor, and power and cooling is a bit above that. As I said, we have dry coolers in the ceiling, but the whole building is not ours. There are other laboratories, other people living inside this building, so we have to fit in the space given to us and work with around the people. Also, we have to pipe this thing around, and also there's existing infrastructure, and it is not easy. Also, the problems are not only limited with the building itself. We are in a university campus, and the university has a ring circuit for balanced electricity distribution, and it is running at capacity currently, and we want to add 2.5 megawatts to it, if I remember the number correctly. Also, the utility company said that we may not be able to bring that power to the campus without adding extra cables, so it is another overhead. Also, there are other buildings around us. Some of them are sensitive laboratories, and their piping and their infrastructure is also around us, including a natural gas pipeline. So we have to work around it too. So the construction is almost complete, despite all odds. We have energized the power in modules, but the data center inside is not yet energized. Monitoring and environmental control systems are being installed right now. Since DLC piping is very dependent on the system you are getting, and the parameters are dependent on the system vendor, we are trying to finalize these things. And we need to migrate our hardware and soft data from previous data center to this. And that's all.
So I take it this place isn't a purpose-built data center?
No.
Okay. So this is something that I meant to look up, but I haven't had a chance to. There is increasingly a move, at least in the UK and some places in Europe, away from building dedicated data centers to just putting up modular data centers that can be extended.
Mm-hmm.
Because building is a huge source of CO2. The release of CO2 from concrete setting is absolutely phenomenal.
Yeah.
And a building's going to last maybe 30, 40 years. A modular data center is going to last 25 years, and it's made through recycling materials. Do you think in hindsight you could have put modular data centers somewhere within your infrastructure rather than taking space in a physical building?
Actually, if I visit our history, when we are building the data center we are going to leave behind, we looked after container-based data centers. And it was not possible to fit one in a very efficient manner. And Sun wasn't bought by Oracle, and Sun was working on installing these things. It wasn't very space efficient to install these things. We are in middle of the city, and we are also dictated by the fibers arriving as the National Academic Network POP points. So we are also very limited in terms of power, in terms of logistics. Also, we have to think about the network endpoints. Also, the same thing is we try to have, we talk with Huawei and other vendors about container-based data centers, and it was not possible to make anything in meaningful size with meaningful amount of money. So we had to do this. So it is not ideal. We would have our own building, but then employee logistics was another story. So we were unable to move too much out of the city. So it is the best we can do after years of trying.
Okay, I got a question. You mentioned the costs. Do you have a feel for the difference in cost you're experiencing by using by reusing an existing building as opposed to starting from scratch?
It depends on the building and, again, energy logistics. Because when you consider the power you consume, when you pass 2 megawatts mark, it is something entirely different to carry that amount of power inside a city or to somewhere else. Sometimes cabling costs and talking with the utility company and making them do it is almost third the cost you are trying to lift, let me say. So sometimes having a building or making a building in a logistically easier place becomes much more cheaper in the end. So it is a very big trade-off and very big balancing act to build a data center this big in terms of power, in terms of density.
Okay. Thank you very much, Hakan. So Hakan, as the same as the next speaker, they volunteered to participate in this green computing. And next is Sean DeWitt, former colleague of mine. I think you are the longest acquaintance here in this. I knew you from long. And he's from UK Atomic Energy Agency. And he promised a controversial talk.
Right, good afternoon. So last session, how long have I got, Kathleen? 30 minutes, so I've definitely got 30 minutes, okay. So I'm gonna start reiterating what Jerome said. Can IT ever be green? No, absolutely not. It's a huge source of carbon, it's a huge source of pollution, it's a massive problem. And that's where I was gonna stop, because there's no point in talking anymore. We can't be green, so whoop. Batteries, terrible things. I don't know where the back's gone. It's fine. Okay, so that's where I was going to leave it, but Kathleen said I needed to fill in 30 minutes. So let's see what I can do. Okay, so how things go at the moment. We have a very linear economy in terms of how IT is created. We run dirty power stations, we mine things, we ship the minerals to somewhere where they're refined and processed and made into something, and then they get flown out somewhere. So if I'm buying an HPC kit, it might be built in America or built in Germany. It gets flown over to the UK, gets put on the back of a truck, gets delivered to me, I use it, and then I throw it away. And that's how it works at the moment. What we need to do is this wonderful thing, and I'm sure you've all heard about it, the circular economy. And the circular economy will save us all, right? Okay? So in theory, as I go round, the amount of stuff that I'm going to try and use the laser pointer. How brave do I feel? Hey, in theory, I'll stand over here so that I'm close to the mic. In theory, this will go down as you are able to recycle more. There's still manufacturing costs, you're still going to have transportation costs, you're still going to have use costs. Hopefully we can move away from carbon-rich energy sources to more renewable sources. But this is the goal, this is the goal. And of course, there are slogans to go with it. So reduce, reuse, recycle is one of the common ones. Before that, there was turn waste into wealth. So recycle things, sell those things, get money. Great things to do. But all of this actually costs money. So in terms of a data center, we've been working on baselining at the moment. The first thing I need to do for baselining is make sure I've got intelligent power supplies so I know how much power I'm using per rack, because I don't want to know across the whole data center. I literally want to know per rack. So all of this costs money. Bit of background about the sources of CO2 emission. So like I said, it comes from all of these sources: mining, refining, manufacturing, transport, operating, and eventually throwing away, okay? So how heavy is an iPhone? Who has an iPhone? Hands up, who has an iPhone? Who's guilty? Okay, do any of you have an iPhone 12? 11? I didn't go any further back because I thought you're all IT professionals. You're going to have the latest and greatest. Anyway, so if you have an iPhone 13, your 128 gigabyte one, how much does it weigh? 128 grams? A couple of hundred grams? Odd, about that much? To manufacture it, and I think this includes use, but I can't remember, 64 kilograms of CO2 is emitted. So your iPhone actually doesn't weigh 128 grams, it weighs 64 plus a little bit. But you can see, to be fair to Apple, they're improving CO2 emissions with each generation. I mean, it's not a lot, but it's good. They're doing something. So, pop quiz. Who has a laptop? How much CO2 do you think is released in use of your laptop? Now, this is over a three-year period, so it takes into account an average energy use globally. How much CO2 do you think is released in the 3 years from mining to manufacturing and use of a laptop? Give me a figure. Somebody give me a figure. You. So how much? 300. More? Higher? Very good. 360 kilos, roughly, for that. So Dell are very good at this. So Dell actually have data sheets for all of their laptops, all of their servers. So I've stolen all of this from Dell. You can see the amount of energy that's used in each part of the life cycle. So 364 kilograms. Okay, what about a desktop? Who has a desktop at home or at work? Okay, how much carbon? Come on. Anybody with a desktop? 500? Any advance on 500? Higher? Lower? 600. 530. Haken's doing well here. But you can see the difference in the actual where the CO2 is generated. So now the usage is much more than the manufacturing. Now, next one. Servers. Servers, terrible polluting things. How much CO2 is released from a server? And again, to be fair to Dell, all of those figures are based on an open source calculation, so you can go away and you can validate it. I'm not going to put the reference in here. You can go to the Dell website and you can find out how much is generated by a server in its lifetime. And this time it's a 4-year lifetime. A ton? 3 tons? Any advance? Any advance on 3 tons? No? Come on. Nearly 4 tons. But here you can see it's very different. Now the usage of the server actually really dominates. It's massive compared to anything, even the manufacturing. So finally, oh damn, I forgot to put the animation in. Storage. So storage, you'd think would be cheap. Storage is massively, massively CPU intensive. I would point out this is for SSDs. So if you're running hard drives, it's slightly less. But storage is a huge CO2 producer. So if you can minimize your storage, you're doing well. 23 tons in a 5-year lifetime. 23 tons. I don't think I have it in here, so I'm going to mention it now, because I don't think Jerome mentioned it. How many trees do you think are needed to offset 1 ton of CO2? 100? Anybody else? 300? Come on, I wanted that. 40. 40, or 1 acre of grassland. And your point about seagrass is a good one. I should look up what seagrass is, because I know it's a really good carbon sink. What's that in real life? So in my Ferrari miles. So in my Ferrari miles, which are completely green, of course, I can go 277 kilometers in my Ferrari to produce the same amount of CO2 as an iPhone. For a server, I can go 14,000 kilometers. Now, what's 14,000 kilometers in terms of Europe? Is that roughly the length of Europe? No, it's more than that, isn't it? It's sort of halfway around the world. I could drive my Ferrari halfway around the world, and that would be great. I'd much rather do that than run a bloody server. For storage, yeah, I can go around the world many times. My Ferrari is excellent for this. So what can we do? So I'm going to go back to that reduce, reuse, recycle thing. What can we reduce? We can reduce the amount of stuff we buy. We can reduce the amount of power it consumes. We can reduce the amount of water it uses. But how do we do that? Give me some ideas. So we already mentioned procurement. Thanks, Jerome, for building this in. Consider total cost of ownership, but total cost of ownership isn't everything. You need to consider the full life cycle. Build CO2 life cycle into your procurement. Use cloud. Everybody loves cloud, right? Everybody's using the cloud. Every government says cloud first. Must go to the cloud. It's a great thing. We'll see. Look for green labels. So I'm going to start with the case against total cost of ownership. So I'm going to go back to the storage thing. So here I'm going to compare SSDs to standard hard drives. Okay? SSD is more costly, but look at the power difference. And this power difference is when they're operational. So in the SSD, I'm using 3.3 watts. For the hard drive, I'm using 12 watts. So I'm using 4 times as much power to run this drive. And that gets much, much worse if they're idle. Because the SSD idle uses microwatts. But the hard drive is still spinning away, still doing things. Yes, you're not reading anymore. You don't save very much power in an idling hard drive. So, total cost of ownership. Why wouldn't I buy an SSD? It's going to cost me less over 4 or 5 years. I'm going to run my storage. Right? No. No. If you look at the carbon offsets, SSDs are much more energy intensive to manufacture, and that's part of the reason why storage costs in terms of CO2 emissions are huge. Now, this assumes you're going to replace your storage every 5 years. You can see that, yes, you save, as an institution, this is great. You can sell this to your finance people because my total cost of ownership is much less because I'm going to use a lot less electricity over my 5 years. It's what? Nearly a quarter. But as soon as you start building in the CO2 in the manufacturing costs, you can see that transition varies a lot. Now, selling that to finance is much harder. Selling that to your procurement team, saying, I want to use carbon as a criterion for selecting my storage device, not an easy sell, because they're going to have to push up the costs. But it's a good thing. It's a good thing. Okay, cloud. Cloud. If we all move to cloud, everything will be rainbows and unicorns, right? Everything's going to be just wonderful. It's not going to cost us anything. The carbon will just disappear in a puff of air, and we're not going to have to worry about it. Is that true, or is it all smoke and mirrors? Okay, let's see. So to be fair to the big cloud vendors, and I couldn't find Oracle in this, I'm afraid, a lot of them have made promises that they're going to be either carbon neutral or carbon negative, and it sounds really good. You have to dig about underneath to realize what it actually means. They're still going to be putting in CO2, but they're going to invest in sequestration. And most of them now have a carbon calculator. Yep, so you can see how much carbon you're going to use. Except not all of them are entirely honest. They calculate things in different ways, so there's different scopes of emission. Has anybody come across scopes of emission? I'm not going to talk about them there. You can read them while I'm talking about this slide. Azure, to be fair, it is the worst cloud system I've ever come across. Don't tell Microsoft. But they actually report Scope 1, Scope 2, and Scope 3 emissions, at least in some regions. So in Europe, they do. In America or Asia, they don't. Now, that doesn't mean to say there are no Scope 2 or Scope 3 emissions in America or Asia. They're still there. They just don't tell you how much it's going to be. Google only reports Scope 2 anywhere in the world. AWS only reports Scope 2 in Europe. The carbon calculator just doesn't work if you're in America. So, is cloud the answer? Maybe. There are use cases for cloud, and I'm going to come on to that because I'm not going to diss the cloud vendors. They provide a really good service and they do some great things. Some problems with it. So we all know that big data centers are huge sources of CO2. You can see it in this graph where it shows the amount of CO2 emitted by data centers compared with other sectors that are considered high CO2 emission. So you can see that in terms of the global CO2 emission, it's, I can't even read that, something like 5% of global CO2 emission is coming from data centers, which is a huge amount. So how can we reduce that? One thing you can do, if you're going to use cloud, is make sure you use a cloud center in Europe. Here's a graph showing, or a pictogram showing the CO2 emissions by region for large data centers. I can't remember whether this is Microsoft, but it comes from a third party, okay? In Europe, everything is good. Let's see if I can actually read that if I turn around. Metric tons. Can you actually see that? Can you read that? Okay. So the green is less metric tons, the brown is high metric tons. So if you want to run in the cloud, try and do it in Europe. The problem, so we did an experiment a few years, maybe a year and a half ago, where we wanted to try running GPUs on the cloud. We wanted the latest and greatest GPUs at the time, which were A100s. They were only available in Northwest America, in a dirty data center. Now, we didn't even think about CO2 at this point, because this is a fairly new initiative for us. But increasingly, it's becoming aware that we have to be aware where we're running services. So what else can you do? Okay, first of all, don't necessarily buy for peak demand, because you're going to have a lot of servers sitting there idle a lot of the time. Buy for sort of average demand or slightly above and look towards cloud bursting. Again, use sources in Europe. One of the problems with cloud bursting, this whole idea of bursting opportunistically onto clouds, is how do you pay for it? At least within a government research establishment, it's very difficult to go through procurement, because procurement like to have a shiny thing that they can put a label on. You can't put a label on a cloud instance for 10 minutes and then tear it down again. They want you to buy a reserved instance for a year. Then they can pretend to put a label on it, and they're happy. Backup is great on the cloud. Backup is really good on the cloud in terms of greenness. But you have to be aware of the costs if you ever need to recover it. So Amazon Glacier is really cheap. There are other solutions out there that are equally cheap. It's very green, but if you want to recover the data, it may be 30 days before you can get your data back. Look at the terms and conditions. And buy anything with an eco label. So Jerome mentioned this. I'm going to go through some of them. and ask for these life cycle analysis data sheets that tell you how much CO2 is being produced. Build that into the procurement cycle. It doesn't need to be a high priority. Maybe give it a 5% weighting, but at least you're doing something. You're putting something in place to say, yes, I want to become greener. Energy Star. So one of these labels is Energy Star. Energy Star started with the US Department of Energy and the US Environmental Protection Agency. It was adopted by Europe. There was an official collaboration, but that finished, I think, in 2018, 2019, although it is still recognized in Europe. There's no official collaboration anymore, but it's also recognized globally, and it covers everything that you might want in a data center. It includes workstations, lab stations, monitors. You can build your entire IT infrastructure with Energy Star labeling. And that guarantees a certain level of performance and efficiency. So that's a good one. EPEAT. So EPEAT I've came across relatively recently. It's available in 43 countries, managed by the Green Electronics Council, who I have no idea. EPEAT stands for whatever it says on that side. It actually goes down to the level of individual servers. So individual servers and individual laptop models can get EPEAT certified. EPEAT is a level above Energy Star. It's much more efficient. It doesn't cover so many things, but in terms of IT, it's great. It's great. And you can build these into your procurement cycle, and everything will be wonderful. TCO. I got confused by this one. I saw TCO and I thought total cost of ownership, and it's got a nice green label, so it must be something green. It's not. Okay, it's all about ergonomics. I'm not saying it's not important. It's how easy it is to use, how likely it is to cause you repetitive strain injury. TCO is a good thing, but it is not a green label. Confused the hell out of me. Reducing power. What can you do to reduce power? You can annoy your users by having a group policy where you power off all your desktops, laptops that are attached to your network at 8 o'clock at night. So they have to come on in the morning. It will annoy users, get them used to the idea. I mean, how many people already have a policy at their sites where you're supposed to turn off desktops when you leave the office? Really? 1? 2? 3? No, I'm not saying you do, but there's a policy saying you should. 4? Okay, so it's not an uncommon thing. How many people actually do it? 1. 1, 2, 3, 4. Oh, wow. I know I don't. I'm terrible for this. So having this policy can save you an enormous amount of money. So if I'm talking about having a desktop computer, you saw how much it was generating. If it's got a hard drive, if that hard drive is spinning away all night with nothing to do, just power it off. So the user has to come in. You have to be a bit intelligent about it. So if people are running long-running jobs on some high-power workstation, you probably don't want to do that, because they're going to be really, really annoyed if they started at 9 o'clock in the morning and it's almost finished and you kill the machine. So you have to be a little more intelligent. That's a good question. Ask me that at the end, because it'll give me time to think about the answer. Yes, in general, that is my response. Yes. But sometimes they can't. I could go into that. Shadow IT. Who knows about shadow IT? Who knows what shadow IT is? Nope. Okay, so you know what it is. So shadow IT. I work in a research organization. Now, researchers will buy like an oscilloscope with a PC attached to do some post hoc analysis to it. Okay? They buy it, and they buy it as a package. IT know nothing about this new computer. It just appears on the network. Okay? So we have no control over that. We have no idea whether it's green certified. Typically, we don't even know if it's had security patches installed. Now, there are tools you can use to address that. So we use a tool called ClearPass. At the moment, we're not enforcing it. We're just using it as a recommendation. But taking control of your shadow IT can reduce your energy costs enormously. At least you know where the hell the energy is going. And this infographic here from OpenSAP shows that globally, roughly 50% of your energy costs are coming from shadow IT that your central IT department know nothing about. So controlling that is really good. I mean, how many people here plug in their phone to a work laptop to charge it or to listen to music? I would imagine most people, because that's shadow IT. You're using resources. So encourage your IT department. Don't ban it, because that'll just annoy your users even more than turning power off. But have this idea of gradually having an acceptance where some shadow IT, because it's been bought with something, yes, they still have to see it, they still have to install all the security patches, they have to install the antivirus software, blah, blah, blah. But access to it is restricted to a few individuals, and it's not open to everybody. Gradually bring in things into that core IT products. Now, this is an interesting one. This is an interesting one for those people who run data centers. GPUs. How many people run GPUs? Actually, how many people are data center people? 4, I think. So GPUs, everybody knows GPUs. Everybody loves GPUs. They're used for machine learning. They're used for AI. They're used for rendering frames. Massive thing. But if you look at the actual efficiency in almost every use case that's ever been found, you see in that left-hand graph, you actually get diminishing returns once you go above gigahertz in clock speed. So why not just run your GPU at a gigahertz? So there's been a lot of analysis done. At 1 gigahertz, you have a 10% impact on your floating point performance. But it reduces your energy by 16 to 24%. So for a 10% reduction, and the user isn't going to notice a 10% reduction, you could get a 24% power saving. Now that changes the graphics, the implications of GPU significantly. Then GPUs actually become quite reasonable. Software. Jerome mentioned software. We all use Zoom or Teams or some sort of video conferencing now since COVID. It's commonplace. But nobody ever looks at the greenness of software. So I've taken this one because it's a pet peeve of mine, because I hate Teams, but I love Zoom. Zoom typically uses much less power than Teams. That's because Teams is a much bigger ecosystem and infrastructure behind it, and it has to do a lot more things. But if all you're using it for is video conferencing, choose Zoom. I mean, there are security issues around that. I know that I've got friends in the defense industry who are not allowed to use Zoom at all, because there's still the potential for it going through China. If you can't use it, fine. Turn your camera off. Get 75% power reduction. Now, you get less with larger meetings because, of course, you're smaller. What I've started using it for is I will turn my camera off and turn it on again with the microphone when I want to speak, because suddenly people notice you. So it's actually a good thing. It's actually a good thing, and that can save an enormous amount of power. And backgrounds. I use backgrounds all the time. Everybody uses backgrounds. Backgrounds consume huge amounts of power with Zoom or Teams. Don't try not to use them if you can. Ideally, when I looked at this, it said to have like a plain gray sheet behind you, but no. Just something that isn't a background, it can reduce the power consumption. Right. So that was the first bit, which I don't remember. Talk about recycling. Don't let your computer end up in West Africa, because that's where still most IT crap goes. West Africa, parts of Asia, parts of India. And it's terrible. It's almost as bad as conflict things. Okay, so we. You mentioned we. Jerome mentioned we. Covers almost IT equipment, except I couldn't see if it covered racks or power supply units. But it covers pretty much everything else. And it has a requirement that 75% by weight must be recovered of IT equipment. And 65% by weight has to be recycled. Now, you can read what the difference is there, because I had to look it up because I couldn't work out what it was. There is no US equivalent. Absolutely no US equivalent. Some cities and states have introduced laws to do this, but there is no federal recycling recovery. There's nothing equivalent to the WEEE. So the WEEE is globally, I think, a world leader. Japan's got some very good recycling laws, but they're primarily aimed at household electronic waste, not at IT data center waste. So they still have a problem. Taiwan, and we have a colleague from Taiwan there, they actually have a really good e-waste recycling thing. So over 50% of e-waste is either reclaimed or recycled. And that is absolutely brilliant. That is absolutely brilliant. So let's look at the carbon cost of a computer. So you can see by chemical composition how much that I've got to admit, I couldn't find anything modern on this. So this is a 1995 desktop with a CRT monitor. So those of you old enough to remember will know this doesn't really reflect reality so much, but it's a good use case. So you can see most of it is silicon, iron, aluminium, copper, pretty much what you would expect. And there's this, let's see if I can get it to work again. This tiny fraction up here, which are trace minerals. Okay, tiny fraction. But now if you look at the CO2 footprint for those trace minerals, they go from 2 or 3% up to maybe 10 to 15%. And that's because these minerals are much more costly to manufacture. They're much harder to find. Some of them, all right, are byproducts of other things. But for instance, hafnium, getting hold of hafnium is almost impossible. It's really difficult to mine. It's very carbon intensive. So what elements go into your computer? So we did all the common ones already. You can see them there. Anybody want to guess some other minerals that go into your computer? Anyone? Oh, come on. That many. There are over 50 elements of the 96 that commonly occur that go into your computer. That's a lot. That's a lot. So, what about recycling them? Here's a nice graph showing how much is recycled. And you can see things like zinc, copper, iron, aluminium, over 50% is recycled. Great. But all those trace minerals, hafnium, cerium, tantalum, elements I've never even heard of, less than 1% of them is recycled because they're too hard or that it's not cost effective. So all of those trace minerals that make up a huge CO2 emission, that's going to continue until we find some way of recycling these trace minerals. Okay, by selected country, how much is recycled? So you can see actually Europe is very good, as is Taiwan. So over 50% typically is recycled or reused. China, USA, 15%. They're generating huge amounts of waste. I don't have figures for Turkey. I couldn't find figures for Turkey. Brazil, Indonesia, nothing. Nothing. So how can we, in Europe, and this actually, there is a Brazilian guy, what's his name in EGI? Sorry? Renato. So he's going out to Brazil. Maybe we should talk to him and say, you know what, you can join us if you start recycling. Okay, so you can see it's still a problem. And why is it a problem? Because recycling trace minerals is hard. You can see that in that graphic. How long have I got left? 5 minutes. Okay, reuse. So this is much quicker. Reuse. So if you run HPC systems, it's hard to reuse computers. A desktop, once it's dead, is a dead desktop. It's pretty much nothing you can do with it. But a server is different. A server is different. So if you're running an HPC system, you typically run the servers for 3 to 4 years before you start replacing them because they're too old at that point. You've got to keep up with the latest and greatest. But there's nothing wrong with putting that server into a local cloud infrastructure And you can extend its life for 2 or 3 years. It doesn't matter if it fails, because if you've got your cloud system set up, it will just recover on a different node. So reusing it in that sort of thing, it will extend its life for 2 or 3 years. So that amortizes that big CO2 emission. So you can spread it out over a longer time. And I'm going to put in a shameless plug for something called the Fairphone, which has nothing to do with fair data. So you see a picture of a Fairphone, you have one. Oh, okay. Buy this man a drink, okay? Everybody buy this man a drink tonight. What you see on the right is every single component that is user replaceable. So if your phone breaks, so I have a problem with my phone, the charging unit breaks, it's broken 5 times in 2 years. I could just order a new one and replace it myself instead of sending it away to some company in Hungary where it takes 10 days before I get it back, and in that time I have no phone, which, because I have multi-factor authentication, means I can't do any work, which is great. But I recommend the Fairphone. EGI is using Fairphones. So, big tick for EGI. Big tick for EGI. Fairphones are the way to go. Carbon offsetting. I've already mentioned a bit about that. How many trees do we need to offset? So you remember that graph or that infographics on the CO2 emission? You can see how many trees you need to replant for every iPhone, every laptop, every desktop you use on this infographic. But I thought actually that's pretty useless because an individual server makes nothing. So let's take it to an organizational level. 1,000 staff, roughly 1,200 phones, because everybody's got, well, most people have one phone, and your CEOs and all the important people have 2 phones to separate their work. 500 laptops, 500 desktops, 100 servers, 2 storage servers. Now here the balance changes because you don't need to run so many storage servers. So the storage servers go down a lot. But you can see just from the server count, you're going to have to plug in 1,600 trees, or set aside 1,600 acres of grassland. Or I'm going to take a wild guess here and say 80 acres of seagrass. But that's a wild guess, so I'll look that one up. It's costly. Replacing the environment or trying to offset it's practical, it's doable, but finding the right location, how you pay for it, it's not trivial. But trees aren't the only way. So Hakan mentioned his data center. If you're building a data center from scratch, use the waste heat to heat the building. Can't do that in older places where you don't have the infrastructure because you need to build this in from the start. Trees are not the only ecosystem. So I've mentioned grasslands, pollinator habitats. Invest in solar cells. So somebody's leased a wind turbine. Think about doing things like that. It doesn't have to power your IT equipment. You can offset it against something else. From a site perspective, that's pretty good. But I'm actually going to plug some random ideas. You know what? Give some of your compute time, if you're running a data center, to projects related to greenness. So give some of your compute away for free to people who are developing wind turbines. Give it away to people who are developing new materials for batteries, preferably green materials for batteries. I failed to put in the shameless plug. Give it to me because I'm developing fusion energy, which is the clean energy of the future. I'm more than willing to take as many CPU cycles as you can give me. So how do you do it? Build a roadmap. No, don't build a roadmap, build a cycle path. You always need a cycle path. Think of the easy wins. What are the easy wins? So the easy ones I've mentioned already. Monitor your energy usage. Calculate your CO2, which is what Jerome said. Display that CO2. Make that information available to EGI. EGI are already doing a lot of the accounting. They can build this into their accounting system. Include carbon accounting and green certification in your procurement. Investigate offsetting options. Declock your GPUs. For God's sake, if you get nothing else out of this, go home and declock your GPUs. So these are the quick wins. Medium term, so this is how you do the energy calculation. Just to prove that this information is available, at least in Europe, in every country, here's a live, well, it's not live anymore, but it was a live graph when I snapshotted it, of the amount of CO2 generated by country. So I selected Estonia randomly, 115 grams per kilowatt hour. And you could do this for every country. I'm not sure how frequently they update. The UK one updates, I think, every 30 minutes. So you can do almost a live carbon counting. And you can put it in a nice Grafana graph thing, show it with your power, with your CPU usage, blah, blah, blah, blah. And it becomes just another metric that you can report on. Yeah, okay, so that's just a picture of a Grafana page. Medium term, switch off, power off policies. Dark data centers, I haven't mentioned, really use dark data centers if you can. If you don't know what a dark data center is, it's effectively nobody goes in it. So we run a modular data center, which is effectively a dark data center until something goes wrong. So nobody goes in it, nobody touches it, it just sits there. Control your shadow IT, extend the lifetime of equipment. So, after all that, can IT ever be green? So I'm going to borrow from Douglas Adams. I said no initially. Mostly no. And that, I think, is everything. Any questions? Or for any of the speakers? Go home and declock your GPUs now, particularly you, Hakan. How do we get a Fairphone? I think you can order them off of Amazon, can't you? Yeah, fairphone.com. So Fairphone has them. I really, that is one of the biggest things you can do as an individual is buy a Fairphone. I'm sitting here with an Android, and I'm thinking my next phone is going to be a Fairphone. I mean, they're not like an iPhone, they're not that super brilliant, but they do everything you want. So I know about this. ARM, for specific uses, ARM is much lower power than other architectures. However, things like I can't remember what their HPC server is. Anyway, Fugaku is an example. Fugaku has got an ARM chip on it. Runs just as heavily as an Intel. Makes no difference at that level. Sorry? Yes, yeah. But in turn, once you get up to the HPC level, ARM is no more energy efficient. It's a good low efficiency chip for things like a phone, where Intel can't compete. AMD EPICs are about the same as well. I don't think you maybe get 2 or 3% energy saving. But certainly ARM, I can't remember what the name of the ARM HPC nodes is. Okay. But yeah, ARM, it's at the HPC level, you don't save anything. Okay. Yes, yeah. I didn't get paid for it. That's not strict. everything. I have both a local copy on a Google Drive copy, so whatever it happens, we are ready. Vuoi usare il tuo computer? Ok, facciamo una prova. Yes, I received it. I have a local copy and also on Google Drive. So. This is not so safe. I think it's better there. Ah, but then you have the microphone. How it works? This? We understand, so I do not see the problem. No, ok. Se funziona il mio, funziona anche. Tu sei il terzo, ok. Hello? It works? Yeah. Yes, but where I put this? There, because it was falling. Because then the microphone. I don't know if it works. Keyboard setup for this. Please, the key. Press the key immediately to the right. Ah, perché lui lo vede. Lo vede come una tastiera. No, even because then we have to switch the map. So let me see if I can configure, because we need to. Hanno chiesto di andare in presenter view. Che usi metti su questa. Ce l'ho su questo computer, le ha. Invece che mio. Stop mirroring. Oh my god. Okay. Ah, ma mo lo vede come primary quello. Li vede di qua. Oh my god. hanno chiesto della presenter view, so che tu qua c'hai le note, allora io non l'ho. Sì, infatti a me sembra la cosa più semplice. Ok. Che stupido. Yeah. So this is the slide. We can open it. Click on the video.
Yeah, it's easier with less people.
Quindi lui Andrea Giacchetti e Marzin. Yeah, then, okay. Then it's better. No, that's not so new. There. Welcome to this Artificial Intelligence Machine Learning Lightning Talks session. We have 3 speakers for this session, so it's also a lightning sessions. The first one is Carmina Vica, right? Is from Surf. She's from Surf, right? Okay, she will tell us more on his background. Attention to the cables.
Okay, hello everyone. I'll be careful, we had technical issues with the laptop, so thank you. So today's presentation is a very interesting project, Safer City with Smart Bikes. I'm Carmina Vica, Data Processing Advisor at SURF, Netherlands. It's a collaborative organization supporting more than 100 research and education institutes in the Netherlands. So I would start introducing the project a bit. City of Amsterdam was experienced lots of maintenance issues of the public assets, which with a negative impact on the traffic safety and personal well-being. So the maintenance of this public assets became challenges in time with increased costs, scheduling staff for repairs, and so on. So as they were reaching out to Hogeschool of Amsterdam for some potential solutions, and this way a collaboration between Hogeschool of Amsterdam, Municipality of Amsterdam, SURF, and Volotech Solution was launching a smart bike project to overcome this, to find a solution, technical solution for this issue. So as you can see that these are a number of major issues impacting the public assets in the city of Amsterdam. So basically, the decision was to launch this smart city using Smart Byte project with funding from European Digital Innovation Hub. So the final goal, we're still in kind of a phase one. For the final phases is to actually manage these public assets with LIDAR, which is light, using light technology and measure remotely the distances, variable distances of assets, video AI to detect objects in images, and edge computing technologies. I will just briefly try to explain, you can also read the slides, but why we were thinking that edge computing is one of the best choices in this case versus cloud computing. Basically, local data processing, it's especially when you have lots of data to process, it's much easier, cost efficient at the edge, and also doing analysis, AI inferences as well. And basically, we want to reduce the volume of the data sent to the cloud. It's improving system reliability, and one of the key things I would like you to remember is increasing scalability. And we have much better control over data access, especially with concerns about sensitive data being sent to central locations. Mark, I was looking for how to switch the video. I'll let the video show you the story of this project. Yeah, there. Can you have? I have.
Edge device, a Jetson Nano with the camera, scans the environment, detecting streetlights.
SURF and HVA want to explore and prepare for a transition into digital cities. Together they developed an edge device. This device can be used to manage and maintain the city in a smart and safer way.
The Edge device, a Jetson Nano with the camera, scans the environment, detecting streetlights, if they're broken, if they're tilted, maybe deteriorated, and then we can process it on the device itself, which improves many things like latency, security, privacy, and make sure we're not sending back and forth all the data.
The images are taken with the camera on the bike. And there is also this computing unit that can do the analysis. So the image recognition itself happens at the edge. And in real time, data are streamed towards the central cloud. And that's actually where we can see it also on our computers. So for SURF, this is an innovation project. What's new about it is expanding beyond our own data center. We are expanding in two ways, because first of all, it's supporting the edge architectures. That's a big trend nowadays, like 5G networks. The other important aspect is working with public clouds. Public clouds in general have many services, and our role as SURF is to be an expertise center for researchers for the public clouds, because we can advise on how to use the public clouds and what's the best solution for a particular research problem.
The most important thing about this project is that we're using edge devices, which is at the forefront of technology in making sure we can decrease the cost of maintenance in the city.
Okay, so the video was great. I hope it explained a lot to them. I'll just go briefly onto the some more details of the design of this project. It's basically we were thinking how to spot this public assets deficiency timely and accurately. That was part of the problem. So basically, we're thinking that eco-friendly periodic inspections by bike would be a great idea, especially there are bikes, especially so many deliveries by companies delivering foods or goods by bike, and they go actually in the places where cars cannot go in Amsterdam. So basically, this will give a very good, accurate number of identified objects with issues and defects and exact GPS locations. And also the visualization and reporting of the citywide issues can be easily linked with existing workflow of the City of Amsterdam systems. So basically, the phase 1 goals is to improve personal well-being, traffic safety, a very important thing, and also minimize liability risk, which probably happened a few times over years, and also prevent a high workload in the peak season of fixing all this. So this project, phase 1, implemented a number of use cases. 2 examples is detecting light posts if they have any issues using the edge devices. Another use case, basically street lights which were tilted, detecting these problems. This is showing exactly the main key point phases. First, how the models were trained on basically labeling a light post using the Label Me app, and the way the image detected the light angle in several steps. How we implemented the solution? So in hardware terms, we have used NVIDIA Jetson Nano and another model, creating, these are the key components, and 32 gigabytes SD card. Also allowing Wi-Fi and 4G connectivity for basically uploading the data to the cloud. Of course, a battery, camera, and GPS sensor, and a gyroscope. Basically, I want to highlight that a key part of architecture of the solution is using cloud, which is, if we want to achieve scalability at the edge, cloud is the key. Again, there are many benefits. One of them, it's easy to scale if we use many edge devices, and we have remote device management on the edge. This remote connectivity, event-driven data processing, modular design, it's one of the key benefits of using basically cloud services. I would like to also mention briefly the 2 major components of the architecture. AWS IoT Greengrass, which is accomplishing data device management and local data processing, all the AI inferences, removing sensitive data, a very important thing, it's done on the device, edge device. Everything on the solution using IoT Greengrass, it's using modular components for customized design, which can be expanded easily for multiple use cases, even from other domains than public assets management. In this diagram, you can see that the data pipeline microservices as components, they basically each component is acting like a microservice, it is configured as such, so taking picture, uploading images to the cloud, removing sensitive data, so it's can be customized for different use cases. And also this AWS service used in this project, it's also doing the complex job of orchestrating event-driven workflows on the device. For the artificial intelligence architecture of this project, we were using AWS SageMaker. We are relying on using publicly available models for this. And in reality, for each use case, there was a dedicated model to detect object of interest. The models were pre-trained on a COCO data set to detect especially faces for the ability to be removed on the device. So the custom models were trained with transfer learning. So this was chosen because it offers the allowing the researchers to very quickly upgrade their models and redeploy. So they can continuously work on this. It is very useful. And also offering the machine learning flow tool. So this is in a very high level presentation of this project. But what I want you to remember, there are three things. Using the trend today is basically pushing computation to the edge. So with this project, data is locally processed and analyzed at the edge. A second thing, most important for achieving scalability, cloud is key. This is another big trend today. Basically the pull to the cloud, it's very important. And the third important thing to remember about this project is the modular design, which can be customized for different use cases, is a blueprint, architectural blueprint for smart edge computing at the edge. So we're continuing with phase 2 of the project, basically going deeper into the artificial intelligence, machine learning processing. It's still at the beginning, but we are very optimistic about this project. Thank you.
I would like to ask some questions, but we are in delay. I hope we can contact you later or at the social dinner. I guess also from the audience there are some questions. So the speaker is Marcin?
Yes.
Right?
Person, right.
From ESNC?
Yes.
That is
okay, I have to
that
be careful.
would talk about the chatbot for use, right?
Yes, that's true. So good afternoon, everyone, and well, it's been a long day and a few sessions ahead of us, but I'm very, very glad that at least some of you find still the time and energy to join yet another, hopefully interesting session. So I'm Marcin. I work for PSNC, Poznań Supercomputing and Networking Center in Poland, and I'm also the task leader in the EOSC Future. I'm going to present briefly the chatbot for the EOSC help desk. I will speak about the chatbot, a personal assistant for researchers, the assistant which relies on the chat-based way of interaction, and the application which is run in a web browser. This application, the chatbot, was designed and developed by PSNC with key IT contribution in terms of requirements identification and integration with ticketing system. We started our effort in March 2022, and actually we are ready now to start integration with the EOSC help desk.
Chatbots in general offers many advantages, many benefits for end users as well as service providers. I would like to enumerate a few selected benefits from the end user's point of view. First of all, chatbots in general offer more convenient way of interacting with end users. So the instant interaction is much more natural than, for example, searching using, well, sometimes complicated queries or navigating through many web pages when someone is looking for a concrete information. The guidance offered by chatbots is effective in a sense that people, the end users, don't need to be technically skilled in order to use the chatbots, first of all, and secondly, they don't need to explore many pages, explore many sources. They just can ask for information, and the chatbot should provide them most accurate answer. The chatbots, well, at the bot, they are available 24 hours per day, of course, and 7 days per week. What they offer is the improved user experience in terms of personal interactions. So a user who visits the web page doesn't feel like an anonymous person. User can feel like someone, an identity, an individual who is more recognized and whose interests can be more precisely satisfied. And finally, chatbots fulfills the, I would say, current preferences of the user. They, like I said, they offer more natural interaction. People are more and more useful when it comes to the self-service offerings. And we believe, and I believe that the way of instant interaction is a future of the web and of web portals. But the chatbots offers also some added value for service providers. First of all, we can say about the time and cost savings. So the chatbot can automate some selected customer support tasks. For example, chatbots can acquire basic knowledge about the user, and they can, let's say, get and retrieve some basic information about, let's say, an issue if a user encountered a problem. It is about scalability and consistency. Scalability in terms of ability to handle multiple conversations simultaneously, and consistency in terms of the ability to put into practice some predefined procedures, and always the same procedure, for example, for acquiring knowledge about the user, for ending interaction. And the third option, the third benefit is about the feedback and data collection. Chatbots can collect user feedback much more effectively during interaction. So the feedback and the interaction isn't separated, like it's usually meet when, let's say, a human calls us and tries to resolve our problem, let's say, and then, for example, someone else calls us again and propose to fulfill a web form, a survey to get, let's say, the feedback about the offered guidance. Our chatbot basically is the chatbot which answers the questions, how can I help you? It's somehow the welcome message. It possesses the ability to process natural language, now in English, answering questions, searching through knowledge bases, and currently limited support for even small talks. It can interact with trusted applications on behalf of the user, which means that chatbots can temporarily gain privileges of a user to create a ticket, for example, on his or her behalf. And it's all in one window approach. Everything, interaction, answers, questions, goes into one window. So one window is the place where where the user can find any information. More about the specific features of the PSNC chatbot. So as an input, the chatbot gets the free text, of course, and the predefined options, usually specified by buttons. And as the output, again, the chatbot proposes something in a free text, again, buttons, or a set of tiles, like a rich tile. I think, because I don't see the screen properly now, but I think the middle screen shows you, for example, the rich tile for presenting a publication. And of course, not the whole publication, but a recommended publication, only part of it. And of course, the screens. So a submission form, which is, I believe, presented in the third screen on the slide. PSNC chatbot implements few main use cases coming from the EOSC help desk. So first of all, it's integrated with the Zamat-based ticketing service, ticketing system. Then the chatbot can submit a ticket, submit an issue on the behalf of the user via submission form or through the conversation. I will show this case later on. On top of that, chatbot also uses the EOSC portal FAQ as a knowledge base to find some information. For example, if someone asks what is the EOSC or is the EOSC secure, first of all, the chatbot shares the information there. And when it comes to personalized recommendations, chatbot can suggest a user some research products like publications, datasets, or software, which are part of the EOSC now, and it uses the EOSC recommender system to do that. So it doesn't do it by alone, but uses the external system via the API. Okay, here is the simplified architecture. So the architecture consists of actually two parts. One is the user browser, and the second is the chatbot backend. The user browser, you can see the widget there. The widget actually represents this part of the chatbot, which is visible to the end users. And the widget can be embedded into the UI, into their website. And it is actually applicable as the so-called renderable component. So these components, because we can have multiple sites with the chatbots, these components interact with backend service, implementing use cases, specific use cases, which are seen as core blocks. And we have the separate NLP service to process the natural language. So a few words about the NLP models. So basically, NLP module tries to answer the user's query as good and precise as is possible. And currently, we've implemented three actually separate models, but they are connected to each other. So the first two models actually are responsible for retrieving similar paragraphs or fragment of the text, which is similar as much as possible to the given query. So it's something like narrowing down the context. And then the third module tries to find the answer in this narrowed context. Okay, so now I'm going to present you very short demo. It's about 1 minute demo and it shows how the chatbot can create a ticket on behalf of the end user. Unfortunately, I have some technical issue. I cannot start it off. I don't know why. This is the last one. Here is the play button, but Okay, so it worked at home. It doesn't work now, but yeah, I can assure you that this works, and it should show you how the ticket can be created on behalf of the user in the Zamat ticketing system. So thank you very much for your attention. Don't hesitate contacting me, marcin.wolski.man.poznań.pl. Thanks a lot.
And the last speaker of this section is Andrea Giachetti, that will talk about a completely different structural biological things. Biochemistry. Okay, good. Do you want to try that? No. C'è una accademia. Hi, hello to everyone. I'm Andrea Giachetti. I'm working in a structural biological field, and I'm here to present you a service to identify physiological and adventist metal binding site in three-dimensional structure protein based on deep learning classifier. Here I'm presenting the service because the deep learning classifier was published in 2022 in the previous. And here I have to explain how it works. So in the protein data bank that collect all the structure of the 3D structure of the all proteins solved with X-ray and MR cryo-EM techniques, basically more than 30 of protein contains ion metals. It is estimated that at least 40% of the enzyme require ion metals to perform their biological function, and the metal is essential for the life. Another thing is that metal ions and metalloproteins are influenced by the local protein structure environment, and position of the metal binding site is an active site and is very important for their activity and in the physiological rule. So why so many metals are present in the PDB data bank? Because, and in principle, the protein, you don't need so many. Because different between physiologically relevant metal binding site and artifact do experimental condition. So some of these metal in protein are present due to experimental condition, but they are not physiological. If you take the protein in the physiological in their physiological in the live when they are not present. Here there is two examples. There are these two structures that come from the PDB data bank, protein data bank. To the right, to the left, you will find a zinc that is physiological, that is needed for the protein. If this zinc is are not present, probably the organism die. The other is something that comes from the laboratory. So we have implemented a deep learning approach to build a classifier able to distinguish between the physiological and adventist zinc binding site in the protein structure. To do that, we have collected from our database that is called MetalBDB hosted in Florence, thousands of proteins that contain zinc. And we have manually annotated, and we have checked how if they bind or not, the zinc is physiological or adventist. This was done manually for any of that. It was a huge work. In order to training our model, we have listed 20 net features. The first 20 are and I will show you all these features in the next slide. The first is the multi-sequence alignment. What we have, a protein are created by the sequence of amino acid. So we take this sequence and we align on the database of the whole protein. And after that, what we find, the protein, they have at least 30% of, they're equal at least for 30% of the protein. At this point, we take, have you seen, we have a column with 20 amino acids. We put in this column the distribution, the number of distribution of amino acid that we have found when we align the protein. So basically, if at some point we found only a glycine, all the structure aligned only by a glycine, we found 1 in the glycine and 0 to the other. These also, another important things, the multi-sequence alignment are used to AlphaFold. It is the input of AlphaFold, Google AlphaFold, in order to they use to create the 3D structure. This is the only input. But in our case, we are more lucky. We are more lucky because we have the 3D structure. AlphaFold don't have the 3D structure. They calculate the 3D structure. So we can collect other features, important features. So we collect the amino acid that this is a spatial feature. We collect the amino acid nearby the zinc, and we create 2 classes. For the amino acids that are nearby 3 Armstrong, we perform one class, and the amino acids that are nearby, that have an aviatus nearby 5 Armstrong, we collect another class. And this is information about the environment that the zinc have in the protein. Another important thing of one structured protein is the accessible surface. So we collect for any amino acid the accessible surface. It is important because normally the physiological, in principle, they are not exposed to the surface. Another feature is the secondary structure. When you build a protein is amino acid chain created by many chains. How these chains are presented in the space, they can they can be arranged in the space in alpha helix, or they arrange in beta sheet, or they arrange in beta turn. And this is important for physiological features, because normally the physiological part of the protein maintain this structure. At this point, we have performed the this is the input that you can see here of our system. In the beginning, we perform a 1D convolutional. After that, they perform a recurrent neural network, and in the end, they create a neural network fully connected, where they output only two values, 0. Physiologic or not physiologic. We are trained, and you can see here the average of accuracy is about 90%, and here and there you can see the confusion matrix. We have we have performed a web service in order to host this machine, this service, and we have created the host using React and Spring, And we run in the backend Promotive and Access, and after that, in Promotive and Access are the software used for the accessibility of the solvent and the secondary structure. And we are running we are under developer the multi-sequence alignment. The problem of multi-sequence alignment that the resource needed to calculate this is very huge. We use MMSec, that is faster, but they use many gigabytes of RAM, so we cannot run this on our server. So in order to perform this service, I think we have to submit in cloud or in local PBS cluster. At this point, we need to create also login page because we cannot use this free. Now I have one. I want to show you. I hosted this in my sorry. Wait a second, I have to put the glass. Okay. I don't know what's happening here. Okay, this is the service hosted on my computer. Here you can choose a file. I will input a PDB. And the software automatically calculates all this future. They calculate the amino acids that are needed by the zinc ion in JavaScript as a JavaScript, and they calculate in backend. They run an Access and the other software in using Spring. Here I will load the MSA calculated because it's not implemented. Here I have to choose which zinc, because this protein contains many zinc ion. You can see here they calculate the amino acid that are needed by the zinc, and here I submit the calculation. Now you can see here that they run in the backend, but they on my computer, normally we have developed this classifier using PyTorch, and we have used GPU, and now it's not so fast using my CPU. So I will show you directly the output. They take about a few minutes, and I will come back to the last of the presentation, and basically, here you can see, this is the output, and you can see that this protein is physiological. So any biologist that can, when they want to see if the zinc is physiological or not, they can use this software to check it. Okay, thank you for everyone.
Questions, but for me, I can find you later.
Yes.
At the social dinner, I hope.
Yes.
Perfect.
Thank you.
Thank you. we have a long list of speakers. The list is a little bit different. I put the end of the slide before I want to have some fun. I found this cartoon. Behind this sketch, there's something true. For example, like how much of what it says is made up. We deal with this trustworthiness, explainability, for example, or the security risk. So we know that this kind of models expose us to security risk. And so we would not put our data, for example, in ChatGPT, our personal data. Anyway, we are not going to talk about ChatGPT or large language model, but I use this as an example to share a message that is the reason that I try to set up these sessions. You can see this is a landscape of large language models. As you can see the gray one are the open source, are just a few. If we look at the European one, so models that are trained in Europe are even less. And the company, there is a legend, maybe it's small, but you can see there is Google, OpenAI, Meta, so all private and American companies. There is a few exceptions, like this Bloom that is here, from which they also derived this Bloom Zeta, that is an open source model that has been trained in Europe, in France, for example. It's not the only one. There is other countries that develop their models for their language. But here is the message. This is the list of the authors of the Bloom paper. So to train this model, more than 1,000 people work, and 250 institutions have been involved. And so my message for the session is that we have to join the forces if we want to say something in this field. And we don't want to rely only on Google, Amazon, and Facebook. And so without further delay, I want to give the talk to Gabriel González Castagné. I hope I pronounced it well, that will introduce the AI on demand platform. We will sit down, then Joost, that will give some more technical details on the API that we are building. And then we will see another initiative that is the AI for IOSC. We have presentation from Carmen Marcos, Alvaros, no, probably Ignacio, Erida, Lisana Berberi, and finally Gergely will present Imagine, another platform built on top of the AI for IOSC one, or the deep one. So let's not waste our time and go to the first speaker. Please, Gabriel.
It's in presentation. I think that is not in presentation mode. Okay, so thanks very much, Marco. So my pleasure to be here. I'm going to introduce a bit what is the AI on demand, what is this project that we have been working during the last year, and a bit of the concepts, and then I will hand over my colleague Jos that will give you a bit of more insights on what we are doing, more or less. So just to start, the AI on demand is a concept that we have been building since quite a bit of time. So AI4U was the seed project, was the initial project, and it was 20 million euros project funded 2018. I will mention that later. And the main idea is to construct a platform for the AI community that spin around a set of topics that were open call for supporting SMEs, different stakeholders like researchers, having AI catalog, having a research and innovation agenda, etc. But the main point was to enable a transfer of technology from mainly researchers to industry, SMEs, etc. So that project was running during a bit of time. We had quite a learning experience, and then we decided to continue mainly this project. So this is more or less the roadmap that we have there. So we started in 2018, mainly, in my case, I was leading the ecosystem development activities, so pretty challenging because right now there is a lot of fragmentation in the AI community, so trying to unite them under the same umbrella was challenging, but then we continue with this project AI for Europe, and it's going to be extended. It's mainly the supporter of the concept that is called the AI on demand, that is mainly an aggregation of multiple projects. This is an example on how the things are evolving towards different services. So we have more or less 44 projects engaging in different directions, so engaging in terms of detection of bias in data, in terms of robotics, terms of data, management of data as well. So I guess that the main idea is to support these services in different aspects that I will explain in the next slides. What is the concept? I was discussing with Josh before that I like to use this analogy. That is, I played basketball for many years. I think that, I don't know, 20 years maybe. By the time, I guess that you always dream to be either Michael Jordan or Larry Bird, depending on long time ago, depending on how well you played or how good shooter you were. So I guess that there is no way in which both of them could win at the same time. So it was tricky, no? But they always play under the same court, rules, court, etc. So the concept of the AI on demand is not to try to force the AI community to play together. It's mainly to build that court that facilitates to them to develop new services, that facilitates to them to share them, and that we can give as much AI-powered tools as we can for them so they can advance faster. So that's mainly the idea behind. All of that, of course, with the trustworthy AI behind and set of things, but mainly the concept is that. So this is a very basic concept. So at the end of the day, what is happening is that there is a lot of fragmentation. There are plenty of platforms, different directions. The people deposit there the assets, the people deposit there the models, but it's very difficult for them to navigate this landscape in different directions. So they deposit a model, for example, in a manufacturing project or in a manufacturing platform, robotics, AI, but there is no simple way in which they can construct all together. So for avoiding this mainly, one of the things that we are doing is to create this framework that can act as a federated environment or as a distributed environment, supported by mainly 3 blocks that are the resources, the API, and the services. So in terms of resources, what we are doing is we are constructing this new iteration of the platform. So the AI4U project was there before with catalogs, etc. So everything will continue being there, and we will migrate to this new system. But in this new system, we will facilitate to the developers to construct the services by giving to them the tools through different types of nodes that they will communicate against each other. So you can see here in the slide, for example, that we name them root nodes or leaf nodes. So mainly the only difference is that the leaf nodes connect against the root nodes, so there is no need to have all the information behind. But it's mainly to have this sharing modality of that all the research that is being produced is being circulated and is accessible to the developers of services. This is quite much more technical. I wanted to add this, even if probably you cannot see it properly in those 2 squares, because one of the things that we are also targeting is to be able to aggregate heterogeneous resources in such a way that we are able to abstract them for the developers of services, and they can have this accessible to make the deployments of the AI tools, assets, etc. So I'm not going to enter into much more detail. About the API, Josh will give you a lot of more details about this, just to mention that we are building these REST API models that can be used can be integrated in any service in different directions, just to retrieve the information, to push the information. So mainly just as an abstraction, if we want to see this in that direction. So any AI developer should be able to access from different platforms, from different data or AI assets, models, etc., from different platforms in an easy way. That would be fantastic. So that's what we are building here. You will have more details from Josh. Behind that, we have pretty well-structured set of metadata, so we are covering a lot of different concepts that can be useful for the AI community, starting from datasets, models, algorithms, but also some components that might be useful from the perspective of the community, like, for example, news, events, etc. Because we, after a few years working in different directions, we detected that there is that need of sharing that set of information that is circulated in a seamless way. So we are trying to cover as many topics as we can, also without reinventing the wheel, but that is more or less what this, without entering into detail, what this slide shows, that we are trying to cover as many needs as we can from AI developers mainly. What are the services? This is a bit tricky. I would say we already have a few services that are catalogs focusing on what we define research bundles, that are those ready-to-consume information from the perspective of AI developers. So could be tutorials blended with documentation, code, etc. That's one of the things. We are having another tool that is mainly based in Acumos that is also to construct workflows. So it takes the information from the underneath layer that we have, and it enables the construction of different containers and those workflows to be downloaded or to be run in a cloud system. And then we have another 6 projects that are constructing services in different directions. You have the link in the right-hand side that are for Earth observation, planning, AI on Edge, DIHs, energy market segment, and matchmaking. Those are mainly the ones that will be released from now until the Q4 of this year, until the end of the year. And then we are working in a set of new, that blue box, we are working in a set of new services that we are developing in this new iteration. However, they are under design, so they are work in progress. In some directions, we have mainly 4 that are core: practitioners portal, for reproducibility, that is very important also in the research community, an information tool and an innovation portal. And then some contributions that are coming from other networks and other parts of the ecosystem. So in the case of the reproducibility information tool and innovation portal, is a work in progress. So we will make this happen in the release, so we will have the release pretty soon. However, I don't even know, and I'm coordinating the project, what the teams are doing. So I know what are the definition of the user stories, requirements, etc., but they are working on this, so it's work in progress. Then we have Human AI Net, another network on human-centric AI, working in another service that they call the Virtual Lab, that is for supporting researchers to address human-centric topics with respect to the different services, tools, and model, work in progress. Matchmaking, also work under Taylor, work in progress. Eurocore, coming from the robotics community, work in progress. And for sure, we are revamping the whole concept of the portal, that is work in progress. So we started 1 year ago, and we are trying to push as much as we can for this new, mainly this new release, that we will be Q3, we will have it for sure up and running, more or less. But the thing is that we want to tackle some of the key points with respect to the AI community within the platform. How we are structuring and integrating the new services. So does this mean that in our project we are building all the services? No. As I mentioned, the main idea, we have already 44 projects engaging in different directions. There are another 22 coming. It will be another call in Digital Europe that is also for supporting different stakeholders that we will be participating as well. And I guess that is something that is growing pretty and is getting a lot of support coming from the European Commission. So mainly what we are doing is we are opening this forum so to support the creation of new services, so we can understand what are the requirements and what are the user journeys or the user stories behind new services that are going to be developed and deposited or make accessible through the platform. And in that way, the technical team can support them as best as we can. And the code is available as well for developers that they want to start touching a bit how this is working. And well, up to here, I think that this is the consortium, so we are 25 partners from different places of Europe and that are pretty well committed. And I guess that my colleague Josh from Eindhoven will explain later. EGI is also part, Marco. my pleasure to work with you, and this is it. So thanks very much. And Josh, Marco, questions?
Maybe the time for one question. There is one question from the audience. In the meantime, that we switch the speaker. So otherwise, Jos is going to give some more technical details on the API that we are building, trying to connect the services.
Do you also have the?
That's the first one that I opened before.
Is that a link here for the?
Okay.
If I want to switch to presentation.
There. Oh my God, maybe. Got it.
I
have a problem with mine. Let's connect.
It's working right.
Is it not charged? Let's talk with the guy. So yes, okay. Would ask you go out on.
Yeah, sounds good. Okay, thanks a lot. My name is Jos van der Velde. I'm a software engineer at the OpenML team of Eindhoven University, and I'm also working at the AIOD project. So I want to give a little bit more technical detail about what we're doing here. So I want to give a short overview of the components that are in the AIOD system, and I want to especially focus if you have a service, AI service with which you want to share some metadata, for instance, or which you want to make use of the components of our AIOD ecosystem, how you can do that. So again, as Gabriel already explained, the goal is to provide developers with AI assets such as dataset models and hardware infrastructures such as compute clusters. And the main part, a central part is the metadata catalog in which all of that data will be. So if there's a data set, for instance, you can find it using the metadata catalog and using the REST interface. That is to say that the metadata will be in there, but the data itself will not be in there. But we want to fill this, of course. So we do have a lot of connectors. For now, we have Hugging Face, Zenodo, OpenML. So those are connectors to existing data platforms. If there's a data set in Hugging Face, for instance, it will also be in our AIOD core catalog. So if you want to know what data set exists, the really nice thing is with AIOD, you can just query the AIOD API instead of going to Hugging Face directly and OpenML directly. And what is really nice about that, I can say as a research engineer, it's quite irritating if you are used to Hugging Face, for instance, and you have to switch to another platform. It's quite irritating that it's working in a completely different way. And we want to smoothen that out so you get the data in exactly the same format and the metadata as well. And one of the things which is also really nice is that we have our own schema. So for instance, data set, we know how to describe it, which fields we want to describe, but you might also be already using a different schema, such as schema.org or the DCAT AP. Those are quite normal ways to use to describe data sets. And we also provide functionality to transform it to that. So I want to give a really quick demonstration of that. This is readable, I hope. All right. So this is the API. So this is not meant to look beautiful. This is just developers' documentation. This is Swagger documentation, and here you see all the endpoints we have in the API right now. So for instance, you see case studies here, data sets, educational resources, well, and lots more. Each of them you can post new information there, or you can get them. I want to show you the list of data sets, because data sets are maybe the most important resource for AI resources. Data is the new code, as some people say sometimes. So let's try it out. Let's try to get all the data sets that are on the platform. If we do that, we get results back. So here we've got an OpenML. OpenML is another platform data set with the description and everything in there. There will also be a couple of Hugging Face data sets. So you get all the data sets back in one go. And as I said, sometimes you might not be really happy with the AOD format because you're already used to using DCAT AP. So let's try to get them back as DCAT AP instances. And here we are. Now it's in this, to me, a little bit weird DCAT AP format. So let's get back to the presentation. So that was just a quick overview of how you can use the metadata catalog. That is what services will do. So there can be a lot of services. What they can do is they can make use of our complete ecosystem. They can make use of all the metadata. So Gabriel already explained a couple of them. They can also, of course, make use of the data storage and the compute cluster. So normally, the data storage, if we have a data set and the data set is in Hugging Face, the data set itself will remain in Hugging Face. The only thing we will store is a URL pointing to that Hugging Face site in this case. And to finish it up a little bit, this ecosystem is that we need authentication, authorization, with interfaces with all of the components, of course. So now I want to show you quickly what things you might want to do if you have a service and you might want to be part of this ecosystem. So firstly, you might have some assets. You might have a model, for instance, you want to share with other people, or you have a data set you want to share with other people. If this is the case, we already have a metadata AIOD core metadata catalog. You can just make a connector. That connector translates from your own representation of the data set or the model to our AIOD representation, and you just post updates to our metadata catalog to keep it synchronized. So what we have is we have code which you can use to create your own connector. Same goes for the metadata catalog, because for instance, you might have a data type that's not yet part of our catalog. So model is, datasets is, but maybe you have something different. You might want to discuss it with us. We might want to add it to our core metadata catalog, but maybe it's quite specific. It's really specific for your service. For instance, you want to keep some data about ships or vehicles or whatever. Those are quite specific, so it's not really reasonable to put them into the core metadata catalog. So if that's the case, you can easily spin up your own metadata catalog and put those instances there. So we provide code for you to do that. The only thing you need to do is you have to design the metadata, decide which fields should be on there, and implement it in our metadata catalog code, which is in Python with SQL Alchemy, or whoever's interested. And in the end, of course, you need to create a connector to fill your metadata catalog. So this is how you can share your metadata with us. How can you also use it? Well, if you have an AI service, you probably want to know what dataset exists, so you can, of course, use that. You might want to be interested in compute resources or storage resources. So compute resources can be high-performance clusters, for instance. All the metadata, so which exist, will be part of our API, and also you should be able to interface with them. Authentication, we've got the authentication solution from EGI check-in it's called, which is supports single sign-on. So you can just log in with the username password, but also with your Google account or even the Poznan University of Technology account if you want, which makes it a lot easier for users to use, of course. And for authorization, you can also make use of the EGI check-in. So authorization for the permissions. You might want to host your own EGI check-in. That's of course possible, but we encourage everybody to use the same check-in instance if you want to be part of the platform. So in summary, there are multiple places where you can interact with the AIOD ecosystem, and as a service, the most easy thing is to just make use of the other resources, but you might also want to put your own metadata into the system. Oh, thanks for this attendance. I've got a link here as well. So there's also already a link, I think you shared this as well, with our codes, which is still work in progress, but the basics are there already. Thanks a lot.
Thank you, Jos. Yeah, the code is an open source code, obviously, so the contribution are welcome. Okay, there is a question.
So, okay, my name is Ladislav Luchy. I am wondering what kind of AI this platform you are supporting. If you are also supporting federated, distributed, splitted, or this kind of, and the first question and second question, if you can tell me about the 3 important use cases from your project, from which you are available data.
I think Gabriel is better to answer this question.
So, sorry, you asked about the use cases, and the first one is, oh yeah, okay, yeah. We are, well, actually this is a very good question, because the first question is, one of the things that we are doing is we are exploring, so we have one work package in the project dedicated to the computing resources. So one of the things that we are exploring is how to map in a transparent way that is tricky, the services that will be developed, because at the end, if you are building a workflow, it's a workflow, it doesn't matter. So what you want to do is to do some either federated learning or split learning, for example, in the case that you want to configure in the adequate way for privacy, security, or for any other reasons you want to go to an environment like that. So one of the things that we are doing in that work package, that we have pretty strong partners there, so Barcelona Supercomputing Center, EGI as well, and also Telenor. We are working in exploring that kind of automation or that kind of resource scheduling and configuration that will be able to support it in that direction. So we are right now cooperating with, through Barcelona Supercomputing Center, with one of the projects that is mainly exploring split learning. And in the case of Telenor, federated learning with real edge deployments through the telecommunication company. So that's one of the cases. The other is about the use cases. So the second question was about the use case. So, well, we inherited from AI4U, we inherited, I think that it was 9 pilots on different sectors. That it was AI for public sector, agriculture, I think that it was manufacturing as well. However, this project at the end of the day is a CSA, so we act as an aggregator of the other 44 projects, so not only the 44 projects that are new, but also quite a few others. So we are getting right now the inputs from the 6 networks of excellence that they have 16 million in total for open calls, more than 160 funded SMEs and innovators that they are depositing the information within the platform. So we are having right now around, let's say, 300 cases of data, assets, etc., in different directions, and also in different market segments. So AI for Edge, manufacturing, Earth observation, energy. So that's already there, or it will be in the little bit of time when this open call finished. And also we are getting from other calls, like for example ICT 38 on AI for manufacturing and digital twins, ICT 40, and that is robotics calls. So we are getting all of those. So from our direct project, we don't have the use cases because somehow it was an overhead and we didn't need it. So through the CSA, we are hooking all of these and bringing them into the platform. So that's how we are working. So we have quite a few, I would say. Does this answer, I think? I don't know. Any other question?
Okay, maybe we see at the end if there is time for other discussions and questions.
If not, I will take the question.
Or maybe, if you want to, we can continue with, in the meantime, I switch to the remote speaker.
That's perfect.
I need to do some settings, so if there is another questions, maybe we have time. Yes, Valentin.
Valentin Kozlov, KIT. How would you estimate your technology readiness level, and what is your timeline?
The technology, sorry, I couldn't...
TRL, technology readiness level.
The TRL, okay. Well, that's a very good question. I guess that well, the TRL, it depends. We decided to don't go through something that is super large in one direction, so we decided to focus with a high TRL in, for example, the API is a TRL that I would say is we are targeting to have a pretty high TRL. However, we have to think that, for example, most of the main target of the AI on demand or AI for Europe right now is researchers. So the target that we are keeping for this contribution of these services is a medium TRL. So TRL, I would say 4 or 5 maybe, for the contributions. It doesn't mean that the platform won't be a high TRL. The platform needs to be a high TRL to support, and the components will be a high TRL. So AGI check-in is a pretty mature component. The API is following very good and strict engineering process to reach a high TRL. However, right now the contributions are targeting the research community. However, in this other call that I mentioned, that is the Digital Europe one, the target is SMEs and public administration. So the TRL will be different. So we will be implemented in the next phase these pipes to mainly target those communities who are very high TRL. But right now, in the implementation of services, I would say that everything that is a good seed in research is valid. The underlying technology is pretty high TRL, I would say. Okay. Thank you. Marco? Don't know. Another question? I can... No? Okay. Thank you.
So the next speaker is Álvaro López Garcia. He will present remotely. Okay, he's already sharing the screen, empowering EU scientists with AI service and tool. Álvaro, can you try to speak? No. Yes, yes. Just a moment, Álvaro. I hope you can hear us. We are running out of battery.
Hello?
Hi, Alvaro. Can you try to speak?
Hello?
Okay, we can hear you.
Okay, perfect. So I will start sharing again. Okay, I hope you can see my screen now. So I will start with my presentation that has the catchy title of Empowering AI Scientists with AI Services and Tools, and I will try to explain you how we are dealing with this. So first of all, some facts about our project in a nutshell. Our project is called AI for EOS, Artificial Intelligence for the European Open Science Cloud. It is an evolution of the deep hybrid data cloud platform that we delivered in 2020. We started in September 2022, and we will run for 36 months. We are 7 academic partners, 2 small enterprises, and 1 non-profit scattered all across Europe. The main goal of our project is to provide the EOS with a set of services providing advanced features for distributed, federated, composite learning, including metadata provenance for the models, MLOps pipelines, event-driven data processing, and the final provision of artificial intelligence, machine learning, or deep learning services. These are our objectives. I won't enter into too many details about all of them, but just to underline that our idea is to provide an AI platform for the European Open Science Cloud researchers, with the final goal of fostering, through the usage of this platform, an AI exchange and community of practice in the EOS, trying to transform the way scientists are currently developing AI applications in the EOS ecosystem, providing them with a feature-rich set of tools and a comprehensive platform for the whole development lifecycle. This is not new, as I told you. This is a long journey that started in 2017 with the Deep Hybrid Data Cloud, in which we set the basis for a platform layer that allow it to consume resources from distributed pan-European infrastructures, both cloud and HPC resources, with transparent access to accelerators, namely GPUs. With this project, we delivered 2 platform releases, ending in 2020. So in 2020, our services were on a high TRL, I would say TRL 8-9, and we were so lucky that these were included in the EGIA's project as AI services for the EOS compute, where we gain a bit of traction from several use cases, for example, from the GRC from the European Commission, or INRAE for the emphasis phenotyping facility. In the meanwhile, we also engaged through the EOS Digital Innovation Hub with several industrial partners. And with all of this, we gathered a lot of feedback, and we decided to send a new proposal to further develop the AI, the deep platform, what we call AI for EOS. That is what we are talking right now. In parallel, we also obtained a proposal for providing a customized platform for the Imagine project that Gergely will explain later this afternoon. And this is where we are right now. We are in the cluster group of projects from the that are called Infra EOS, where we are right now providing AI services for a different set of projects. Not only our use cases that I will briefly describe afterwards, but we have also engaged with the FAIR East project, providing AI services for Earth observation and environmental monitoring, EOS Cancer, RACE, Blue Cloud, or FAIR Impact, just to name some of them. So this is our very high-level architecture. If you want to go into more technical or gory details, I provide you with 2 links with the detailed C4 architecture of our project, that it is completely open and that you can view and interact with, both in the structurized workspace or through the static diagrams that are generated when we update the architecture. So basically, our architecture is what it is depicted on the left-hand side. We have a scientist that aims to develop a model. He or she can go to our dashboard that interacts to the platform through a dedicated API, where we provide different functionality. On the one hand, we provide AI as a service component based on serverless computing and the Oscar service that is developed by our colleagues of UPB, exploiting Kubernetes clusters to provide massive scalability for inference of pre-trained models. Then we are deploying a service mesh for the whole management of the rest of the platform. This is the talk that will be presented afterwards by my colleague Carmen, where we are leveraging a set of tools from HashiCorp to build a workload management system that we use to perform the trainings of the machine learning applications or artificial intelligence modules. On top of that, we are building additional functionality as a federated learning, exploiting Flower, or interactive development environments where users can develop their applications directly on Scratch in a collaborative environment like Google Colab, for example. All of this is managed under the hood through the infrastructure manager and the Indigo Data Cloud that provides the resources transparently for our platform, and we provide connectors and integration with the rest of the EOS services, them being the most important, the AAI, but not only, we're also integrating with the storage services or additional repositories. As I told you, we come from the deep HTC realm, and we are transforming it into the AI for EOS and AIOS realm. In the deep project, we delivered two different platforms, and the platform and software was tightly integrated, so it was sometimes difficult to differentiate between the two of two. So in AI for EOS, we have taken the decision to decouple the platform from the stack. So we are, on the one hand, deploying the AI for EOS platform, which is a platform powered by the AI4OS stack, and the software stack, which is AI4OS, which are all the components that we are developing and integrating in order to provide a platform. So, for example, we can customize a given platform for our needs, like we are doing in the Imagine project, or even for additional projects easily. A bit of our use cases. I'm not going into too many details because these are internal use cases for the project, but we are now incorporating more of them. We have one use case on agrometeorology where we are exploiting satellite imagery, insight measurements, and weather forecasts to provide more added value products for farmers. Here we are exploiting the composite AI pipelines that I have mentioned before. We also have an integrated plant protection, where our idea is to provide a deep learning-based model for the recognition of plant diseases together with weather forecasts and climate sources. And then we have the automated thermography, that this is the use case that we are using to drive our developments on federated learning, where we are providing a platform for the federated training of the models using drone image cameras to recognize heat leaks in the different components of the building. This is the feature-wise timeline of the features that are being incorporated in the platform. As I told you, we started in 2022. We took some time to migrate from legacy components and adapting the usual tools to the new components. Now in 2023, we are delivering a federated learning capable platform integrated with Flower. We have provided you with we are providing users with enhanced interactive development environments, updated data science templates and repositories for ease of use, AI as a service following a serverless compute model providing synchronous and asynchronous inferences, federated multi-site deployments as will be shown afterwards by Carmen, drift detection services to be incorporated into MLOps pipelines, composite AI tools. And in 2024, we are focusing on providing other distributed paradigms like gossip learning or split learning, enhancing the experiment-centric dashboard with a provenance of machine learning models, providing a complete automated provisioning of resources on consolidated composite AI tools and the pipelines towards our final goal of having the last release of the platform in 2025. So starting with the migration from legacy components, we move from all the components, namely Apache Mesos to HashiCorp Nomad plus another set of tools to provide transparent, federated, and multi-site platform deployments. We are improving the accounting of the resources together with the security and the monitoring. And for all of this, we are also developing a tailor-made API that we call AI for Puppy, a link with a new dashboard and client tools, decoupling the execution on the underlying platform from the API. We are also adding sidecar tasks in the platform to allow for other additional features like decoupling the storage access to the platform from the platform, providing additional monitoring and things like that. All of this is integrated with the EDI check-in, both at the dashboard and the API level, or with any other OpenID capable provider. Regarding the enhanced interactive environments, starting from an entry in our catalog, what is what you see, or our hub, what is what you see on the left-hand side of the picture, we can perform a deployment with two different flavors. We can deploy a platform with a module, with Jupyter Lab or with Visual Studio Code. All of this exploiting resources coming, for example, from the EGI Federated Cloud in a transparent way and all through the dashboard that is developing the platform. Also from the dashboard, we are working on integrated federated learning framework in order to provide scientists with an easy way to create federated learning experiments, being possible to participate both from the platform, I mean, in cases where data can be available at the different sites in the platform, or even externally from the platform, for example, a site that is not part of AI for use, but want to participate in a federated learning experiment. They have agreed with a scientist that they want to do so. We have preliminary results that are being published here and there. We are also providing a serverless-based artificial intelligence component as a service, AI as a service, exploiting Oscar, where we provide a serverless event-driven execution, both for asynchronous mode, where files are uploaded to an storage, they trigger the inference or even composite AI pipelines, or synchronous modes, finally providing the resource to the users. You can test it in the link that is at the bottom. We are also doing extensive work on MLOps pipelines, all that will be done by Lisana and Valentin afterwards. About drift detection, we are working on monitoring of models in production. We think that monitoring models in production is not enough in order to check that the model is behaving correctly. As you know, a model learns from data. Data can be, or normally is not stationary. A concept that has been learned by a model may change. A concept may change over time. So the idea is that we are building the data concept detection libraries that we, in the end, will transform into services. You can access here the Floros library, which is the state-of-the-art library implementing the largest number of drift detection methods in the state-of-the-art. And we are working in integrating this with Oscar in order to provide online services and serverless-based drift detection for batch whenever possible. You have an example on the right-hand side with live data from underwater video. We are working in composite. Our colleagues at UPB are working in composite AI models, where we are working on ways to create a composite AI pipeline, for example, providing an ensemble of models to provide more accurate predictions, or incorporating these drift detection tools with the final result. In order to implement all of this, we are facing several challenges, but we are trying to mitigate all of them. The most compelling challenge when we deal with the distributed resources is the integration from disparate platforms, services, and clusters. We are trying to exploit automation whenever possible, providing infrastructure as code tools and a thin platform layer that can be deployed without too much effort and intervention from the providers. Another important point is data access for privacy preserving tools, for privacy related data sets. Here we're working with the most obvious approach, which is federated learning, but we are also working on additional, not national, sorry, there is a mistake here, additional measures like homomorphic encryption for federated learning together with federated learning, or privacy tools based on anonymity, diversity, closeness, and whatnot. Also, we are working on metadata, as it has been presented by the previous speaker. Metadata is a must, so we're working on it and trying to engage with the RDA FAIR metadata, FAIR for machine learning working group. Remote access to data, that is a cumbersome problem, so we're working exploiting the Nomad capabilities to provide sidecar containers, providing tailored access to the different storage services. The access to accelerator is always a challenge, but we are providing transparent access for resources. And one point that I have to mention here, trying to be not to be the elephant in the room, but maybe I am, we tried not to jump into the AI bandwagon, because now there is a lot of AI-related developments and we are living a hype. So we are trying to focus on scientists and on our ecosystem and on fulfilling the requirements that we get from the different use cases, both internal and external to the project that we are supporting. Our key impacts, the main impact is the increased number of services in the exchange related with AI, both generic, like as the AI for EOS platform, or community specific, like Imagine, see, for example, Gregory talked this afternoon, trying to transform the way AI models are developed in the EOS. Also providing additional tools for the improvement of robustness of AI systems. We think that MLOps is fundamental. One of the most important topics is drift detection. Also, the provenance of models towards reproducibility is a key aspect, and the verification of all the assets. As outcomes, we are providing actually an AI platform for the EOS, the software stack that can be used to build additional platforms, and obviously a lot of best practices and documents for the AI community of practicing the use. Finally, a word on collaboration. As I told you, we are right now starting the collaboration with the other InfraEOS projects, providing AI tools whenever they need it in their virtual research environments, for example. This is what we are starting to do with FAIRIS, RACE, and EOS for Cancer and Bluecout. We are collaborating with FAIR Impact on the verification of all the AI assets, but we have also collaborations outside the EOS realm. One, the most important for us, is Imagine, where we are working on providing an AI-based imaging data services for aquatic science. Gergely will give you much more details about this. Or the potential collaboration with the AI on-demand development platforms for the automatic inclusion of all of our AI for EOS assets. I have not said that, but everything in our platform is automated, from the development, from the inclusion of models in the platform, the generation of containers and whatnot. So we can exploit this automation link with the API that was shown right before, in order to provide this automated update of our access into the platform. But this is not, we are not ending there. We are open for additional collaboration. So we want you to reach out at that mailing list there, where we can take care of supporting you. Or if you are part of an industry or SME, the collaboration channel that is best for us is through the EOS DIH, and I'm sure that our DIH colleagues, Marcin, will be there, happy to tell you how to collaborate with us. So that's all of that. Thank you for your attention, and I'm open to any questions you may have.
So are you open also the other way around to get models from the AI on demand platform that can be deployed on the AI for IOSC platform?
Yes, this is something we are exploring basically because the only requirement that the models from our platform has is the existence of the DPaaS API. And this is the link between the model and the rest of our platform. But we are working on automating the creation of containers together with the DPaaS API. So yes, this is something that we need to further explore.
So now there is a presentation on, I think, on the bottom layer of the architecture, right? Is Ignacio presenting it? Distributed computing platform on a GI federated cloud. So, is Ignacio presenting? Okay. I have the slide. No.
In the morning.
Nomad. This one.
Yeah, that one.
Sorry. So instead is Carmen that is presenting.
Okay. Yes.
I think this is the bottom layer of the architecture
Yes,
that
yes.
Baru just presented.
Yes, so now I'm going to talk about the distributed computed platform on the IGI Federated Cloud. In particular, now this is like the bottom of the architecture in the i4EOS platform. So first of all, I want to reach out to Viet, Álvaro, Martin, Ignacio, and Ondrek, that most of us are the ones that we have been playing around with this and developing this, people from ISAS and from IFCA. So first of all, when we started the project, we started thinking about, okay, we need a platform that helps managing and distributing the workload across a cluster or infrastructure. We know that a lot of research centers are going to provide their infrastructure. Let's say that you can create some instance in different OpenStack or any other cloud provider of different research centers. We were between Kubernetes and the actual solution that we choose, that it was Consul plus Nomad, that is part of the HashiCorp environment. We know that Kubernetes is one of the most powerful tools for this kind of work. However, we thought that sometimes it can be a bit complex, the management and the ecosystem itself. So we start playing around with both, and in this case, I'm going to try to explain why we thought that Consul plus Nomad was a better fit for our project. So basically, Consul plus Nomad is quite simple compared to Kubernetes. Like we have some experts in some of the research centers, and for the purpose that we want, Consul and Nomad provides like a simple way of manage everything. Consul and Nomad was a native support for multi-data center deployments. That is one of the main approaches that we want to handle and we want to provide. Well, Kubernetes not, still is one of the best approach also, but it has more different ways of approaching, and we thought that it was not the main intention, so still Consul and Nomad was a plus in here. Then Kubernetes, as we all know, was focused on managing a complex microservice architecture, while in this case, we are trying to manage easy and centralized management of the services. We want to centralize the services, however, in distributed environments. So taking all this into account, we finally decided that Consul plus Nomad was a bit better. And let's say something a bit more informal way. We don't want to try to kill the we don't want to kill a fly with a canyon gun, you know, like we don't need that much powerful, because it also has some drawbacks, like the complex management that Kubernetes may lead. So to show you kind of how Consul plus Nomad work together, Consul is the service networking, while Nomad is the workload orchestrator. Consul is the service mesh solution itself is distributed, and it provides the service registry and the discovery mechanism of the service itself. In addition, it's a secure network connectivity with SSL and TLS and provides the service mesh. On top of that, Nomad is going to start working because it's fault tolerant and in fact is the workload orchestrator itself. So we can create also namespace. We can do it distributed in the different data centers that are going to be created in console, and Nomad is going to auto-discover all of them with ease thanks to the HashiCorp stack. Also, in the future, it can be also implemented more solutions of HashiCorp like Terraform or even Vault, and many others that they are still nowadays deploying. Also, we must say that Nomad also it supports GPU devices plus CPUs, and you can run totally natively containers or maybe just the binaries and many other ways of deploying a task. So here in this slide, you can see more or less the console mesh itself. So when we are in console, we have console servers and console clients. The console servers, let's say, are like the brains of our infrastructure, are the ones that have to storage all the data, while the clients are the ones that are working it, let's say somehow. And it's an agent-based architecture. Every client has an agent, and they are the ones that made the service registration. In addition, we can use proxies and third-party proxies, like we are going to see later on, that we are going to use some of the internal ones, but also some additionals like traffic. And it allows multi-data center connection with one federation that is, we are now finishing to develop it and making it solid and properly working. So let's say that we can deploy some machines in the OpenStack of ISAS and another on IFCAS, and we can put all of them into the same cluster in a very easy way. So here we can say this just a screenshot from one of our clusters. We have several data centers. We have two at IFCA. One of them is A4EOS IFCA, that is the primary and the local one, that is the main one, let's say somehow. Then we have another at IFCA, that is Imagine IFCA. But then we have another one that was created in the machines of ISAS, so it's I4EOS. All of the nodes are consistent, and Nomad is not going to notice at all where the compute resources are coming from. So that's a really good advantage of using this combo. And let's repeat that it's really easy compared to many other tools that we have right now to set this up. We can also see the services that this is a bit of a spoiler because you can see that they were registered via Nomad, but Consul is the one that is going to register all the services that are not going to be launched by Consul. Nomad on top is going to launch the services to Consul, and Nomad is going to be the workload orchestrator. So let's keep with this. Nomad is going to run on top of Consul. Once Consul is totally deployed, we go to Nomad. That is going to be the job scheduling. It allows scaling and automatic scaling, resource management, and still we are going to do the environment integration. Here you can see that we have some jobs deployed. The jobs are totally anonymous. Is the user job that the EGI Fed Cloud authentication gave. And you can see that they can be running in different namespaces. This is really useful because, as Alvaro has said, we have some dashboards. So in this cluster, we are not going just to run services of I4EOS and Imagine together. They are going to be different, and the accounting can be based on this. So we can choose and start exploring the ones that are going to be running on I4EOS. And then if we want to do the accounting of maybe like Imagine, that is the other project that we have been talking about, the accounting is going to be on the same platform, same cluster, but totally independent. So that's a really, really positive point of Nomad in here. Here we can also see that we can also, like this is the manager view, but we can also see the topology, how the jobs are allocated in different machines, and like you can see here, we can see the available memory of each machine, how all the workload has been managed and distributed among all our clients. Here also, I'm showing you like all the jobs that are running. How can you also see the clients that are the machines? You can see the data center where it comes from. But let's say that is just for informing purposes. It's not going to make a difference between who launches. Is going to be to one place or one other? Maybe yes, but we are the ones that we are going to configure it. If we don't configure it, all the people that comes together to create this cluster are going to be part of the same stack, and the jobs that are going to be launched on top can be distributed to different data centers if that's what we want. So that's also a plus. And then we can see that we can explore the job itself, all the service and the different tasks that the job has. In this case, we are watching the services that has been registered in Consul, like you can see here. They were launched on Nomad, but all the services were registered in Consul. So in i4EOS, our approach and the state right now of this part of the platform, we have a production cluster and a development cluster. The production cluster is the one that maybe, I don't know, some of you can be using right now with the different dashboard that we have in i4EOS for production, demo, or development, depending on the cluster that you are launching. Then use of namespaces is something that we think that is critical for quotas, accounting, and management of different projects that have to or want to run in the same stack. We are also using traffic as the proxy and load balancer because it's a simple way to approach it. And the federated learning, as Alvaro has said, is one of the main focuses of our platform. We want to be able to do a federated approach and work with federated learning models, and to deal with that, we are using the one federation, using mesh gateways that Consul give us the chance of that. In fact, Martin Selling is the one that is working right now on that, and is a really, really good point to point out. And on top of that, we have the API that we have talked about, that is called A4PAPI, and is the responsible of the authentication via OIDC token. And now we have it with the EGI check-in as a provider, but in the future can be EGI check-in for i4EOS, or maybe can be another check-in that the partners wants to use. And also the AP is the one that manages the job submission. It's not going straight into Nomad, because the Nomad jobs are launched in a .acl type that is HashiCorp configuration file. And we don't want the user to actually launch that. That is the way that Nomad provide us. They don't give us any other way. So we have created this API in order for it to be transparent to the user in order to launch their jobs. And yeah, the development of the dashboard that Ignacio, that is seated right there, has been working on really hard. And probably is the one that you have been using, some of you, if you have been trying to migrate from Deep to i4EOS. So this is all. Thank you for your attention. If there's any question.
Hi, it's just a general comment actually to the rest people. On Friday at 9 o'clock we do a training on how to use the platform to develop AI model and how to use the platform.
Thank you so much.
This presentation is MLHop's platform review case study for AI for IOSC by Lisana Berberi.
Hi everyone. I am Lisana, a researcher at the Karlsruhe Institute of Technology in Germany. Okay, thanks. Today I'm going to present a light talk entitled MLOps Platforms Review this is a case study from one of the projects I'm working on, called AI for EOS, that, yeah, Alvaro already presented and Carmen as well. A short overview on this slide talk. I will shortly introduce what MLOps is, then just give some use case, some of the requirements that comes from our 3 onboarded use cases, and then I will show some results of a landscaping activity we conducted, like a review study to, let's say, investigate review of existing open source MLOps products. And finally, draw some conclusions. So what is actually MLOps? So I guess you already heard this term by Alvaro already. And MLOps, it's a short term that stands from machine learning operations, and is a set of practices to put machine learning models into production. If we can consider this machine learning deployment in like 3 stages, for example, from design, like define a problem that you want to solve using machine learning models, then second phase, like train the model, and at the end, operate it, like use for example, inference. Then MLOps is will do like all these will do like all these steps among these 3 main stages, main processes, automatically. This is like you can see like 3 main components of this set of best practices. Well, to assess the level of the technical capabilities in MLOps environments, we'd like to shortly, let's say, introduce kind of a maturity, let's say MLOps maturity model, like a roadmap, which consists of 4 levels. In how these 4, let's say, main components of MLOps, like people, the model creation, the release, and the application integration itself. So how they are supported basically from level 0 to level 4. So it consists of 5 levels in total, and let's say this roadmap, it's adopted from Microsoft reference page. And from level 0, just brief description, basically model, so to build the model, test and deploy, and everything is done manually, so basically is defined as no MLOps, no operations at all offered. Instead, in let's say the first, the second level, but level 1, as we're starting from 0. In level 1, we can see that this DevOps is fully supported, and so the releases are automated, and there are unit tests in the application code itself, but still there is no centralized option for tracking experiments on the model itself. And the next level is level 2, so-called automated training, and in this at this level, let's say, there is the option of tracking all the experiments of the model development and deployment fully, and also there is still all the level of all the features from the previous levels regarding the DevOps are fully managed. Next level is the automated model deployment, and here there is the auto-release of the model itself, and basically all the other, let's say, category support features are kind of the same with the previous one. And in the last, most mature, let's say, model, so-called fully MLOps, automated, this is like most mature level to reach in order to automate fully all the cycle of machine learning deployment. And well, we can say that from, let's say, after the analysis we run on our use cases that that we have in our project, we can say that they, based on the assessment we did, they are already now in the level 1, and I will show you some of the requirements where we try to map each of those requirements to specific levels. And here is a complete view of all the support features, and for each category, and split it among the levels. Okay, this is what, sorry for that. It's another contribution made from one of our colleague working in our project, and so basically after deploying the model, of course, you want to monitor the performance, so how accurate is still your model, and as Alvaro mentioned, they have developed the tool Frurus that will basically detect data or concept drift. And I can skip maybe the part of AI for us because I wasn't sure that, so the order of the presentations were changed, and I didn't know if I should, let's say something about the project itself, but I guess I can skip this part. And the use cases already were somehow presented by Alvaro. We have, let's say, 3 built-in use cases where we want to, let's say, use as demonstrator, and they will, let's say, test our AI platform and all the component services that we will offer, based, of course, on first considering the requirements that they have, so based on their needs. And we have 3 different ones, so is agrometeorology. They are trying to develop a forecasting system in order to detect like extreme events, for example, for thunderstorm. The second use case is trying to, let's say, protect crops from diseases, plant diseases. And the last one is the automated, is in the automated tomography domain, trying to spot these thermal leakages in different buildings of the city. Okay, and here is, so during the first phase of the project, of course, we did a requirement analysis, and we managed to collect around 44 requirements from the 3 different use cases, and now we are trying to, let's say, map. We, of course, filter which of these, let's say, requirements will be fitted more in the, let's say, MLOps point of view, perspective, and that's why we now are trying to define and to map that each requirement, so these MLOps, let's say, requirements are mapped to which specific level based on the roadmap I show you in the previous slides. So some, of course, there are some similar requirements among the 3 use cases, as you can see here, like it's requirement 2 from use case 1, or requirement 9 from use case 2, or requirement 7 from use case 3, which is they want to organize and they want to track all their training experiments. And other requirements, like they want to detect a model and concept drift, and also they want to continuously monitoring the accuracy of like the performance of their models. And well, the review study that we conducted is, so here it's the results. We have let's say reviewed 16 products, solutions, so I can say as a term, where we try to assess the 9 different, let's say, features that each of these products supports. And in this table, there is, so we marked with one tick that once the product, let's say, supports partially a feature, so maybe only some aspects of a feature is supported, or some functionalities, let's say, not full functionality of that feature. And with double ticks, then that means that this feature is fully supported in the specific product. And I need to say that we limited our search to just filter only open source products. And of course, we didn't start it from scratch. We based, let's say, this kind of exploring these different features also based on the publication report that was published, if I'm not wrong, was last year, November, from AI landscape community. And maybe a better view and the easy view how, so to show at what degree, so each of the product supports all of the specific features that we wanted to review. And there is, so these are the radar charts layout, and on the right side, you have the abbreviation of all these features in case, you, of course, you won't remember. And in this reference number 6 is on my slides. There is also the option and the possibility to view on interactive mode all these results. And this is for the rest of the last 8, so the second 8 of the products we reviewed. And another metric, let's say, we calculated is the score in percentage of the category support levels. So, so how many of these products basically manage to support each of these category features that, we wanted to investigate. As we can see from these column bar charts that say that orchestration feature is one of the most supported feature, and then the others, I would say that are at moderate level, except for the MTV, so model testing validation, the distributed training, and the code management. Okay, we can conclude, so kind of key points on what we learned from our study. So we, of course, we can conclude that products, of course, have varying levels for specific features. And of course, these findings highlight the importance that we need to consider first the requirements and then select, let's say, which MLOps products is most adequate for meeting those requirements from our use cases. And of course, I ordered, sorry, I missed that part, so we ordered the list of products from the GitLab stores. But of course, we have to, let's say, continuously monitor what kind of features each of these products is going and is heavily developing. So not to miss any update. And what are, of course, the benefits of, let's say, offering MLOps is on improving efficiency. Of course, this will enable automation, and this will lead to faster model development, deployment, and iteration. And of course, this will facilitate, it will be more, so machine learning models will be scalable, and of course, through the ML packages option, MLOps will ensure that all these experiments and results can be reproduced. And there is challenge to do that. This will require setting up and managing a complex infrastructure such as storage, computing resources, and orchestration frameworks. So these are the references I mentioned, and thank you for your attention.
Yes, thanks for the very interesting presentation. I had a question. So one aspect of MLOps you didn't really go into. MLOps, a lot of times they also talk about efficient inference. So to make sure that your model uses with less GPU requirements, runs faster, to maybe convert it to Onyx or something like that to make it easily shareable. Is that also a part which is considered, or is it deliberately left out of scope of this MLOps part?
Well, I guess this is on the part of monitoring, right? Mm-hmm. So how accurate is the model itself? So how good is the prediction? And yeah, I mentioned that.
No, what I meant is not, so if you have a model already, you know how good it is, but you want to make it faster. You want to make it run on cheaper hardware. That's also quite an important thing normally if you want to deploy your product.
Well, no, we didn't consider if...
I can just repeat. I would say we leave it up to the user to optimize that, where they will deploy it. And in principle, I'm not against ONNX, but one has to be careful with that. It's to share. If I trained my model in TensorFlow and I want to use it in PyTorch, that's the way. But as our, at least, data scientists in-house say, some layers can be differently named, or you may lose the efficiency which you achieved with the model, or the accuracy which you achieved with the model when you trained in TensorFlow, for example, and you transferred that into PyTorch. You may not reach the same efficiently running model. So again, you may optimize for a different hardware, but again, you as a developer of AI solution should know that. We provide the means, the tools, and the users choose among the tools.
Thank you for the talk. One question is, why did you do that? In a sense that, are you now choosing one of these tools to integrate into your platform? And if so, which is your choice? I didn't get it.
Yeah, sure.
So which is your choice, based on all this data?
So you have my choice here. So we first are trying to track the experiments from the different machine learning models, and we set up an instance, is in production already, is MLflow. And then, of course, there are some limitations for the MLflow. Yeah, as we saw, there are still some features missing, for example, the orchestration itself. And what we would like to do is also try to integrate the MLflow with one of the other MLOps products that I show that basically supports, for example, orchestrating, like running all the tasks in a sequential flow and trying to, let's say, order these tasks in a specific order, like prefect, for example. And this is, so we are, let's say, testing these different products. But you can say that why didn't you pick up some of the other MLOps products, as you saw that almost fulfilled, let's say, and support all the features. But in reality, they are open source products, but these kind of features, these advanced features, let's say, are not with this free and open source version. But you need to get a cloud version, so you need to pay for a license in order to, let's say, take the advantage of having all these features into one single product.
And this MLflow is a hidden element in the AI for EU platform, AI for EOS platform. So should I care about this choice as a user? If you see what I mean.
Maybe we're not yet ready to answer.
Okay. Okay. Thank you.
No, it will be said well. If I can add,
sure.
We still kind of assessing these tools, and maybe we will offer certain solution within the platform, but we also have these templates for creating projects, and I think we foresee that you may choose different MLOps solutions. So if someone wants to go with some cloud solution because they have cloud account and they're ready to pay, the template which generates, the code which you generate from the template may account for that. So it's not like we choose, there is no solution which fits everything.
I don't know if it can be a useful information, but we are participating in other two projects that are AI for public policies and high energy, and both choose MLflow as tool. So maybe if you want to add a couple of points. Thank you very much. So the next presentation is the Deep as a Service API, the community API for the AI in the European Open Science Cloud. And it's a remote presentation from Ignacio Herida.
Yes. Can you hear me?
Yes.
Okay. Great. I will share my screen. Can you see my screen?
Yes.
Okay. So in line with everything that has been presented up until now, another component of the platform is what we call the DPaaS API, so the DPaaS as a Service API. And the idea is that it doesn't matter if you have a tons of services, different services, if the user has to learn how to use each one differently, it will be a chaos, because if you develop an image classification and you have to understand how the software works before using it, it will be useless for most people except the developer. So the idea is to hide the complexity of the code behind a single API. So the idea is most machine learning models either do prediction or training. So it is a simple way of hiding this complexity under these two API methods. So the advantages of it is that we develop this API and the user just has to connect their model, their code, and so on with the API, and the API automatically takes care of exposing the methods, the parameters the method needs. So if you need, for example, for prediction, you need to input an image. So the API will automatically take care of exposing this image parameter to the end user. So in this way, we provide a unified entry point for all AI applications in the AI for EOS catalog, or any other machine learning model that wants to join these principles. So it's easy to integrate your user code with this API. You just have to use some entry points in your Python package and some requirements on how to input parameters, but very simple. And it's easy to integrate with AI systems because we support flat authentication and authorization, and we can deploy it and scale it behind load balancers. So as you can see, there's tons of APIs, and I'm not here to convince you that our API is the best one, but it has been made with AI and machine learning people and users in mind. So it explicitly focuses on them. So by the method it exposes the prediction, training, by the way the methods are implemented. So for example, training is always going to be an asynchronous method, because training takes lots of time. So you cannot wait until you get the response before keep going, because training might take weeks, months, whatever. So every tiny detail of the API is focused on those use cases, machine learning use cases. So this is why we think is a good solution, and well, we hope to keep improving it. So as I mentioned, you have a training endpoint, predict endpoint. So those are the basic two tasks you want to do with a machine learning model, right? And well, you can also debug if something goes wrong, and you can run also the API in batch without going through the UI and so on. So in addition, this is the automated Swagger UI that is generated by the API, but we also have some preliminary work on exposing a nicer interface with GRadio package. So we kind of connect the GRadio specifications with our specifications. So it is a very lightweight layer over our API. And in this way, instead of having this ugly interface with that, we can expose this a bit more friendly, user-friendly interface. So, well, maybe before going on what we envision for the API, I can show you quickly what the API means. So, the API basically, if this is the model, a code, the code of your AI model, you will define different methods. You will have an entry point to this file, pointing to this file, and then you will define different methods. So the training, the training arguments the user will need, the prediction arguments the user will need, and the predict function. So as Valentin said earlier, we are going to have a very in-depth tutorial on how to develop a model with this API, and well, more things, how to retrain models that are already integrated with this API, and so on. And this tutorial, I believe, will be on Friday at 9 a.m. if I'm not wrong. So I encourage you to assist and take and learn more about this. So on the roadmap of this API, we plan a number of things, but well, maybe among those things there are, for example, restricting different methods. So, for example, if your model is not trainable, maybe you want to only expose prediction methods. We want to improve compatibility with the Kaiserve API. We want to improve integration with user models. So, as I said, using this API means defining some entry points in your Python package. And it would be nice to, in addition to that, maybe also support decorators, so which are quite handy. We want to remove maybe explicit parameter definitions, and instead, so this means that right now we have to define an explicit function that is, for example, get predict parameters, and then there define the parameters. So maybe we could avoid that function altogether and rely on Python type hints. So we are exploring this also, and we want to explore to also to improve the task offloading. So right now we have the code is complex because we have to take care of running the trainings in different tasks, isolated, and those tasks have to run asynchronously. So it's working, but it's complex. So we are in the process of migrating to Dask or to Ray, and this will enable us to handle this much better, and it will give us for free integration with a lot of platforms like Kubernetes, Yarn, and so on. We also plan to add more security features, so not only authorization authentication with flag, but also token-based authentication. Again, as we will merge the preliminary UI I showed before with GRadio on the main software, so it will allow to serve everything in the same entry point. We also want to integrate with machine learning provenance systems, and this goes parallel with what Lizana presented in the earlier talk. So in this case, MLflow, and we also, this goes a bit outside the scope of DPAS, but it's kind of related. So instead of having to create manually the model and the requirements and package manually the model requirements, the API, and kind of pack it all together, we are looking into kind of automating this tool as far as possible. So before maybe leaving you, I can show you, because presentations are always a bit dry and a bit boring, but having an interactive view of what the API looks like is always nicer. So this is our dashboard for the AI4EOS project. So here you can see all the modules you have on the marketplace, and if you log in with the EGI, well, with the EGI check-in, you can deploy any of those modules. And for example, here I have deployed an image classifier. So you can go here and I have it deployed with DPass. So this will open this DPass UI. And as you can see, you have here the methods I mentioned. We can train it, or we can predict it, or we can use it to predict. If you want to use it to train, you will need to attend Friday's tutorial, because it takes a bit more time. But if you want to use it for prediction, it's quite easy. You go here, you choose a file. I have a very nice lion here waiting for me, and I can input it, and using the default model, we get some output. So we have a first item is a lion with 99% of probability. So, and this is a bit ugly, but I mean the UI. But again, with G-Radio, we will make this much more appealing to the end user. So going back to the presentation, so if you have any suggestions or new functionality, well, you can check the existing functionality here in the docs, and new suggestions you can open a pull an issue or a pull request in the repository. If you have ideas as machine learning users on how this could be more appealing. Here is the link of the DPass UI. You have links to Flat, and here is a link to the integration module I showed as an example. So how to integrate a model with DPass. And I think we can wrap it up. So any questions?
Thank you. Just a small question. Is there also a plan to also make it possible to use it in different languages, such as R, for instance?
Which one was, for example, which language you said?
Oh, R. I mean, R is used by a lot of statisticians and machine learning people. I like Python as well, but I was just wondering if there were plans.
The point, yes, I guess R is quite used in statistics, and for that purpose, I think it does a very good job. But I'm afraid in machine learning, it's not that widely used. It's true that, for example, TensorFlow has some basic R bindings and functionalities, but it's by far much more basic than the Python integration. So given that this API is particularly focused on machine learning, and most machine learning frameworks are basically either are using Python, or some of them are using Go, but well, let's say that TensorFlow, PyTorch, MXNet, main big ones are using Python. Cafe are using Python. I think the main focus is using Python. But yes, well, if we have time and a big user base that is demanding R, I guess it could be considered, but it's not on the roadmap, let's say.
Well, I maybe I add one thing. I think there is a way to call R functions in Python. So in principle, if you have a model developed in R, you may just kind of call it from our API, the pass API, which is in Python. And if you then want to call like training method, then when you describe this train function, you could probably call this R model through Python. And then you would provide then this interface for your R model. But I never tried it. I remember that in principle, calling R from Python is possible. RPy, I think that's at least one. So, but one may explore that. If you have a use case, we may try.
Just interested. Thanks.
Thank you, Ignacio. We have the last talk of this evening. Gergely is going to present the iMagine AI platform. Gergely is the coordinator of the iMagine project. Thank you, Gergely.
Thank you. I know I'm in between you, the dinner, and the dance, so I try to keep it short. And the technology we use in this project is the exact same that you heard about so far, so that saves me quite some time. I'm trying to do a slightly different kind of talk, to talk about what you can do with AI, and specifically what can be the impact on science and on society with the use of AI for image analysis in aquatic sciences. The word aquatic here means kind of 90% marine sciences, so ocean, sea, and 10% in sweetwater sciences. Okay, so we are primarily focusing on the seas and ocean, and a little bit on lakes, rivers. I'm giving this talk on behalf of many colleagues, including Valentin, who does some of the heavy lifting here, and Alvaro and Ignacio over the Zoom, and Dick Sharp, who is the scientific coordinator of the project. So he's the one with the biological knowledge that I'm lacking of. But I do my best to talk about the science here. Let me just run through the motivation. Why we need artificial intelligence and image processing for aquatic sciences. So we all know that the seas and oceans are very important for life in general. But I want to just pull out three main reasons. So half of the global oxygen production is done by the living organisms in oceans. Second is that it's the largest and most diverse species ecosystem on the planet. And third, it's an amazing source of food for us, which we may enjoy tonight as well. There is a huge data accumulation, and especially in Europe, for marine sciences and the aquatic sciences in general. So the European Commission and member states invested over the past few decades a huge amount of money into observational stations that range very much in nature from underwater surface observation to the ecosystem observation to microscopic image or microscopic observations to floating buoys, satellites, drones, ships, anything that can gather data about the sea. And now we are facing the data deluge, that we have too much data to understand and to extract knowledge. So that's the starting point for us. And we specifically piggyback on the call that came out and requested image analysis for AI, right? So in this call, Imagine is a project that is focusing on image analysis for aquatic sciences. And actually, there is another project running in the same call, which is image analysis with AI for life sciences. The project itself is 36 months long. It started exactly at the same time last September when the AI for IOSC started. So that's another kind of strong liaison for us. They are more a platform developer project, and we are an exploitation project. So we bring the use cases and we do science with the use of the technology that AI for IOSC develops. The project itself has 23 participants, consortium members. You can see the logos at the bottom of the screen. And they basically bring 3 types of expertise. One is cloud providers. We have 4 of them. They operate OpenStack clouds. So that's the one that delivers the GPUs, the storage, and CPUs. We have 5 institutes that are expert on machine learning. So some of them develop and deliver the AI for IOSC platform, or the deep data cloud platform, as we call it in the beginning of the project. And some of them are supporting and hand-holding the users. For example, Valentin is the key person here, who is the interface towards the users and translates the gibberish that the AI community is using, or the IT community is using, to the scientists. And we have 14 scientific institutes that are actually linked to 12 large European international research infrastructures. These 14 institutes are typically a nationally mandated marine institute that in itself is gathering data and is now entering into the stage that they want to add value-added services on top of the data. So a huge potential that this project can bring is well beyond the consortium. Actually, what we do here is that we can show to these 12 research infrastructures on how to best use artificial intelligence for image analysis. And that have, as you will see later, a huge spectrum of opportunities just within agricultural sciences. So let me talk about the use cases that we have in the project. We have 8 of them. We have 5 more major use cases, more major in the sense that the teams, the institutes that are bringing those have some expertise in image analysis and working with AI models and training AI models. And the next 3 on the next slide are less developed in that sense. So the first one is led from Germany, and it's about helping companies or governments clean up trash, or litter, which was typically flooded onto cities or streets, wherever, after a monsoon. So they do a lot of these operational planning activities for governments to understand how many trucks I need to send to an area to clean up the mess, how many people I need to clean up, and also to classify the type of litter that's out there in order to get prepared to the selected collection, but also to maybe penalize the companies whose trash eventually ended up on unnecessary fields. So here we talk about images that are taken by drones that are flying over flooded areas. The second use case and the last use case on this slide are very similar to a lot of sense. They are both about microscopic images that are taken with high throughput imaging tools that are designed by the institutes who are participating here. These are imaging units that are sold with relatively large quantities all over the world and are used in several marine institutes to take a sample, either deep water or just shallow lakes, and then to take loads and loads of images. And obviously, now the question is how to classify the different species, those different small animals that you can see on the picture, and how to do it at scale. The third is linking to this large research infrastructure, EMSO, which has also the ERIC on board, and they have marine observing stations all across European seas. We have 3 of those stations on board, and they operate underwater cameras or photo cameras or video cameras. And the challenge here is to recognize species, not microscopic but macroscopic species, in order to quantify the number of species, the number of fish or number of objects per species, and also to see the diversity of an ecosystem in a certain area. The next use case from Italy and Spain is about satellite images, try to predict how oil spills can move on top of the water on the sea in case of any spill out happens. Again, to advise governments or companies on cleanup operations. Then we have 3 less developed use cases which need way more training and hand-holding. The first one is about acoustic noise pollution in the ocean. And if you may ask how it's possible that noise is through the spectrogram transformation. The question here is that once we have these spectrogram images generated by or from microphones that are deployed underwater, then how can we identify the source of that particular noise? Is it a natural source or is it a human activity? And also try to pinpoint the exact location of the noise using multiple microphones that deployed to a known location, to a known distance from each other. Number 7 is a very interesting one with a couple of cameras deployed on top of hotels next to very touristic areas in Spain on the Palma and other Balearic islands. And they try to recognize 2 types of things on those images. One is density of a certain seaweed, which is a very good indicator of cleanliness or healthiness of a particular beach. So that obviously indicates whether there is a healthy and nice beach for the tourists to come or not. And the second is that there can be occasionally the so-called rip current formation in the sea, which is a special type of wave that, as this graph shows or anim GIF shows, can kind of pull in the swimmers or the beachgoers quite deeply into the open water, which can be dangerous, of course, and can cost human life at the end. So what they want is to recognize that such a wave formation is happening in order to raise some alarm on the beach so the beachgoers don't go into the water. And the last use case is similar to the microscopic one, to the previous one, but this is specifically about certain species that exist in fresh water. Okay. So these are the 8 use cases, and these are the ones we want to advance through the project. And the objectives are on one, we have 5 objectives, but I think what's more important is on the right side with the blue color, the outcomes, what we want to achieve in the project. First is to have an operational platform customized for imaging in marine sciences. We do that with the reuse of the AI for EOS platform and customizing that. The second is that to launch 5 analytical services with the use of virtual access based on the 5 major use cases for those end scientists who also have similar problems and they just want to reuse this train model which is operated as a service. The third outcome would be advancement to the 3 less mature cases, and those less mature cases would become not an operational service, but would become already a huge step forward to those 3 communities and related research infrastructures. Then outcome 4 would be best practices, guidelines, documentations that can help others outside of the consortium on using AI and machine learning for image analysis. And the last would be a kind of portfolio of these things that we can offer for the research infrastructures that are the continued beneficiaries of all of the results. So what we have in terms of the practicalities, we have the 4 cloud providers that are now operating a deep or AI for EOS platform. And on top of that, now we are working with these 8 groups on developing their AI model, training those, evaluating the satisfaction of the users, and then when we reach certain level of satisfaction and accuracy, then we can push those out as production services for external scientists outside of the consortium. So this is the customized view of this platform that was just opened a couple of days ago based on the achievements you heard in the previous talks. We have some reusable models there specifically for object classification, image classification that can be relevant as starting point for the use cases in the project. And what's happening now is that each of these 8 use cases is started engaging with this platform, connecting their data sets, playing around with the models, and advancing their algorithms and validating that with the help of the AI experts who can advise them. We are going to continue this code design, code development for another, 10 months, 12 months, and then we will release the major services for external users, and then we will operate all of this through the virtual access mechanism. If you are interested in the use cases in more detail and the individual user stories that's behind them, please refer to this document which is at the bottom. That's a publicly accessible development roadmap. So we are still in the beginning relatively, but there are already a few lessons that we learned about the difficulties mostly of running and achieving a successful machine learning setup. The first one was about labeling, or even the second one is about that the initial data is not as good or not as usable immediately for training as I guess some of the communities thought. The labeling is not there yet fully. It has to be expanded. There are different labeling tools that are used. The files themselves and the images on the files are sometimes not as clean and clear as would be desired. Here on the right side you can see a real-life example. So that's from one of the underwater cameras. And you can see how dirty the lens is. And that's just get worse and worse. So sometimes they have to send people down, divers, to clean the lens before the whole operation can continue. So for the training data set, we need to first select the images that we trust, and then we have to label them. So the labeling itself, in most of the use cases, not for all of them, but for most of them, happens in multiple steps. There should be someone identifying objects, that there is something here, and then another group of people with the domain expertise can then say, yeah, that's this kind of fish, or that kind of crab, right? So we need 2 groups. One is, I don't know, the students or whoever does the object recognition, but that doesn't need the domain knowledge. And then the second one who needs the deep domain knowledge. Another finding is that some of the use cases, especially those that work with these pre-designed hardware for high throughput image taking, need multiple steps in the whole workflow. What they want is to really automate and speed up the whole process from taking the water out from the ocean to getting the classified images, objects, deposited into an open access database. And that whole pipeline has several steps in which the AI part is just in the middle at some point. But what they want to maximize is the throughput on this whole pipeline. So we need to work with the larger ecosystem of open science and data repositories and deposition and image segmentation in the beginning. The regular exchange of information is important, and that's the real value of this project, that it not only brings together 8 use cases that are slightly different, I mean, why they are all from aquatic sciences, but it also brings together the scientific community with the AI for community and then with the IT community or IT providers from EGI. So there are these 3 layers of expertise working together. And Valentin is the one running the bi-weekly course or leading those courses with the communities. And another last lesson so far is that filling out manpower gaps is a bit hard. This expertise is really scarce these days, really hard to get enough people to fill up all the positions, basically. So far, these are the lessons we learned. And if you want to know more, then you can read the documents I pointed to, or if you happen to work in aquatic sciences and you have similar problems or similar needs, then now the project opened a call that we can onboard additional use cases for support, and let's grow together and go together in understanding how AI and machine learning can help in image analysis in aquatic sciences. So we offer you help, human time, plus this online platform and the regular expertise sharing to scale up and run the models. Thank you. Yes, go to dinner and dance.
In 4 minutes.
Yeah, okay.
That is 15 or 15 minutes
Yeah.
far. But no.
About the?
The dinner, where is it?
Where is the dinner? That's a good question. If you have this application,
Wow, yes.
then there was a message sent earlier. I can tell you if I find this. Yeah, probably. Okay. Can someone tell? Just follow the crowd, I guess. I don't know. I don't find it, of course, no. Yeah, it's Mlinska 12. I don't know if I can edit it here. No. I don't know.
I have one way here, probably. There is a message. I would like to thank the speakers and the audience. And the remote speaker. Message. I can find the messages.
Go to the agenda. In the agenda, you have the winner is the last one, and you have the it's this Milinska 12. That's the place.
Yeah, I know, but I can find it in this link. Huh?
No, go back to the and copy this Milinska 12 for this.